Hello everyone, welcome to the Tableau Full Course by Intellipaat. Tableau is one of the most powerful and fastest growing data visualization tools used in the business intelligence industry today. It's known for its ability to turn raw data into easily understandable visuals and interactive dashboards with minimal coding. As per recent job market data, there are over 70,000 Tableau job openings worldwide. In India alone, companies in sectors like finance, healthcare, retail, and technology are actively hiring Tableau professionals. The average salary of a Tableau developer in India is around 8 LPA, with potential to earn much more as you gain experience and move into roles like data analyst, BI developer, or data visualization expert. So, what is Tableau exactly? Tableau is a visual analytics platform that helps you see and understand your data. With Tableau, you can connect to a wide range of data sources, whether it's an Excel file, a SQL database, a cloud platform like Google BigQuery, or even web data, and create beautiful dashboards and visualizations that help in faster and more effective decision making. What's great is that you don't need to be a programmer to use Tableau. Its user friendly features allow anyone to build and publish dashboards with just a few clicks. If you're someone who wants to stay ahead in the ever evolving data industry, learning Tableau is an absolute must. And to help you with that, we at Intellipaat have carefully crafted this free Tableau full course. This course is taught by top 1% industry experts who will walk you through everything from the very basics of Tableau to building advanced dashboards and performing complex data analysis. I'm confident that if you stay with us till the end of this course, you will not only understand how Tableau works, but also know how to apply it in real world scenarios. And yes, you'll also get to work on a real world Tableau project, giving you practical hands on experience. Now that you have a clear idea of what to expect, let me take you through the agenda of this course. First, we'll start with understanding what Tableau is and dive into what data visualization really means and why it's important. Then we'll take a look at the different Tableau products available and move on to the installation process and interface setup to get familiar with the tool. Once we're comfortable with the interface, we'll explore the data pane and metadata grid in Tableau to understand how our data is structured within the platform. Next, we'll learn about cleaning and reshaping data for analysis, ensuring it's ready for meaningful insights. We'll also cover the different file types and data structures supported in Tableau, helping us make informed choices when importing data. After that, we'll dive into the two main data connection types, live and extract connections, and understand when to use each. Then we'll move on to how Tableau handles multiple data sources by exploring relationships and joins. Following that, we'll learn how to use filters for data exploration, allowing us to focus on what matters most. We'll also cover how to create sets for custom groupings and deeper segmentation of data. After sets, we'll unlock the power of parameters to add dynamic elements to our dashboards and visualizations. And finally, we'll wrap up with dashboard actions, which bring interactivity to our reports and make our visualizations truly engaging. I hope I've made myself clear with the agenda, so without wasting any more time, let's take up the very first topic on our list.
Currently, the most popular tools for visualizations, data discovery is Tableau. So let's explore. Nike is the world's biggest athletic footwear company. It has retail outlets throughout the world. So, for a company like Nike, in order to understand what are the top selling models, which is the best time for sales in each region, what is the top customer demographics, how discounts affect sales, what marketing and sales initiatives work best in each geographic region, product segment and customer categories, all this and lots more need a lot of deliberation and a powerful tool called Tableau. So in this video, we are going to talk about what exactly is Tableau, what are the key features in Tableau, how does Tableau dashboard works, what are Tableau certifications, and finally, what are Tableau job trends. So let's begin. Tableau is a powerful business intelligence tool that is being deployed by a majority of the enterprises to make sense of different sources of data and convert into valuable business insights. Tableau has been voted as the best business intelligence and data visualization tool by none other than Gartner. So in the coming slides, we shall be learning what is Tableau, what is business intelligence, and finally, what is data visualization. So, how does Tableau make working so intuitive? Tableau brings in clarity even when you have humongous amount of data. You can easily categorize, connect, and prevail over data to get detailed, until now unheard business values. You can concentrate on patterns, trends, outliers, correlation, causation, and more. In comparison to other BI tools, some of the unique features of Tableau are apt visualizations. In Tableau, you select the data and switch between visualizations on the fly. It's easier to jump between visualizations in Tableau. Tableau visualizes data from the start, allows you to see the significance right away. Tableau differentiates correlations using color, size, labels, and shapes, giving you context as you drill down and explore on a granular level. Then it has got depth of discovery. Tableau gives users ways to answer questions as they investigate data visualizations. It can show basic trends as predictions, use what-if queries to adjust data hypothetically, and visualize components of data dynamically for comparisons. Implementation. Tableau provides a variety of implementation and consulting services for enterprise-level deployment. Automation functionality. So this one allows users to create custom formulas that are not available in most of the tools. And finally, data source connectors. This offers hundreds of native connectors to easily pull, cleanse, and correlate data from practically any source without having to create custom code. So just anybody can use Tableau regardless of their technical proficiency. It is accessible on any device and the results are crystal clear for anybody to understand and implement at any time. This is the power of Tableau that can help enterprises come up with true business values. Big data is fueling business intelligence. Today, we are in a data-driven world where 90% of the data has been created in the last 2 years alone. Data comes in all sorts of varieties like spreadsheets, database, cloud-based data, big data, and many more. And Tableau can intuitively connect with any type of data and make sense out of it. Some of the highlights of Tableau are as follows. So you seriously need no technical knowledge or background to work with Tableau. It can offer you any answers regarding your big data questions. You can access Tableau anywhere, regardless of the device type and the operating system you are using. And it is possible to tell your data story using the powerful Tableau dashboard. So let's now understand Tableau a bit deeper. Tableau is one of the best data visualization tools that helps to understand the importance of data by converting it into graphs, charts, maps, patterns, trends, correlations, and many more. Tableau lets you convert data into intuitive dashboards. It is possible to explore data all on your own. Thanks to the power of Tableau, you'll be able to quickly and easily understand hidden relations, patterns, outliers, and derive valuable and actionable insight. Rather than pouring through large amount of data, you can come up with stunning insights by visualizing the data just like this. You can create Tableau dashboards in minutes through simple applications of drag and drop of data feeds. You don't need any technical knowledge for exploring and building of Tableau dashboard. So after this, let us start a practical example of it. So let us see how to connect with Tableau and how to create visualization using data source. So once you have installed Tableau, so this is the first instance you'll be seeing once you double click on it. So you can simply connect with any of these data sources according to the data source available based on your requirement, that is either it is a flat file or it is a server related database. You would be able to connect with any of the data sources. You also need to have saved data sources, sample superstore and the other data sources which you can directly double click on it and use it for your learning. So I'm going to connect the same sample superstore but through here this Excel connectivity. So let's do it. Here I'll click on Microsoft Excel. and simply I will connect to the sample superstore. So here, go to here, module 1 sample superstore. Okay, so once you have connected, you can drag the required tables. So each table you are dragging in should have the connectivity, that is, relationship in order to use these joints. So the entire thing is called workbook. I hope it is clear. Now here we'll click on the sheet 1. We have connected to the sample superstore data set, and you can see the dimensions and measures based on this data set. So I'm going to create the visualization for customer versus sales. Okay, so here I have dragged customer name. Now I'll be dragging sales, right? And you can see it has come in this graphical way, and simply go and rename it. So we can rename it by saying my first visualization. Okay, now we have to simply save it. So go to file, save. Now you can save it either in TWB extension or TWBX, but it is advisable to save in TWBX extension if you want to make your graphical display public. Okay, so we'll save it as introduction and then save. So see how easy it was to create a pictorial representation of customer versus sales, right? So let us move ahead. So now Tableau offers 5 main products: Tableau Desktop, Tableau Server, Tableau Online, Tableau Reader, and Tableau Public. Using a combination of all these Tableau components, you can come up with visualization that can ring in the case register for any business enterprise. Now, people who are either a Tableau qualified associate or certified professional have proven expertise, confidence, and differentiation amongst others. The two important certifications of Tableau are Tableau Desktop Certification. It is suitable for analysts and data visualization professionals who are expected to design and create Tableau dashboards. Tableau Server Certification is for database administrators, IT, and BI professionals involved in the data layer administration of existing and ongoing Tableau reports. So each certification stream consists of qualified associate. It is a prerequisite exam for professional certification. The official recommendation is to have Tableau experience for more than 5 months prior to attempting the exam. Then we have got qualified professional. This one is the actual exam that will give you the designation of certified professional. According to guidelines, you will have at least 11 months of Tableau experience prior to attempting the exam. And finally, Delta examination, which is a way to renew your certification once a new version of Tableau comes out. All this makes Tableau professionals some of the most sought after individuals in the business intelligence domain. So, if you are also interested in learning Tableau and want to work for a big MNC and provide incisive and analytical reasoning and command top-notch salaries in the process, so check out these Intellipaat Tableau Business Intelligence training now. So all these are the courses related to Tableau that we here at Intellipaat provide you to secure your career and give you wings to fly high.
Just a quick info, guys. Intellipaat offers a Tableau course. Through this course, you will learn various techniques like connecting to data, transforming data, working with calculations and expressions, visualizing data, and much more from the top industry experts. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth.
Okay, so let's start with some theoretical points related to Tableau. Okay, so I'll let you know theoretically what this product or this software is all about, a few theoretical points which will give you some basic idea, and then we'll slowly get into the software. We'll open up the software, and we'll see how the user interface looks like, how to start working with the software, and so on. Okay, right. So Yeah. Now, Tableau, whenever you go in search of what is this product all about or what is this software all about, there'll be two phrases that pop up. Okay. Tableau is a powerful business intelligence tool, and Tableau is a data visualization tool. Right? Now, why do we call it as a powerful business intelligence tool? Now, you have this software using which you can you can get answers for different questions related to your business. Okay, so why do we have to, ask questions about our business? Now, the reason is, as in the whole point of using this software is for improvising the performance of your business. Now, how will you improvise the performance of your business? Only when you understand what is currently happening, what measures can be taken, so that in future I can make sure I'm taking some steps. Might be I'm taking some measures in order to cut down the unwanted costs. Make sure we are in in level with the demand of products, of certain products that are normally out of stock in our store. So you can analyze your data, understand your data, take measures accordingly, such that in future you will have some improvisation that's seen in your business performance, right? So that's why we call it as a powerful business intelligence tool. And data visualization. So normally we have data in the tabular format or might be in a comma separated format, right? You have it in the form of tables stored in databases. Now, when you're handling tables as in rows and columns of data, okay, it's going to be really difficult to analyze or fetch information that you're particularly looking for. Correct? So what Tableau does is it lets us convert tabular data into graphical representations, basically into charts and graphs, after which it becomes very easily to analyze or to look into some specific information that you're actually trying to that you were actually trying to look for. Yes. So within a few seconds, using the drag and drop technology, Tableau lets you visualize your data or convert your data into graphical representations. Okay. And from which understanding the data becomes very, very simple, right? That is what is data visualization. So having tables of data, it's going to be tedious and time consuming for you to fetch some specific information that you're looking for, right? Just imagine if you have millions of rows of data, fetching specific information will become very, very difficult, right? But when you make use of Tableau, within a few seconds, it lets you convert that data into graphs and charts, making it easier for you to get answers or to know more about your data or analyze more about your data, right? So we have a lot of benefits when it comes to data visualization. Now, again, a very common question that will pop up in your mind is, what is the scope for Tableau developers? So you're planning to invest some time, during this learning process, you've enrolled for the course. So there should be some benefit out of it, right? There should be some scope or there should be some usage of why we are spending so much of time, you know, you're putting so much of effort to learn something new. So what would be the end result of it? That's the general question that we all have, correct? Now, when it comes to the scope of Tableau developers, or what will I gain, or where can I exactly look for jobs once I, complete this course, or once I finish this course, right? In which sector should I look for jobs specifically? This might be the common questions that you might have, right? Now, the advantage of the software is it's a data visualization software. Wherever you have data, in order to analyze the data, in order to visualize the data, we may make use of these softwares. Now, where do we have data? Data is present everywhere, right? You take a school, you'll have data. You'll have student data, staff information that has to be maintained. Hospital, you have patient information, list of doctors, incoming patients, outgoing patients, list of medicines, available in stock, or list of medicines that we may have to purchase, or order for a lot of information, basically data that has to be managed and maintained irrespective of the sector. You take an automobile sector, you have data that has to be managed and maintained. You take a store, you take any domain, banking sector, retail, pharmaceutical, wherever you go, you have data everywhere. And wherever you have data, data has to be analyzed, managed, and maintained in order to improvise the performance of their business. And that is where we as Tableau developers have great scope. Irrespective of the sector, you will have great scope for Tableau developers, right? So a little about how helpful data analytics is going to be, how helpful visualizing your data is going to be. It is going to lead us to take better decisions, understanding the data, and also take decisions accurately and quickly, right? Right. So data visualization leads us to take better decisions, understand your data, and most importantly, your decisions can be taken accurately and quickly, right? Some real-time scenarios, as we just now discussed, a hospital, a store, any sector you may get into, you will have data present that has to be analyzed and visualized to understand your data, right? Now, this is how a dashboard created using Tableau will actually look like. I mean, this is just a sample, okay? Just to give you a visual idea how a dashboard created using Tableau can look like or will look like. Okay, now right from today, we'll be coming across a lot of new terms related to Tableau, right? Dashboard is one of it. But again, you'll be having a lot of new terms that we'll be coming across. I'll be using them very often in our sessions. You'll gradually get familiar with them. Okay, there's no need for it, to make any effort to remember them as such, because almost in every session, we'll be using them again and again and again, and you'll gradually get familiar with them, right? So dashboard is one such term. Dashboard is nothing but a collection of worksheets, right? So you have multiple worksheets over here. Worksheets are nothing but charts. You have a stacked bar chart, you have a pie chart, and then you have a few other bar charts over here. Okay, so when you place multiple worksheets in one common space, that becomes a dashboard. Okay, it's like a notice board that we have. You have multiple circulars over there. One related to the sports event in your school, one related to the annual day, one related to the exam timetable, exam results, right? So you have different circulars put up in one single space, and that becomes a dashboard, right? So similarly in Tableau, you have multiple worksheets that are put together in one space. That is what is known as a dashboard. And this is just a picture of a sample dashboard that's given over here for you to have just an idea. But every aspect of the dashboard is customizable based on your requirement. You can add logos of your organization. You can customize the colors. You can decide what type of chart you are planning to use to visualize the data. Okay, the font, the text, the placement of your charts, every minute aspect is customizable when you build your dashboard. Okay, right? Okay, Tableau is an interactive BI tool, business intelligence tool used for data visualization. It was founded by an American software company in Jan 2003, which was almost more than 2 decades ago, right? And it's an easy to learn, easy to use tool. It uses the drag and drop technology. Okay, and a very important point over here. Tableau stores data in the RAM, or the random access memory of your system. Okay. Now, first of all, Tableau is a data visualization software. So is there any prerequisite, for us to start working with Tableau? Now, point one is that there's no need for any coding knowledge in order to work with a software, because that's a general question that we might have. So are we supposed to sit and write pages and pages of codes, debug the code, look for errors, syntax errors, debug them? Do I have to sit and write codes if I'm planning to use Tableau in future? Right? The answer for that is no. No coding knowledge is required, and even after you get into the software, there'll be very minimal code that you might have to write, calculations that you might have to create, and that too depending on your requirement. It's definitely not mandatory, right? The syntax, options to debug, everything will be taken care by Tableau. Tableau will help us in doing all that. So the answer for that is no coding knowledge is required in order to work with Tableau. And if at all there are requirements for calculations or simple codes that needs to be created, we do have options in Tableau, which is going to make it very, very easy, right? The next point is that when you're planning to start working with Tableau, just the software is not enough. Okay, you should have your data in hand. Data in hand in the sense, you should have your data in the form of an Excel file locally present in your system, or you might have your data in the form of, let's say, tables stored in databases like SQL servers, Oracle, or any cloud like Snowflake, SAP, MongoDB, anywhere, right? So you should have access to data. You should have data in hand. So Tableau cannot survive by itself. It needs data connectivity. Only when you connect your data with Tableau, it is going to let you visualize your data, or it is going to help you in visualizing the data, right? So data in hand is the basic requirement. Then you should have your software, after which you can start connecting the data with the software to proceed with your visualization. Okay, Tableau is not capable of storing the data within itself. Now you have an Excel file, or you have a data that's connected, from a cloud or a server, right? Tableau will not be capable of storing the connected data within itself. It is temporarily going to use the RAM of your system as a cache to store the data. Okay. Now, when you look into other BI tools, now, yes, we do have many BI tools available in the market, and the most, popular one out of them is Microsoft Power BI. Then you have ClickSense, you have Zoho Analytics, and so on, right? So we do have many other data visualization tools or BI tools available in the market, and all those tools, store data in disks. Now, because of this particular point, Tableau has a better processing speed compared to all the other BI tools that store data in disks, because Tableau is using the RAM of your system as a temporary cache to store the data, right? So this is one main reason why we can justify that though there are so many BI tools available in the market, Tableau still stands on top, okay, because it has a better processing speed compared to the other BI tools. And again, if you're familiar with Microsoft Power BI, okay, there's another difference, that is normally felt when you make use of both the softwares. The user interface, right? When you look into the user interface of Tableau, it's very well organized, right? You have the features which are well placed, well organized, especially for a new learner. It's going to be very easy to use and easy to learn software. But when you look into Power BI, the environment, as in the user interface, is a little clumsy. You have all the features which are stuffed up in one single space. And as a new learner, it might take a little time to get used to the environment. It's not as organized as we have Tableau, right? Might be as we keep, moving forward, as we start looking into the software, you'll get an idea about that, what I'm actually trying to say, right? So that's that's one major point why Tableau is preferred compared to the other BI tools. And we also have kind of a survey that was done by the Gartner Magic Quadrant for business intelligence and analytic platforms, where compared to all the other BI tools, Tableau is standing right on top. Microsoft Power BI is very close to it, but still, it also depends on how comfortable you are with the software, right? And as I always say, people, as in students, normally ask, how do I, become an expert in Tableau, or how do I, become a well-versed Tableau developer? Now, the answer for that is, it's not enough if you're just going to theoretically keep learning the topics that we discuss, or, you try to go through the PPTs that is provided by Intellipaat, try learning the topics from there. That alone is not enough, right? You'll have to open up the software, look into the software, get familiar with the user interface, get familiar with the environment, right? Keep exploring the tools available in the toolbar, the options that we have in the menu bar, right? Just make sure you are exploring and getting familiar with the environment. Now, what happens if you're familiar with the environment? You get comfortable, right? You get comfortable as in you already know what each tool does. Okay, when you click on the drop down arrow mark, for example, these are the options that I am familiar with. So when you get familiar with the environment, you get comfortable. And once you're comfortable, you gain confidence. No matter what problem or project is put in front of you, you will be able to solve it. You will be able to come up with a solution for that in Tableau because you are familiar with the environment, you're confident and comfortable with the environment. So no matter what project comes in future, whatever the requirement is, you will be able to crack it down and complete it using the software. Right? So every single day, make sure you spend at least a little time opening up the software, going through the environment, keep using it, get familiar with it. That's how by the end of our course, you'll be able to become a well-versed Tableau developer, right? So I would like to give you an idea of what are the different products offered by the Tableau software company, right? So we have 6 different products: Tableau Desktop, Tableau Server, Tableau Reader, Tableau Public, Tableau Online, and Tableau Prep, right? We have 6 different products. Now, we are not going to go through, as in this entire course is only going to focus on 2 developer products. Okay, but still, I just want you to have an idea of what the other products are all about, what is the purpose of them, how do they differ from each other, okay, and in what kind of a scenario you may have to make use of them. So that at least a high level idea is what you should have about the different products that is offered by the Tableau software company, right? Just like how we have, if you take Microsoft Office, you have Excel, PowerPoint, Word, and so on, right? Similarly, these are the different products offered by the Tableau software company. And for explanation purpose, I would like to categorize them into 3 main headers. Okay, developer tools, then we have sharing tools, then we have our ETL tool. Okay, and this is just for our discussion purpose or for the explanation purpose. To make it a little easier, I'm categorizing those 6 products into 3 headers. Okay, developer tools, as the name tells you, tools or softwares that are used for developing or creating dashboards. Okay, the tools using which I can connect my data and convert my data into graphical representations, using which I build my dashboard or I develop my dashboard. Okay, such tools fall under developer tools, correct? So we have Tableau Desktop, then we have Tableau Public. These are the 2 developer tools that we have. Tableau Desktop is the most important one because when you get into any organization, as in, let's say you're planning to, you're given the role of a Tableau developer, right? So when you have a project that has to be, a dashboard has to be created, they'll give you 2 things. First, they'll give you the software, as in, might be the access or license for the software will be given to you. And the next one is access to the data, right? They'll give you the credentials required to access the data no matter where it is present, because only having these 2 as a Tableau developer, we can start creating our dashboard. What are the 2 things? First one, you need the software, and next you need the data, access to the data, right? So once you have these 2, you can connect your data with Tableau and start your visualization work. So Tableau Desktop is the most important developer tool that is used in organizations. Okay. Next, we have Tableau Public. Now, Tableau Public is also a developer tool using which you can create, develop your dashboards. Okay. And in fact, a very important certification exam question, or, by the end of our course, you will have a quiz that has to be completed there'll be a quiz given to you by Intellipaat, conducted by Intellipaat. You will have to pass the quiz with a certain marks in order to be qualified, right? So this is also another important question that comes in that quiz. Which is the only product offered by the Tableau software company that can be used both for development as well as sharing purposes? Right? So Tableau Public is the only product that can be used for developing dashboards as well as to share the developed dashboards. Now, first of all, what is a sharing tool? We know what's a developer tool, tools using which you can develop or create your dashboards, right? But what about a sharing tool? Once you have your dashboard that has been developed, you will have to hand it over, you know, to people of your organization. It might be your higher officials or it might be your client. You will have to give it to them, hand it over to them so that they can use your dashboard for analysis, right? So what's the purpose of developing a dashboard? To analyze your data. Right now, what I'll do is once we complete, this particular topic, I'll open up a real-time working dashboard. Okay, and I'll show you how well you can use your dashboard for analysis purposes, or anyone from your organization, how they can use the dashboard to understand your data, to take decisions to improvise the performance of your business. Okay, right? So that environment where you go share your dashboard is known as the sharing tool. Okay, now just imagine we have social media, right? We have different platforms, social media platforms where you go publish your content. Okay, uh, and that's how you are sharing the content with the public, right? So similarly, dashboards that are developed by us, as in we are Tableau developers, we've developed a dashboard, we will have to go publish it into an environment where people from our organization will come use our dashboard to understand the data. Correct? So that environment or that space where we go publish the dashboards after development is what is a sharing tool all about. Okay, right. So Tableau Public is used for developing dashboards and also sharing the dashboards. Correct? Apart from Tableau Public, we also have Tableau Server, Tableau Online. Okay, these are the other two sharing tools available through which you can share the developed dashboards with people of your organization. Right now, there might be a question that would come in your mind. Okay, see, we have Tableau Public, which is letting us do both, right? Tableau Public is letting us develop the dashboards, and at the same time, it is also letting us share the dashboards, right? Or it is also giving us a space through which, we can share the dashboards with people, where we can publish the developed dashboards, right? So it is letting us do both. Then why can't we just stick with Tableau Public? What is even the purpose of having all the other tools? When Tableau Public does both, why do we have to have all the other tools? In what way they differ from each other? Or when are we going to skip Tableau Public and make use of the other tools? In what kind of a scenario? Or what is the reason we may do that? Right? See, the point is definitely yes, Tableau Public is letting us do both, develop and share the dashboards. But as the name tells you, Tableau Public, right? Tableau Public has no security. Okay, see, when you develop and share a dashboard using Tableau Public, anyone from the public can view the developed dashboard. Are you okay with that? See, I mean, yes, we do have scenarios, but let's say you're working in a bank. Okay, you have the bank customer data, which is highly confidential. Correct? Now just imagine if you're planning to create a dashboard with this bank customer data and you make use of Tableau Public, anyone from the public is able to view the dashboard. They're able to view the confidential data. That's definitely not right. Yes, we will, I mean, as an employee of the bank, we will never let that happen. We don't want this kind of, a dashboard with that was created using confidential data to be seen by the entire public. We'll never be, ready to do such a thing, right? So that is when you need security, when you're working with confidential data, we make use of Tableau Desktop, because Tableau Desktop is highly secure. Okay, you develop your dashboard using Tableau Desktop, and then you make use of Tableau Server and Tableau Online, which are highly secured sharing environments. Okay, something like a gated community. Okay, suppose you developed a dashboard using confidential data. Okay, and your organization has a space, has an account on Tableau server. They have a small space just for employees who belong to your organization. They'll be given access credentials. Okay, so the people who belong to your organization using those access credentials will get into the server environment and see the dashboards that are published in that environment. So it's a highly secured space for sharing the confidential dashboards, right? So Tableau server is used for on-premises deployments, whereas Tableau online is a cloud. This cloud is managed and maintained by the Tableau software company themselves. So, as a part, as a part of our organization, we can go to the Tableau software company, we can rent a space in their cloud. Okay, we can rent a space in the cloud where, again, it's going to be highly confidential. Only people with proper access credentials can access that space that is used as a sharing tool for the dashboards of our organization, right? So normally organizational data is confidential, and they try to keep it secure, right? They're not ready to leak the data out to the entire public. So in such scenarios, Tableau Desktop will be used as a developer tool. Tableau Server and Online will be used as sharing tools. And that's why I told you, if you get into any organization, they will 100% use Tableau Desktop for development purposes, server or online for sharing purposes. Now, again, you will have a question. Okay, I understood this point. Then what's the whole purpose of having Tableau public? See, I'll once again show you. Tableau Desktop is used for creating or developing dashboards, okay, which is highly secure. Tableau Server is used for on-premises deployments, okay. And if you look into Tableau Online, it is used for cloud-based deployments. It's a cloud. Tableau Online is a cloud, which is managed and maintained by the Tableau software company themselves. Okay, right? Okay, I've understood these points of security and all that, which seems to be reasonable and fair. Then when will I use Tableau Public, or when should someone use Tableau Public, or what is the purpose when someone picks Tableau Public, right? See, Tableau Public is purely meant for practice purposes. Now, as you know, as in our during our sessions, now what are we doing? We are learning the software, okay? And we will be learning the software using some sample data, correct? So you have a lot of sample data sets available in the internet. Might be COVID data, or might be weather forecast data, or let's say you can go look for might be uh, metro train delays in my city, right? Or might be the bus routes in my city, or let's say what else, airport flight information of my country, right? You have different, or any hospital, general COVID data. Similarly, you have some for the past 10 years, what are the newly introduced medicines, top 10, such common public data is available all over the internet, right? So we'll be using such sample data to start working, to start learning the software, correct? That is when we make use of Tableau Public, because at this stage, are we ever, are we concerned about the security? There's no confidential data that we are going to work with, right? I'm okay with any data, any sample data that's available in the internet, because I'm just learning the software. I'm trying to explore the software. And you can just do nothing with the software. You will need some data connection, right? So for that purpose, I'm using sample data, right? So whenever we are practicing or learning the software, that's when we make use of Tableau Public, because Tableau Public is an absolute freeware, okay? Which means Tableau Desktop, Tableau Server and Online, they are paid softwares. You will have to purchase the license of these softwares. Your organization will do that for you. We needn't worry about that. But during practice sessions, when you're learning the software, we will be making use of Tableau Public. It's an absolute freeware. Once you download and install it, you can keep using it for free for lifetime. Okay, right. And whenever, again, the another point that I would like to mention is whenever you are practicing, you'll be creating some dashboards to just see how well you are able to come up with interesting dashboards, just testing your own skills, right? So whenever you do that, just make sure you are creating your own Tableau public profile. Just like how you have your social media profiles, you can very well have your Tableau public profile. Okay, so using Tableau public, develop some dashboards with sample data, and just it's like saving your work or publishing your work in your Tableau public profile. Okay, so if you keep doing that then and there, in after a certain point of time, you will kind of build a portfolio for yourself. Okay, right? You create your dashboard, you publish it in your Tableau public profile, and when you go in for interviews, you can share the link of your public profile, just like how you share the link of your LinkedIn profile or your Instagram profile. Similarly, you can share the link of your Tableau public profile with the interviewer, and that profile will speak for itself, right? So it'll be an opportunity for us to showcase our skills, okay, that through the dashboards that we've created using Tableau, correct? And after that, they might ask you questions, related to the topics or theoretical questions that you might have to answer, and all of that is definitely there, right? But still, this will act as an added advantage for you to showcase your skills, that you actually have worked with the software and this is a proof for it, something like that, right? So that's when Tableau public profile can be used, or that's the whole purpose of when we make use of Tableau public, both as a developer tool as well as a sharing tool. During practice purposes, we make use of Tableau public. There'll be another question in your mind. Okay, I'm using Tableau public to practice and all of that. But once I get into my organization, if they give me Tableau desktop, how will I know how to work with it? Will that be, will the user interface of Tableau desktop be something different compared to public? How will I, how will I know how to start working with Tableau desktop after getting into my organization? See, the point that you'll have to clearly understand is the user interface of Tableau public and Tableau desktop, they are 98% similar. Okay, 98% similar. Features, the way the environment looks, the way you create your dashboards, everything is just going to be as it is in both the softwares. Okay, both Tableau desktop and Tableau public. You hardly have 3 to 4 limitations in Tableau public, okay, which is again in no way going to affect our practice, our practice sessions. Okay, now the point that you can, the point that I'm trying to highlight over here is if you use Tableau public during our practice sessions, you will 98 or even 99% be confident with Tableau desktop. It's hardly 3 to 4 limitations that we have in Tableau public when compared to Tableau desktop, and one of that is no security. Tableau public has no security, right? But otherwise, the user interface, the way it looks, the way you build your dashboard, everything will absolutely be the same, right? So that's about Tableau desktop. And these 3 to 4 limitations, as we open up the software, then and there, I'll let you know that this particular feature is available in desktop, but not available in public, right? Very few differences between them. So I'll definitely highlight then and there when we start actually working with the software. Okay, right. Then we have server and online. Okay, and finally we have an ETL tool. Okay, ETL tool is nothing but ETL stands for extract, transform, and load. Okay, extract is nothing but you fetch your data from any server, cloud, or local file present in your system. You make some transformations on the data, and then you get the output, which is nothing but the transformed data. That is loading all about. Okay. Now, what kind of transformations can we do? Or in simple terms, we can call it as a cleaning tool or a cleansing tool. Correct? See, not every time we receive the data from the database team, it will be in a proper format to start with my visualization work, or it is not going to be in a clean format with which I can start my visualization work. Right? Now, it is going to be, I mean, you may have some garbage data, you may have some null values, you may have some unwanted spaces or punctuations present in your data, right? So some cleaning work that might be required before you start working or before you start visualizing your data, right? That's when we make use of these ETL tools. Now, Tableau Prep is the ETL tool of Tableau, or it is the cleaning tool of Tableau. So whenever you receive data from the database team, if you feel it needs some cleaning work before you start visualizing it, you can use Tableau Prep, clean your data, and then connect it with Tableau Desktop for visualization purposes. Again, it is not mandatory that you have to clean your data before connecting it with Tableau Desktop. It depends, right? If you feel your data is not clean enough, then make use of Tableau Prep. Otherwise, directly connect it with Tableau Desktop. And in fact, if you might have heard about, there are other ETL tools available in the market like Alteryx, Informatica. They are way too advanced ETL tools available in the market. But I would definitely say Tableau Prep is just 5% of them. It's a very basic ETL tool. Okay. Now, Tableau software company wanted an ETL tool, within their list of products so that people shouldn't go out looking for an ETL tool to clean the data. So they wanted an ETL tool within themselves, right? Within their in-house products. And that's how Tableau Prep came in. But yes, it is useful for some basic cleaning work, right? So yeah, that is Tableau Prep, or the ETL tool of Tableau, all about. We've covered almost, yeah. And we have Tableau Reader. In fact, Tableau Reader is not in use this used to be the only sharing tool available for developers through which dashboards were shared in the earlier days. But nowadays, we no longer make use of it. Okay, but yes, that was Tableau Reader, the only sharing tool available for developers in the earlier days, right? So now these are the different products that are currently being used in organizations: Tableau Desktop, Tableau Public, Tableau Server, Tableau Online, and Tableau Prep. Okay, ETL tool is Tableau Prep, or you can call it as the preparation tool. We are preparing the data so that we can start visualizing the data. So you're cleaning your data and you're preparing the data, right? That's how the name came in, Tableau Prep. Okay, so I hope now you have a basic idea about what each product is all about. Okay, and what is the purpose of what is the purpose of each and every product? A high level definition of idea is what you might have now. Okay, this course is completely going to focus on Tableau Desktop and Tableau Public, as in the developer tools is what we are going to focus on. Okay, so I'll just open up the software. So this is how the start page looks like. Okay, so this is going to be Tableau Desktop Professional Edition. Okay, see, mine is 2024 2024 2.2 version. I still haven't updated mine. We have 2025.1. If you look into the right bottom corner of my screen, you have 2025.1. Okay, the reason I was just waiting is I wanted to show you if at all there's a new version that is being launched, we needn't go keep a track. Okay, I have to update my software, there's a new version that has been launched. We needn't go keep a track of that, because the start page, the right bottom corner of your start page, will give you this pop-up letting you know that, okay, there's the next version that has been launched. So make sure you update yours to the latest version available in the market, right? I am currently in Tableau Desktop Professional Edition. This is Tableau Desktop. Okay, right? And we have the latest version, 2025.1. And frankly speaking, there'll not be much differences between these versions. There'll be some patches done or issues resolved in the backend from the backend perspective, but we'll not be able to see that or see any difference in the user interface perspective. It's very rare that changes happen in the user interface perspective. Okay, right? Yes, this is the licensed version, Tableau Desktop, that normally is being used in all the organizations. Okay, this is Tableau Desktop Professional Edition. I'll also open Tableau Public. See, this is Tableau Public. Just click on Help and just click on About Tableau Public to know the version, right? See, this is Tableau Desktop Public Edition. That was Tableau Desktop Professional Edition. This is Tableau Desktop Public Edition, and in short, we call it as Tableau Public. Okay, again, my version is 2024 2.2, but we have the latest version. The right bottom corner tells you 2025.1.0 is the latest version that we have. Just click on the pop-up to update your software to the latest version. Okay, right. So now we have both downloaded and installed in the system. If you only have Tableau Public, no issues at all. That is more than enough for practice purpose. Okay, but I should show you how they differ from each other, right? So that if you go into an organization in future and you've given Tableau Desktop, you shouldn't feel there's something new in Tableau Desktop. I haven't seen this at all. You shouldn't get that feel, right? So that's the reason I have both, so that I can compare them if required and just showcase how they differ from each other and so on, right? Okay, so the first difference right in the start page itself, you'll be able to find one major difference between Tableau Desktop and Tableau Public. Okay, see, now I'm back into Tableau Desktop Professional Edition, the licensed version of the software. Okay, now we are into Tableau Desktop. Now, what do we know about the software? We have the software in hand, but can we do anything just having the software? No, we will need data, correct? You should have your data in the form of an Excel file that might be locally present in your system, or it can be a text file, it can be a JSON file, PDF file, and so on. Or you should have your data, just click on more over here. You should have your data present in any of these servers or clouds, right? See, Tableau supports more than 50 to, I think, more than 70 type of databases and clouds, servers and clouds, from where data can very easily be connected with Tableau, right? See, normally organizations make use of huge data, big data, right? So big data is stored in servers or clouds, right? You name a server and you'll have it in the list over here. See, you have Amazon Redshift, Azure, you have what else? You have Databricks, you have MongoDB, you have MySQL, you have Microsoft SQL Server, you have SAP, Salesforce, Snowflake. You have such a long list over here, right? So wherever, whichever cloud, whichever server, whichever database your data might be stored in, you can very easily connect it with Tableau to proceed with your visualization work. Okay, this is about Tableau Desktop, correct? Let's open Tableau Public. Okay, see this left side connect pane. Okay, just click on more over here and you'll be able to see these are the only places, or these are the only file types from where data can be connected with Tableau Public. Okay. Do we have server and cloud connectivity that's possible with Tableau Public? No, it's not possible. And this is one main reason, or this is another main reason why organizations do not use Tableau Public, because organizational data is usually huge. It is stored in servers and clouds, but Tableau Public is not capable of connecting server or cloud data with itself to proceed with visualization. Correct? Yes. So Tableau Public is limited to data. But when we are practicing, we'll be just using Excel files or text files locally present in our system to get to know about the software. Correct? So for practice purpose, Tableau Public is more than enough, but Tableau Public is limited to data. Server and cloud connectivity is not possible in Tableau Public. Okay, right? Fine. Should we have knowledge about SQL in order to work with Tableau? Because SQL is, considered to be whichever job, or any IT job you get into, they consider SQL as a basic skill. Okay, so with that in mind, if I'm planning to work as a Tableau developer, is SQL skill mandatory? Am I going to use SQL anywhere, or should I have SQL knowledge if I'm going to go attend an interview for a Tableau developer? Okay, now, frankly speaking, it's definitely, as an SQL knowledge to work with Tableau is not compulsory or mandatory, is what I would say. Because if I'm having if flat files is what I'm going to work with, Excel files or text files, why will I need knowledge about SQL? Or let's say my organization is storing its data in Azure, okay, or might be in MongoDB or SAP. I might not need SQL queries. I will not be required to have SQL knowledge, because I can simply connect the data from any of these servers or clouds with Tableau and start my visualization work. Okay, but sometimes if you're connecting data from an SQL server itself, okay, you can write simple queries, okay, to fetch only limited information. Select star from so and so table where country equal to India. Okay, or again, if you're using Databricks, sometimes you can use SQL queries to limit the data that you're trying to pull or connect with Tableau. But we do have other options called filters in Tableau, okay, using which you can limit the amount of data that is getting connected with Tableau. So I would say it's definitely not mandatory to have SQL knowledge in order to work with Tableau. Okay, when you're writing calculations in your as an inside Tableau, also there's no need for SQL knowledge. Again, for Amazon Redshift, if required, it's optional, right? Even when you're working with SQL Server or any other server or cloud, it's purely optional. If you want, you can use SQL queries, but frankly speaking, we don't see the necessity of using SQL queries in Tableau at all, because we do have other ways of limiting the amount of data that can be connected with Tableau. We have features in Tableau that lets us do it. So we generally don't prefer, or we haven't used, SQL queries within Tableau. But again, I'll tell you something. See, when you go in for interviews, you can justify, you can just justify this particular point, telling them, see, even without SQL knowledge, we can definitely 100% survive and work with Tableau. It's actually not required, but sometimes they do not accept it. This is from my experience that I'm just telling you. Okay, I had this experience where might be the person was new to Tableau, so that interviewer was more comfortable with SQL. So there were a lot of questions that were related to SQL, and they were trying to justify that, as an IT person, we should have SQL as a basic skill. This was 10 years back. Okay, so that was something that few of my other, friends also did come across. So it's I mean, as from a general perspective, what I would suggest is it's not required that you should be an expert in SQL, writing SQL queries, but just make sure you are aware of the basic stuff, like basic commands, all the, select statements, where clause, having clause, group by, order by, all the basic commands. Just make sure you're aware of it, a decent knowledge about SQL. In case they question you, you can just tell them, see, I have some basic knowledge, but I haven't had an opportunity where I was involved into a lot of writing SQL queries, but might be given an opportunity in future, I can definitely develop my skills. So that way you can manage, instead of telling them I have no idea about SQL queries or SQL commands that we have, right? But to put up, I mean, to conclude, or to summarize, to work with Tableau, there's definitely no need for you to have SQL knowledge. That's the final point. Okay, right. So this was about the first difference between Tableau Desktop and Tableau Public. Tableau Public is limited to data, right? Okay, so now we have the software in hand. Can we start working with it? No, we should have some data as well. Okay, so if you get into the folders that are provided to you, if you get into module number 1, get into the folder called data set, and that is where you have, that is where you will have an Excel file called sample superstore. Okay, this is going to be the sample data that we will be working with. Almost 80% of the topics that we have in our course will be discussed using this sample superstore data. Okay, it's a normal Excel file with 3 sheets. You have orders, returns, and people. Okay, see, there are 3 sheets in this Excel file, and the first sheet is the most important one. Orders sheet, it has around 21 columns, which has, see, the data is about sample superstore. It's a store data, orders made in a particular store. Okay, order date, shipping mode. Then you have all the customer related information, product related information. Okay, and then you have the sales done, the quantity sold, and then what else? Profit, discount, and so on. Correct? The customer location related information and all of that. So this is a detailed sheet called orders, and it has around 9,994 rows of data, approximately. I mean, nearly 10,000 rows of data is what it has. So this is going to be one of the most important sheets using which we will discuss around 80% of the topics that we have in our, as in throughout our sessions. Okay, now where did we get this data from? I mean, is it available in the, I mean, it's definitely available in the internet, but who prepared the data basically? Who's the owner of this data, right? See, Tableau software company, they very well know that a person who is, downloading and installing the software will be a person who is planning to learn the software, or there'll be a person who will be completely new to the software. Okay, and for such a person, how will they start exploring or learning the software? They should have some data in hand, right? So what the Tableau software company does is they prepared this Excel file, and when you download and install the software, they are giving you the data set called sample superstore along with the software, telling that, okay, you're downloading the software, you will need data to start working with the software. So here's the sample data. I'll give you the sample data for you to explore and learn the software. So this Excel file was prepared and provided by the Tableau software company themselves, using which we can practice, explore the features, and build dashboards using the software. So this is going to be the data set that we will use in our upcoming sessions. And apart from this, we'll be using some smaller data sets here and there that I've prepared to discuss certain topics to make it easy to discuss and to understand certain topics. I've also prepared some smaller data sets apart from the sample superstore one. I'll provide all of them then and there during those sessions. Okay. So yes, that's about the data set. So we have the data in hand. This is an Excel file locally present in our system. And we also have the software in hand. Why wait for? All we have to do is what next? Connect the data with Tableau and start with your visualization work. That is what we will have to do. Okay. So before we start connecting the data and all of that, I wanted to give you an idea of how a complete working dashboard created using Tableau will actually look like. Okay, see, sometimes your learning process will become even more interesting if you get to know how the end product can actually look like. Okay, you'll have the enthusiasm to learn how did this particular dashboard, how was this dashboard created, what were the features used for creating that dashboard. I'm interested in learning about it, right? So that's when the journey becomes even more interesting. So for that reason, I'll just type Tableau public gallery. You can just type Tableau public whiz gallery, Google for it, get into the first link, and this is the Tableau public whiz gallery, where there'll be a lot of people, Tableau experts and enthusiasts all around the world who've used sample data sets, public data, to create interesting dashboards to showcase their skills, or might be to, it's just that's how uh, enthusiast they are about the software. They are so much interested in exploring and creating interesting stuff using the software, right? You can just go through these dashboards whenever you have time, right? As of now, we'll pick up one sample dashboard. Okay, just okay, might be how peaceful the world is. This is one dashboard available in the available in the Wiz gallery. How peaceful is the world, right? See, you have different chart types using which data can be visualized in Tableau, and map is one of them. Okay, it's not necessary that you'll have to only stick on to bar charts and pie charts. You have interesting charts that can be used to visualize your data. You have maps, okay, and this is a slider. We call this particular feature as a filter, right? Because see, as a random end user, what am I doing? I'm interacting with the dashboard, correct? See, I'm telling the dashboard, give me data related to 2012. So what would happen is the dashboard will get updated. See, the dashboard will get updated, giving me information about whichever year I had picked in. You can just look into these values and the map. When I change the filter, okay, the values change, the map changes, because data is getting updated according to whatever selection I make over here. Okay, might be you call it as a filter or you call it as a parameter. We have different features using which you can interact with your dashboard, right? Or let's say I would like to know only about Asian countries, right? So I've selected Asia. So this list over here will display only countries that belong to Asia. So what are we trying to do over here? We are trying to apply a filter and focus only on countries related to Asia, right? So we are interacting with the dashboard. We are telling the dashboard, see, give me only this particular information, or I would like to focus only on so and so information. And accordingly, dashboard is updating itself, and accordingly, it is displaying whatever we had asked for. That's what interaction is all about. Okay, so this is a very common term that you'll be coming across even in interviews, right? Creating interactive dashboards is very, very important. Now, just imagine without such features called filters or highlighters or parameters, how will your dashboard be? It'll be static in nature. It'll be like an image. And there's no point in having a non-interactive dashboard. Why? Because the ultimate aim of creating dashboards using Tableau is for letting people to analyze data based on their requirement. Correct? You might be multiple people, as in board of directors or higher officials in your organization. They'll be having different perspectives of analyzing the data. right? So only if your dashboard is interactive in nature, they can analyze the data based on their perspective to come up with different solutions to improvise the performance of your business, right? So it's very important for your dashboard to be interactive in nature, and this is what interactivity actually means. Okay, and we have a lot of features in Tableau that will make your dashboard interactive, like filters, parameters, actions, and so on. Okay, we'll be going through all of them in detail in our upcoming sessions. Okay, but this, I mean, see, this is not to confuse you. You know, there have been comments in the past telling that right away in day one, I showcased a dashboard and that was confusing for certain participants or for some participants, but that's not what we are. I mean, to confuse you is not my motive. I want you to have an idea of how interesting, Tableau can be, how interesting dashboards, yeah, how interactive and creative, you can get when you're making use of Tableau. That's something I wanted to open up. Okay, open up your creativity and your enthusiasm so that you'll be very keen to get to know about how did this particular person create such a dashboard, what were the features that were used for creating such a dashboard, so that keen interest would increase is what I felt. Correct? Whenever you have time, you can just go through this and go through this particular gallery and just get an idea how Tableau is a superpower, right? So how well we can make use of it. That's the whole idea about it. Okay.
Just a quick info, guys. Intellipaat offers a Tableau course. Through this course, you will learn various techniques like connecting to data, transforming data, working with calculations and expressions, visualizing data, and much more from the top industry experts. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth.
Okay. When you're learning the software, when you're exploring, we may need different sample data sets from the internet, to practice, as in to explore how to use or create dashboards using Tableau. Now, sometimes, where do we go search for sample data sets, right? So there was a question about, do we have any community or do we have a link where we'll be able to get different data sets, sample data sets or public data sets using which we can, keep exploring the software, keep, working with different data sets, try creating different dashboards, and you can keep adding them to your Tableau public profile. Correct? So one such space from where you can get sample data sets is the Tableau public whiz gallery itself. Okay, you can just get into any one dashboard that is published right here. Okay, just get into any dashboard and you have an option to download the dashboard. Okay, so there'll be a download button on the right top corner. Just click on download and you have different options. Select your file format, right? So you can download this dashboard as an image file, or you can download the data behind it. Okay, you can download it as a cross tab in an Excel file, download it as a PDF, download this particular dashboard as a slide in your PowerPoint, or download it as a Tableau workbook itself, right? When you download it as a Tableau workbook, you can open up the workbook and check how the developer has created it. What are the features? What are the calculations? What are the different options used from a developer's perspective can clearly be, figured out when you download this dashboard as a Tableau workbook. Right now, using what file type my Tableau workbook will be downloaded. We'll be getting into those topics, just like how we have .xlsx for Excel files, .txt for text files. You have different file extensions. right? If you think about an image, it will be .png or JPG. These are the file extensions for image files, correct? Similarly, what will be the file extension using which my Tableau workbook will be saved, right? We have different file extensions in Tableau. Each has its own purpose. So we'll be going through all that in our upcoming sessions. That would be our upcoming topics, right? If you download it as a Tableau workbook, you will not only get the dashboard, but also the data based on which the dashboard has been created, right? See, it's like Tableau cannot survive by itself, or the dashboard cannot be brought into view just by itself. It is completely dependent on data connectivity. Yes, so whenever you download this dashboard as a Tableau workbook, it will be downloaded along with whatever data is being used. Only then the dashboard can be displayed in the front end, right? Because it depends on data connectivity. So we have a lot of technical points related to this upcoming. So might be that's when you'll get a better clarity. But anyways, when you're looking for sample data sets, you can very well use Tableau Public Viz Gallery, get into any dashboard, and if you feel it is interesting, I need the dashboard as a Tableau workbook to explore more about it. I'm keen to know how they came up with this kind of a dashboard. You can just download it as a Tableau workbook and just go see what kind of features they've used, how worksheets has been built to come up with this kind of a dashboard. So we can literally go analyze all of that by downloading it as a Tableau workbook. Or if you just need the data, you can download the data as it is, right? So you have the download button on the right top corner of any dashboard, right? So you can just click on that download and select the file format in which you would like the data or the dashboard to be downloaded, right? So that was one point. Okay. We do have sample superstore in hand, correct? This data set called sample superstore. It's an Excel file with 3 sheets: orders, returns, and people, correct? 3 sheets, and this is the data set that has been prepared and provided by the Tableau software company themselves. Okay, so you have the Excel file in hand, and what else? You have the software in hand, right? So we have both Tableau Public as well as Tableau Desktop in hand. So we have the software, we have the data set, and that's it. The next step is going to be, all you have to do is connect your data with Tableau and proceed with your visualization work. Okay, because when you get into any organization as a Tableau developer, these are the 2 things they'll provide. 1, access to the data, and 2, the software, right? With these 2 things, you can very well start with your analysis work. Okay, right. So now the start page, right? The left side space of your start page, this blue color pane, is known as the connect pane. Okay, you have to connect your data through the options provided right here. It can be the file types, or it can be the servers and clouds or databases, the complete list that's available over here. No matter where you have your data, you can very easily connect it with Tableau. Okay, we'll start with the sample superstore data that we currently have in hand. Right now, what file type is our sample superstore is? It's of an Excel file. It's a .xlsx file type, right? So it's a Microsoft Excel file, correct? So I'll have to click on Microsoft Excel because my data is present in an Excel file type. Okay, so click on Microsoft Excel and you just have to browse. See, the moment you click, you'll get a dialog box. You just have to get into whichever folder you wish to. Okay, wherever you have your data set. I have it under module 1, data set. This is where I have my sample superstore. So just browse, get into the exact folder, click on sample superstore, and then click on open. Okay, just click on open, and within a few seconds, you will be directed to a page known as the data source page. Okay, so within a few seconds, you'll automatically be directed to this page over here. The left bottom corner of the page is telling you the name of this page. It is known as the data source page. Okay, now what do we have in this data source page? We have sample superstore, the Microsoft Excel file that is connected with the workbook. And then you have three sheets, right? Orders, people, and returns. These are the three sheets that belong to my Excel file, correct? All the three are listed out right here. Yes, so which means our Excel file called sample superstore is successfully connected with Tableau. Yes, the moment you connect your data, you will, the moment you click on open, right? The dialog box opened up. I clicked on sample superstore and then I clicked on open. And after that, after a few seconds, you'll automatically be directed to this page known as the data source page, right? The same thing would happen if you're using Tableau Public. This is Tableau Public. We have the data which is in an Excel file type. So click on Microsoft Excel, click on the sample superstore file that you have within your system, and then click on open. Within a few seconds, you'll automatically be directed to the page known as the data source page. Okay, so this is not just for Excel files. No matter where you have your data, see, just click on this Tableau icon on the left top corner of your data source page to toggle between the start page and the current page that you are in. Okay, so by clicking on this Tableau icon, you'll always be taken to the start page, right? See, these are the minute things that you'll have to get familiar with. What every button does, what every tool does, what every icon does. You'll have to explore, keep getting familiar with the environment, and that's when you'll build confidence. Okay, right. So now what if I have my data in any server or cloud? This was just a local file from my system. So this is how, we easily connected it. But what about databases, as in data stored in the form of tables in databases, servers, and clouds? How do I connect them with Tableau, right? See, I'll tell you something. See, the way you connect your data might differ depending on the location where your data is present, right? The way you connect your data with Tableau might differ, but once connected, the way you work will absolutely be the same. Now, what does this mean? See, now we had an Excel file. So it was pretty simple. We just clicked on Microsoft Excel and there was a dialog box that popped up. So I went into the exact folder where I have my Excel file and then I clicked on open. I was just directed to the data source page. So my Excel file was connected with Tableau. Now, what if I have my data present in the form of tables in any server or cloud? For example, we have it in the Microsoft SQL server. Okay. Yes, so in my Microsoft SQL Server is where my data is present. So I'll have to click on Microsoft SQL Server and you'll have a dialog box that would pop up asking you for certain details, right? You have to enter the server name where your data is present, right? So the organization, as in your team lead, will give you these details. As a Tableau developer, we will be handed over with all the details required to access the data. So they'll give you the server. They'll tell you this is the server where we have the data and these are the credentials for you to access the data or access the server where the data is the data would be present. Okay, because they'll give you all these details as they know in order to work with Tableau, data connectivity is the basic requirement. So only if you have access to the data, you can connect it with Tableau to proceed with the analysis work, right? So based on that, they'll give you all the details required to access the data. So you'll be given the server name, your SQL server, where the data is present, and also the access credentials, the username and password to get into the server. Only then you can connect the data from that server with Tableau. Okay, so this is a small authentication step that happens when you have your data present in servers and clouds because they are secured environments. Okay, if I try connecting, let's say Oracle, okay, or might be SAP, Salesforce, or Snowflake, right? So just click on Salesforce, okay? You will have to log in, just sign in, or basically you will need the basic credentials to sign in to the Salesforce URL, okay? Only if you have proper access, the username and password, you can get into your organization's account where the data would be present. So this authentication step is important if you have your data outside the system in any server or cloud, right? And once you are through the authentication step, once you pass the authentication step, you will again be directed to the same page known as the data source page. So this is where you'll have the list of tables or databases present in your server, from which you can choose the table, choose the database, and start working with Tableau, right? Which means, as we've, as we just now discussed, the way you connect your data might differ. If it's an Excel file, it's pretty simple and straightforward. If it's data present in an SQL server, you may need the server name, the credentials to get into the server. Okay. If it's going to be data present in some other location, then you might need that respective credentials or server name or cloud name and so on, right? So the way you connect will slightly differ depending on where the data is present, okay? But once connected, once you pass the authentication step, once connected, you will always be directed to the data source page, from where the way you work in Tableau will absolutely be the same. There'll be no difference at all. Okay, so once you're into the data source page, Tableau is going to handle the data no matter where it is coming from, exactly in the same manner, such that once you're into the data source page, you start working, you start creating visualizations in Tableau's workspace, you will definitely find no difference whether you're working with a data from any cloud, any server, or whether it's a data that's locally present in a system in an Excel format. You'll not be able to figure out, or you'll not be able to find any difference as in from where your data is coming from, because Tableau is going to handle all of them exactly in the same manner, in a uniform manner, letting us work with no matter where the data is coming from in an absolutely similar manner when it comes to Tableau's workspace. The reason I'm trying to stress on this point is that this is a normal question that they try to confuse you when it comes to interviews. Let's say you've done a project with flat files, with Excel files or text files and so on, right? But the interviewer might try to, shoot you with a question that says, or that is like, see, you've been working with Tableau only by connecting flat files, only by connecting data from flat files. But when you get into our organization, we have our data present in Oracle servers. How will you be able to handle that? Okay, so that's just a question to check whether you are actually aware of this point, that no matter where the data is from, you will be given the access credentials. All you have to do is set up the connection. Once you're into the data source page, the way Tableau is treating the data, irrespective of where it is coming from, absolutely is the same, right? So you will have to answer that in great confidence, letting them know that, I mean, just because I've done my previous project with data from flat files, I've built my dashboards and all of that. But again, when I get into your organization, no matter where the data is coming from, you will be giving me the credentials. The question is about, you've done your project on Tableau previously. Okay, you've built some dashboards in your previous project, but where was the data coming from? The data was handed over to you in the form of Excel files, right? But now, when you get into our organization, we have the data stored in Oracle servers, right? So the location of the data, the file type, from where the data is going to be connected with Tableau is different, right? How will you be able to handle it? You've worked only with flat files connected with Tableau previously, but now we have data present in servers. Will you be able to handle it? You don't have that experience, as in you don't have prior experience about server connectivity with Tableau. So will you be able to handle it? This would be the question. It seems too complicated, right? But reality is not like that. I mean, reality is that it's very simple because, as I told you, the way you connect your data from different locations might have slight differences, because for Excel files, there was no need for any authentication step, right? But when it comes to your data from an Oracle server, you might have to enter the server name, enter the credentials, pass the authentication step, and then you'll be directed to the very same data source page from where the way you work in Tableau will absolutely be the same. The way Tableau is going to handle data from Oracle server will be absolutely similar to how it had handled your Excel data, right? So you just have to be confident in your answer. They are just trying to test you whether this particular question is going to make you nervous, because it seems complicated, right? I've been working with flat files, but normally server data is huge. We have big data. So that particular point hits us and we tend to become nervous, right? But all you have to do is just be confident about this particular point, that no matter where the data is coming from, this project might give you data from an Oracle server. The next project might give you data from a Snowflake cloud or might be from SAP. That doesn't matter, because once it's just the way you connect data from different locations with Tableau might have slight differences, but once connected, yes, once you're into the data source page, the way you work in Tableau's workspace, the user interface of Tableau will just be the same, because Tableau is handling data from any location exactly in the same manner. So you needn't worry about that particular point. So that is the justification of these lines over here. The way you connect your data from any location with Tableau might have slight differences here and there. The way you connect might have slight differences, but once connected, the way you work in Tableau will absolutely be the same, right? So that's one important point I wanted to mention. Okay, so now you have your data in any location, you have the credentials, you've successfully connected, and you're being directed to the data source page, right? Now, suppose you have any server, any cloud, right? So you just click on that particular server or cloud, enter the credentials, and when you click on sign in, what would happen is it'll make sure your credentials are right. Okay, that authentication step will happen. It'll make sure the username and password is correct, and all of that, verification step, authentication step happens. And once it is successful, once it is all cleared, within a few seconds, you will be directed to this page over here known as the data source page. Okay, and this is where, just like how you have the list of sheets from your Excel file, you will have the list of databases present in whichever server you had connected. And from those databases, you can pick whichever table you're planning to work in Tableau's workspace. Okay, right? So I'll tell you how to then choose the table and proceed. You might have multiple tables in a database, right? How do I choose the table that I am in need of? Yes, see here we have sheets that belong to our Excel file. Okay, now you have orders, people, and returns, correct? As you go down the left bottom corner of your page, the first tab over here is the data source tab, and just right next to it you have something called sheet number 1. Okay, try clicking on sheet number 1. It will take you to the worksheet space of Tableau. Okay, worksheet space. So this is where we will literally be converting all our tabular data into graphs and charts. This is the space where we'll be visualizing the data. Okay, we'll be creating our charts and graphs in this space, and this is known as the worksheet space. Okay, but I don't see any column. So if you recollect, if you think about the orders sheet in our superstore file, we had so many columns over there, right? We have customer name, customer country, sales, profit, product information, and all of that. Only if I have those columns, only if I have data, I can convert it into graphical representations, right? but I don't see anything over here. Why so? Or what am I missing? Or what am I supposed to do in order to bring those columns over here so that I can start? Suppose I would like to see country-wise profit or state-wise sales. I need those columns, right? But I don't see any of them over here. What are we, or I mean, what are we missing, or what are we supposed to do? There's a small red exclamatory mark over here, right next to your data source name, right? The reason you have this exclamatory mark is that, let's go back to the data source page. You have the data source tab over here. You can toggle between the data source page and the worksheet space using these buttons or tabs. Okay, so click on data source, you'll be taken back to the data source page. Okay, now the reason why there was a red exclamatory mark over there were no columns based on which or using which I could, convert my data into graphical representations. The reason behind that was, I mean, though sample superstore is connected with Tableau, though there are 3 sheets that belong to sample superstore, you haven't dragged and dropped anything into your data source page. It says drag tables here to create a data model. It means you have to drag at least one table or sheet into the data source page right here. Okay, only then you'll be able to see the list of columns in your worksheet space, after which you can convert it into graphs and charts. See, we'll do that. Now this space, this blank space over here is known as the canvas area. Again, a lot of new terms that we'll be coming across. Okay, but we'll be using them again and again and again. You'll gradually get familiar with them. Okay, so this is our data source page. This blank space over here is known as the canvas area. Okay, so make sure after you've successfully connected your data with Tableau, drag and drop at least one sheet into the canvas area. Correct? Drag and drop at least one sheet into the canvas area. So I've dragged and dropped orders into my canvas area. Correct? Then what's happening? The bottom half of the page is displaying the rows and columns that actually belong to the orders Excel sheet. Yes, yes. Now this is known as the view area. Now how did we get this? This was how it looked initially after the successful connection. You have to drag at least one table, one sheet, drag and drop it into the canvas area of your data source page. If you do that, what would happen? The bottom half of this space will try displaying the rows and columns that belong to the orders sheet. Okay, this space is known as the view area. Why view area? VIEW, right? Why view area? Because we are able to view. Now, if you go back to your sample superstore, you'll be able to see. This is our orders sheet, row ID, order date. See, these are the complete list of columns that we have. There are 21 columns, okay, in the orders Excel sheet, right? So when you drag and drop orders into the canvas area, all those 21 columns are being listed out right here, and you have your 9994 rows of data. This is the space through which you're viewing whatever data is present in your orders sheet. Correct? So we call this as the view area, right? Now try going into sheet number 1. Okay, just click on sheet number 1. Now the left side space, see the red exclamatory mark near your data source name has disappeared. Okay, and the complete left side space over here is giving you the list of columns that belong to orders of sample superstore. See, these 21 columns from orders of sample superstore will be listed out into your worksheet space on the left side, using which you can very well visualize your data, right? Suppose if you need a state-wise profit, just drag and drop state into the column shelf. You can drag and drop your sales into the row shelf. You will get your state-wise sales. I mean, this is just an example, but we'll discuss more about, what is the column shelf, what is the row shelf, why is this blue in color, why is this green in color, and all of that. We'll slowly get into all those points, right? But as of now, all you have to understand is once you're into the data source page after a successful connection, you might have the list of sheets, you will have the list of databases. Under each database, there'll be a list of tables, right? Drag and drop at least one table into the canvas area. After that, what would happen is the view area will give you the complete view of the table, the columns and rows that belong to your table. After that, go into the worksheet space. That's when you'll get the list of columns using which you can try converting the tabular data into graphs and charts. Okay, that's the first point. Okay, now the next point is, see, these are the list of sheets that belong to sample superstore. But currently, using which table are we trying to visualize the data? Only orders, because I've dragged and dropped orders into my canvas area. So only the columns that belong to orders sheet will be listed out right here. Okay, so just because people and returns are present over here, it doesn't mean I can use them for my visualization work. Only if you drag and drop them into the canvas area, Tableau will know, okay, you need the columns and rows from the people table. Okay, these are the rows and columns that belong to the people table. Now, when you go into sheet number 1, these columns would be listed right here. Okay, so it all depends on which sheet or table you are trying to drag and drop into the canvas area. Now, you might have another question. Can I drop more than one table? Can I drag and drop more than one table into the canvas area? We can very well do that, but that's again topics related to a few advanced concepts. Okay, but before that, we have certain basic points to understand about the data source page. Okay, so we'll discuss about it, and then gradually we'll definitely get into the topic. That's a part of module number 1, right? So we'll gradually get into the point of what about dragging and dropping multiple tables into the canvas area. How do we do that? What are the different options or ways that we have in Tableau using which multiple tables can be dragged and dropped into the canvas area? That's definitely possible. But again, a few basic points that we may have to discuss, which will act as a base for certain advanced concepts, right? But definitely we'll come back. We have all of that in our modules, in our upcoming topics. Okay. If we are discussing about Excel files, we call them as sheets in an Excel file. If you're discussing about, let's say, servers and clouds, you will have databases in your servers under which you will have multiple tables, right? But when it comes to Tableau, Tableau is treating everything as tables. Okay, I mean, just because it's an Excel file, we call them as Excel sheets, right? But anyways, Tableau will be treating them as tables within your databases. Just like how it treats tables inside your database, it is going to treat these sheets, these Excel sheets, as tables. So end of the day, everything is the same. Tableau is treating everything as tables. Okay, right. So let's explore a little more about our data source page. Okay, let's drag and drop orders into the canvas area. You get those rows and columns displayed right here, and we call it as the view area. Okay, right. So now you have a small symbol right on top of every column header. Now, what are these about? Just click on one symbol and you'll be able to get a list. You'll be able to see the list right here. Now, they are known as the data types in Tableau. Every column is assigned with a particular data type. See, your row ID is a column which is of a number whole data type, right? Row ID is a column which is of a number whole data type. Now, if you see, there are 6 different data types. Number, which is split into number, decimal, number, whole. So we consider that as 1, right? So we have 6 data types: number, date and time, date, string, Boolean, and geographic role. These are the 6 different data types, right? Now, you have integer or whole numbers as values under row ID, and that's why it is of a number whole data type. Correct? Then you have order ID. It is alphanumeric, right? It has text as well as numbers. So it's considered to be a string data type. Then you have order date, ship date. They are date related information, as in the format is basically date format. That's why they are of date data type. In case you had timestamps along with date information, then they would be considered as date and time data types, right? Then these are again string, and as you keep moving, there are certain columns which have a globe symbol over here. Now, what does this mean? See, I hope we are already familiar with the other data types, right? Number, date and time, date, string, boolean. Boolean is nothing but true or false. That would be the values within your column. Yes, but what is this geographic role all about? Yes, now first of all, are we assigning every column with a specific data type? No, Tableau does it automatically, right? Depending on the nature of data present under every column, Tableau assigns it with a specific data type, right? And as you can see, you have these globe symbols over here. These columns are assigned, or these columns are identified as by Tableau as geographic data types. See, geographic data types, it says this is country information. If you click on city, it says it's a geographic role. It has city related information. Now, what do we mean by, why can't it simply give it or assign it as a string data type? Why is it assigning as a geographic role data type? In what way this is going to help us, or what's the purpose of it? The main reason behind it is, see, as we know, Tableau is all about data visualization, right? You're converting your data into graphs and charts. What kind of graphs and charts are we going to convert the data into? Let's go into sheet 1. The right top corner gives you the show me tab or show me button over here, right? Just click on it. Now these are the readily available 24 types of charts and graphs with which data can be visualized in Tableau, right? So you have, as you place your cursor, this space over here tells you this is a packed bubble chart. This is a box and whisker plot chart, or this is a tree map. And along with these, pie charts, bar charts, and so on, you also have maps using which data can be visualized. See, if you have data related to, states that belong to US, you can visualize your data directly on the US map. Okay, let's say there are 10 states where we have store set up across United States. How is the sales of these 10 states? Okay, how is the sales in stores located in these 10 states? So instead of visualizing that using a bar chart, wouldn't it be interesting if you directly visualize it on a map, on a US map, right? So maps can be used as ways of visualizing your data. They are also considered to be a chart, a graph using which data can be visualized. But how do we, or what do we need in order to plot out a map in our worksheet space? How can we plot out a map in our worksheet? What do we generally need? We'll need the latitude and longitude information, correct? Which sounds a little complicated, right? So see, we have state, we have country, we have cities, we have states, we have postal codes and all of that. Now, manually, is it possible for us to pick up the latitude and longitude value for each and every state, and using those latitude and longitude values, plotting out a map in our worksheet? All these things seem to be very complicated, right? Manual effort, as in doing everything, all of these things manually, is going to be very, very difficult, right? So what Tableau does is it is making our work easier. By assigning these columns as a geographic data type, it is, making a note that, okay, these columns are related, are in some or the other way related to location related information. So the user might want to visualize the values in these columns in the form of a map. So if at all they would like to do that, they will need latitude and longitude values. So beforehand, what Tableau does is, by assigning these columns which contain location related information as geographic data type, it makes a note that it has to generate latitude and longitude values for all values, latitude and longitude information for all the values within columns that are assigned as a geographic data type. Okay, so verbally, this is what Tableau does. It looks into a column, okay, state, it has location related information. How did it identify that we have location related information? Because they have standardized state names, correct? If you think about a state called, let's say Delhi, okay, might be a state called Madhya Pradesh. It's a standardized state name that belongs to the country called India, right? Similarly, you have these states which are standardized names that belong to US. Okay, so it identifies that yes, they are location related information. For each and every state, it tries to generate the latitude and longitude value. If you go into your worksheet space, see there'll be two pills over here, or two fields over here, known as latitude, and in brackets you have generated, longitude generated. Okay, this generated over here means that Tableau has automatically generated the latitude and longitude values for fields that are of geographic data type. So that's the main reason, or that's going to be really helpful for us when we try to plot out maps in our worksheet with fields that contain location related information. Okay, now you might wonder, okay, country, city, state, postal code, yes, they are of geographic data type. Region, region has values like south, west, central, east, and so on. They also point out to some location, right? Southern part or western part. It's something related to location related information. Why isn't it assigned as a geographic data type? Any idea? It's just assigned as a simple string data type. Why so? Region is also something related to location, right? But why isn't Tableau assigning it as a geographic data type? What do you think would be the reason behind it? Okay, so, moving back to the point that we discussed previously, they don't have latitude and longitude. See, these are values which are standardized country names, standardized state names, or standardized city names. So they'll have a proper latitude and longitude value, right? But region names, they are generalized. It can be the southern part of any country, it can be pointing to the southern part of any state, we don't know, right? As in, they don't have a standardized latitude and longitude value. They are generalized in nature. That is the reason Tableau is not trying to assign it as a geographic data type, but instead it just assigns them as a string data type. So now I hope you get the difference between why geographic role for those columns and why string data type for this particular column. So based on the nature of data present in every column, Tableau assigns it with a specific data type automatically. So now sales has decimal values, so it would be assigned as a number decimal data type, right? So this is one of the very common certification exam questions, or might be one of the basic questions your interview might start with. What are the different data types in Tableau, right? That was the first point. Now you'll be familiar with these symbols, right? Right below the symbol, you have the table name to which this particular column belongs to. So row ID, order ID, they all belong to the orders table, correct? So when you have multiple tables pulled into the canvas area, you should be able to have an idea. Okay, this column belongs to my orders table. This particular column belongs to a different table. So that's the reason they have the table name that's displayed right on top of every column header. Okay, then you have the column header. So these are the three things. First is your data type symbol, then your table name to which the column belongs to, and then you have the column header, right? Now, on the right top corner of every column, okay, you have a drop down arrow mark. Now, if you click on the drop down arrow, you have a set of options. And the first option says rename. Okay, but before that, I have something else to tell you. Understanding how Tableau is getting connected with the data, right? If you remember, there was one point that we discussed. Tableau stores data in the random access memory of your system. What does that mean? Tableau is not capable of storing the data within itself. Okay, Tableau is not capable of it, so it's making use, it's considering the RAM of your system as a temporary cache where it stores the data. Okay, there's one more thing that you'll have to understand about what's exactly happening when we say, or what do we mean by data is getting connected with Tableau. Okay, what do we mean by that? The first point is when right now we've connected Sample Superstore with Tableau, right? Now, when we say Sample Superstore is connected with Tableau, are we literally bringing the data from Sample Superstore into the workspace of Tableau? That's not the case. Tableau is just reflecting your data. Okay, see, when you drag and drop orders into the worksheet space, it is trying to display the data that actually belongs to the orders sheet, but this is just the reflection is what I would say. That's why we call it as the view area. Okay, data is present, the actual data is present in Sample Superstore itself. Okay, but over here it's just the reflection that we are looking into. Okay, which means Tableau is acting as a mirror reflecting your data, and with this reflection we will be building our charts and graphs. Okay, now when you go inside your worksheet, when you particularly choose a field, drag and drop it into your worksheet space, this is when category column related information will be temporarily placed into the RAM of your system and then displayed right here. Again, it's just the reflection. Okay, we'll come to this particular point, but the point that I'm trying to stress on now is Tableau is acting as a mirror. Now you just have to imagine, let's say the data source called Sample Superstore is the original location of the data. That's my original data. When it is connected with Tableau, okay, it's just the reflection that is seen in Tableau because Tableau is like a mirror. Now just imagine you have a kid standing right in front of a mirror. Okay, now the kid is wearing a red color hat. Now what would be reflected in the mirror? The kid with red hat will be reflected in the mirror, right? Similarly, you have 9,994 rows of data in the Excel file. Okay, that's my original data source. That's like the kid in front of the mirror. When I connect it with Tableau, I have all those 9,994 rows being reflected into Tableau's workspace because Tableau is a mirror, correct? There'll be another question that might pop up in your mind. Okay, suppose I would like to add a few rows. See, this is the superstore data, right? So there are new orders made in my store recently. There were new customers who purchased certain products, and I would like to add rows to my orders sheet, correct? I would like to add 20 new rows of data, or I would like to delete certain rows because the orders might be cancelled or something, or I have certain modifications or updates that needs to be done to my existing rows. Let's say this this order ID over here, there's a small change. Instead of 688 in the last three numbers, it should be 687. There's a small update that I have to make. So adding new rows, deleting existing rows, or deleting existing rows and updating existing information. Can I do all of this from Tableau's workspace? What do you think? Can I add new rows? Suppose there are 10 new rows that I have to add. Can I do that from Tableau? Or I have to delete certain rows. Can I do that from Tableau? Or I have to edit certain information. Can I do that from Tableau? Or basically, can I touch my data from Tableau's workspace? We will not be able to do that in Tableau's workspace. Why? Because Tableau is a mirror. Tableau is just reflecting the data. Yes, whatever change or whatever, addition, deletion, updation, whatever, work related to the data is supposed to happen, you have to go back to the original data. It can be your Excel file, it can be your server, cloud, wherever the original data is present. You have to go all the way there, make those changes. After that, those changes would be reflected in Tableau's workspace. See, going back to the kid and the mirror example, now the kid is wearing a red hat, so the mirror is reflecting the same. Okay. Now, suppose the kid is planning to change the hat's color. What should the kid do, or what should we do? We should remove the red hat from the kid's head and place a green color hat. And after that, what would happen? The mirror is going to reflect the same. Okay. Can I take, now I'm planning to change the green hat and make the kid wear a blue hat. Now what are we supposed to do? Can I take a sketch pen and change the color of the hat by scribbling blue sketch on the mirror? That will not be possible, right? So I'll have to make the change on the kid, as in the original data source is where I have to make the change. And when I make that change, that would be reflected in the mirror right in front of the kid. Okay, so whatever change you're planning to make to your data set, as an addition of rows, deletion of rows, updating existing rows, all of this is supposed to happen in the original data source. Correct? And once you do that, all those changes will be reflected into Tableau's workspace. So that's how, or that's the way Tableau is actually connecting the data. It's reflecting the data from the original data source, and we are literally working on the reflection of the data. That's why changes to the data is supposed to be done in the original data source itself. Now, in this case, I have to go back to my sample superstore right here, add rows, delete rows, make changes, make sure you are saving those changes, which is very important, right? I mean, we'll be doing all of that practically as well as we get into our upcoming topics. Okay, but yes, you have to make those changes, make sure you're saving those changes, then those changes would be reflected into Tableau's workspace. That's how we have to edit the data, add rows, add columns, delete columns, and all of that. Okay, that's a very important point you have to remember. I mean, if you're imagining this kid and mirror right in front of it, just compare it with the original data source and Tableau being the mirror. I think this concept will seem very, very easy to understand. Okay, fine. Now moving on to this, these options in the drop down menu that we have over here. The first option says rename. Correct? Renaming the column header. Now, isn't this point contradicting to what we just now discussed? We just now discussed that you cannot touch your data from Tableau's workspace, correct? But how is Tableau letting us rename the data? I mean, rename the column over here. Instead of row ID, I can rename it as RID. Okay. Now, is this change going to affect my sample superstore? Let's go check that. No, it still says row ID. Okay. This particular change has not affected my sample superstore, right? Then what is the, I mean, what are we actually trying to do over here? See, renaming column headers in Tableau's workspace is just for our convenience to work in Tableau. This is in no way going to affect the original data set. You make any change in your original data, that would be reflected in Tableau, but the other way around is not going to happen. You make such changes in Tableau's workspace, renaming your column header. This is not going to affect your original data in any way. Okay, see, going back to our kid mirror example, again, you have this kid wearing a red color hat and that's being reflected in the mirror. I'll take a sketch pen and I'll scribble something on the mirror. Now, this scribbling that I've done on the mirror, is it going to affect the kid right in front of it in any way? No, right? That sketch pen scribbling that I've done is locally going to stay on the mirror itself. It is in no way going to affect the kid in front of it in any way. Similarly, renaming of column headers in Tableau is just for just available locally in Tableau's workspace for our convenience, for the developer's convenience. It is in no way going to affect the original data set. See, sometimes you may have let's say technical column headers, or might be a little lengthy. I would like to abbreviate it, make it short so that it becomes easy for my analysis purpose, right? For all these reasons, you can very well go rename your column header. It's just for your convenience to work in Tableau. Okay, that's the point. Okay, how do we reflect those changes? See, I've made some changes in sample superstore. Might be I've added 20 new rows. I've saved those changes. Okay, just click file, save. I've saved those changes. Now, how are those changes going to be reflected in Tableau? Are they automatically going to be reflected in Tableau? No, you will have to click on a refresh button. Okay, when we discuss about these radio buttons called live and extract, we'll also be coming back to this. But again, certain basic topics are still pending, because only if we discuss that you'll understand live and extract in a better manner. Okay, so during that we'll do all these things practically of how once you make a change in your original data, how to come back to Tableau, and then you just have to right click on your data source name over here, click on the refresh button. Okay, that's when changes made in the original data will be reflected into Tableau's workspace. Okay, we'll do all of that. I know this is, there's so much of information that is being discussed, but again, we'll discuss about each and every point in a detailed manner. Okay, so that was about renaming column headers. It is in no way going to affect your original data set. The kid, the mirror. Just remember that example. That's how your original data and Tableau are connected or related with each other. Okay, fine. The next option says reset name. So just like how you had renamed, you can reset it anytime. You can reset it back to the name that the original column actually had. Okay, so that was rename and reset name. Then you have copy values. Okay. Okay, with Power BI 2, its mirror changes would still need to be made to the data source. Power BI, I think we have options for both. Okay, and maybe check that and get back to you. In Power BI, yes, you have options to do it locally in its workspace, as well as you can make the changes in the original data. Both would be possible, is what I believe. But in Tableau, instead of to avoid that confusion, because there'll be a database team working on the data. Now if we interrupt that by making changes in our data visualization tool, that might cause a confusion. Okay, for that reason Tableau is keeping it straightforward. It's only on your original data where you can make the changes. Okay, yes. Then we have copy values. This copy values is just like the normal copy paste option that we have in any Word or anywhere. Copy paste. Copy the values of any column and go paste it somewhere else. Might be in a Word file, in your email, in your notepad file, anywhere. So it's a very simple copy paste option. Hiding. See, there are 21 columns in orders of sample superstore, right? But do you think we'll be using all the 21 columns for analysis? No, might be I need only customer information and product information. Okay, row ID is something that I'm not going to use for my visualization purpose. Or might be, let's say, order ID is also something that I'm not going to use. I'm not bothered about the ship mode. So certain columns that you might not use for your analysis purpose, yes, you can very well hide them. Okay, why hide them? Making it easy for you. See, all the options available in this space, especially in your data source page, are helping you out, are just for your convenience to work in Tableau, right? Making your work easy in Tableau's workspace. Correct. So if you just go into your worksheet space, you have such a long list of columns. Okay. Sometimes you may have a longer list such that there'll be scroll bars over here. Maybe you'll have to scroll up and down to fetch the column that you're actually in need of. Okay, so in such a case, to reduce the number of columns in this list over here, letting you focus only on the columns that you actually need for analysis. What Tableau is letting you do is it's letting you hide certain columns. We'll see how to unhide as well. Okay, I'll tell you. See, I'll just go click on the drop down arrow mark of row ID and I'll click on hide. So row ID is hidden. So now you might have a question. Do I have to hide one column, as in only one column at a time? There are 10 columns to be hidden. So I do it one at a time. So should I do it one at a time? No, which will be time consuming, right? You can also multi-select columns and hide all of them at once. Let's see how that can be done. Just click on this, you have this blank space over here on top of your column header, right? Just click somewhere on that so that the column gets selected. Okay. Once the first column is selected, press Control in your keyboard and try multi-selecting columns that you actually don't require. You're planning to hide all of them. Okay. So how do we do it? First of all, click on any one column. Once it is selected, press Control in your keyboard and start selecting multiple columns, all the columns that you're planning to hide. Okay, so now multiple columns are selected. Click on the drop down arrow mark of any one column. It's okay. You can just click on the drop down arrow mark of any one column. Okay, and then click on hide. So what would happen is all the selected columns will be hidden at once. So what are we trying to hide? Order date, ship mode, customer ID, and segment, right? So all the 4 columns will be hidden at once. And when you go inside your worksheet space, see, this has reduced number of columns. We don't have row ID, we don't have order date, we don't have segment. All the columns that we hid, from the data source page are not displayed over here. So this is letting you focus only on the columns that you actually require, hiding all the columns that we do not require. Okay. Right? So that's how it is making your work easier, letting you focus only on the required columns. Fine. Next point. Okay, I would like to bring them back. How do I unhide them? Right? All you have to do is click on the settings like icon that appears right here on top of your table. Yes. And the second option says show hidden fields. See, what does it say? Show hidden fields. So all the hidden fields will be brought into view. See, they are still hidden. We haven't, they're not unhidden. They're still hidden, but we're just trying to show the hidden fields. Correct? So now you'll get an idea. Okay, these are the columns that are hidden. If at all you would like to unhide them, click on the drop down arrow and click on unhide. You'll get them back. Okay. And if you're planning to unhide multiple columns, the same way. Select one column, press Control in your keyboard and select all the unhidden columns that you're planning to, all the hidden columns that you're planning to unhide. Okay. Select all of them. Click on any one of the drop down arrow mark and say unhide. So hiding and unhiding multiple columns at once. This is how you do it. Okay, so that was the hide, unhide. And when you go back to your worksheet space, now you'll get back all the list, as in the complete list of columns displayed right here. Okay, fine. Next, you have Aliases. Now, what is Aliases in general? It's like another name given to something, right? Yes, for example, as in we have professional names used in schools, colleges, as in professional environment and all of that. But at home, we might be, we might have a pet name, or we might have a different family, just our family and close friends refer to us using that particular name. So it's an alias name, right? Similarly, you can create aliases for values under any column. Okay, let's say for example ship mode. Now what are the values that we have in ship mode? We have second class, standard class, first class, and same day. Okay, I'll just click on the drop down arrow of ship mode and I'll click on aliases. Okay, see, these are the 4 values of my ship mode column: first class, same day, second class, and standard class. Now, I would like to create aliases for them, as in I would like to might be abbreviate them. Instead of first class, I'll have it as FC. Instead of same day, I'll have it as SD. Instead of standard class, SC. And second class. Instead of standard class, I'll have it as STD class. Okay, something like this. And it's not necessary that you have to create aliases for all the values in your column. You may just have it for first class and standard class, right? I would like to create equivalent names or abbreviations, or might be if you feel the values are way too complicated. Okay, it is too technical, difficult for me to analyze. I'll just create aliases, use short and user readable, user friendly names for certain products instead of having technical names, making it easier for us to analyze. Okay, so this is basically creating aliases for your convenience to work in Tableau, right? If you have certain product names which are way too complicated or technical with a lot of numbers, specifications of the product and so on, create such aliases, abbreviate it, make it short, make it readable so that it becomes easy for you to proceed with the analysis work. Now, these aliases again is like the scribbling that you make on the mirror. It is going to stay locally on the mirror. It is not going to affect the kid in front of it in any way. Similarly, these aliases that we create right here is going to stay locally on Tableau's workspace. It is not going to affect your original data source in any way. Okay, so that's about creating aliases. And if you want, you can just clear those aliases by getting back to your aliases dialog box, clear aliases, and that's it. Click on OK, right? See, these are just points. If you want, if you would like to make your work a little easier for analysis, you can very well make use of them. It's definitely not mandatory, but yes, Tableau is giving us certain options to, make our work easier if required. Yes. Then we have next three options is about create calculated field, create group, create bins. See, calculated field is all about module number 3, how to create calculations in Tableau. So that's one whole module that we have to discuss about calculations. We'll come back to it. Then we have group, bins, sets, and then we have parameters. All these topics, group, bins, sets, and all of that is a part of module number 2. Correct? But we are still in module 1. So we have certain topics to discuss in module 1. After that, we'll jump into module 2, during which we'll come back to these points in detail. Calculated field is about module number 3. Okay, so we have a lot of this in store in our upcoming session. So we'll definitely come back to them. Then we have pivoting. Pivoting is something like the one that we have in Excel, something like a transpose. Okay, I have a separate sample file with which I'll explain what is pivoting in Tableau all about. So we'll definitely come back. See, when I say we'll come back, we'll 100% come back. Okay, so you can trust me on that. And calculated field is like pivoting is grayed out because you need multiple columns to pivot. Okay, you cannot just see when I multi-select, that's when my pivot is going to be available. Otherwise, it would be grayed out. So pivoting is an option that requires multiple columns. That's why when you just click on the drop down arrow of one particular column, it is grayed out. Okay, right. So we have different, inbuilt functions and calculations available in inside the calculated field box. Every function has its syntax, a small explanation about the usage of that function, and also an example for that, as in how to use it. Yes, so that's why I told you there's no need for any coding knowledge in order to work with Tableau, because Tableau is providing us with everything. Right? So you have the if then else function, you have the case function, and then you can just go through it whenever you have time. There's such a long list of functions that we have. Okay, so we'll be using them, at least a few, when we reach module number 3 to give you an idea of how to create calculations in Tableau. Okay, and one example that I can give you is, see how easy Tableau is making our work, right? See, we have a column called sales, and then we have a column called profit, right? Yes, but do we need to know which function is needed? That's a question that all of us have in mind when we are initially working with Tableau. I'll tell you, right? See, now we have sales and profit column, but do we have a column called cost? I would like to find out what the cost of my product is. But we have sales and profit. What we can do is we can create a calculated field. See, just go create a calculated field telling cost will be the name of this calculation. And what is cost all about? Sales minus profit. Okay, let's say this is my cost. For a product, you have certain sales amount and then you have the profit. Just subtract both and give me a new column called cost. See, instantly Tableau is giving us a new column called cost, which is nothing but sales minus profit. Okay, and there's this question about how do we know which function to use, when to use which function. So that is something that comes only as you keep working, as you keep coming across different scenarios or problems in Tableau. When you're trying to find solutions for certain problems, that's when we'll figure out, okay, for this kind of a problem, we have to use this particular function. So that doesn't come, see, by the end of the course, you will definitely be able to create dashboards just like the ones that's, shown in the Wiz Gallery and all of that. But it'll take a little time for you to understand about the complete list of functions that we have, when to use which particular function. That just comes, on the go. So as you keep working in different projects, you'll gradually come across that particular point. But that's something that doesn't happen in a very short span of time, right? So what we normally suggest is just try to understand, certain basic commonly used functions. Make sure you're familiar with them. That's more than enough. And in future, when come across scenarios or problems, that's when you can explore a little and get used to the other functions that are rarely used, right? Because right away, if we think about getting familiar with all the functions that we have in Tableau, that will add on stress, that will definitely make you even more nervous, because that's not possible. It's a little difficult. Yes, it's definitely complicated. So on the go, you'll gradually get familiar. We needn't worry about that. Let's focus on dashboard building. Let's focus on the features that we have to make your dashboard interactive. I think that's more important. Calculations, on the go, we can figure it out somehow. So there's no need to worry about that as of now. Okay. Yes, cost is a new column that we've created, but it's not a column that comes from the original data set. It's a scribble that we've done on the mirror. This cost column will only be available in Tableau's workspace. Okay, for your convenience to proceed with the analysis work or the visualization work. It is not going to be created in Sample Superstore. You will not have this column called cost in Sample Superstore. Okay.
Just a quick info, guys. Intellipaat offers a Tableau course. Through this course, you will learn various techniques like connecting to data, transforming data, working with calculations and expressions, visualizing data, and much more from the top industry experts. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth.
Okay, fine. So let's connect back to our Sample Superstore. And within a few seconds, we'll be directed to the data source page. I hope you're familiar with these terms now. Okay. And it's not enough if you just connect your data with Tableau. You have to drag and drop at least one table into the canvas area. Okay. And when you do that, what would happen? The rows and columns that belong to this particular table is going to be displayed in the view area that appears right here. Okay, so we were going through the data types with which every column is assigned. Tableau is going to assign every column with a specific data type depending on the nature and type of data present within that column, right? Then we also have, we went through the different data types, especially what is a geographic role data type, and then, how, as in what are the options available when you click on the drop down arrow mark right on the top right corner of every column, how to rename, and especially when we are renaming, if is this rename or this new name that we given for our column headers, is it going to affect the original data set? No, because these changes that we make in Tableau's workspace is just like the scribbling that we make on the mirror. It's going to stay locally on the mirror itself. It's going to stay locally in Tableau's workspace itself. It's just for your convenience to work with Tableau. These changes that you make is no way going to affect the original data source, right? Whether you rename your column header, you hide certain columns, you create aliases, you create calculated fields, all these things that you do in the workspace, as in, in Tableau's workspace, is just for your convenience. So as a developer, you may have to make some minor changes, okay, which is going to make your analysis work easier, right? So Tableau is helping us with these options, which will make our work easier in Tableau. And at the same time, it is in no way going to affect the original data source, right? So one such option that we have, just like how we were renaming and creating calculated fields and all of that, similarly, we have an option to split the column. Okay, now, for example, if you take order ID, right? How is the value, how are the values under order ID? You have CA, might be that's the country code or something. Then you have a hyphen. After that, you have the year, okay? And again, you have a hyphen, and then you have some number. Might be that's the actual, order number, right? But when you say order ID, it's a combination of your country code, hyphen year, hyphen order number. This is how the order IDs are displayed, okay? But as a developer, for our analysis purpose, I would like to have the order number in a separate column. I would like to fetch the order number from the entire order ID and display it in a separate column. Okay, so how do we do that? We have an option called split in the drop down menu right here. See, split is an option that's available only for fields which are of string data type, right? Now, for example, if you get into a field which is of a number data type, there's no option called split right here. Okay, but when you get into order ID, you have an option called split, and along with that, you have something called custom split. So let's start with split now. Okay, so when I click on split, what would happen is, okay, we don't see any change over here, but what you have to do is, scroll to the rightmost part of your table, and there you'll be able to see three new columns that are created. Yes, order ID split 1, order ID split 2, and order ID split 3. Okay, three new columns are created. Yes, so you have the country code, you have the year number, and then you have the order number. So on what basis is Tableau splitting these columns? Based on hyphen or any separator that Tableau identifies in your value. Based on that separator, Tableau is going to split your column into multiple columns. Okay, now there are certain things that you have to observe right here. Yes, see, that's why I tell you it's very important you get familiar with the workspace of Tableau. It's not enough if you theoretically keep getting to know or learning, the interview questions or the definitions of or the new terms that we have and all of that. It's not enough if you do it theoretically. You have to get familiar with the environment. Open up the workspace of Tableau. Just keep exploring. What is this particular tool used for, or what does the option present in this particular drop down menu, how do we make use of it, or where do we make use of these, what's the purpose of this? right? So if you keep getting familiar with the environment, it'll become very easy for you to gain confidence and become a well-versed Tableau developer, right? So that's something that we keep suggesting to all the participants right from day one. So you can observe a lot of things. Now, what is the observation that you can make right here? There's something Tableau is trying to convey, right? So we'll have to understand that what exactly is Tableau trying to convey. If you understand that, it'll be easy for you to get to know Tableau and work with it in an appropriate manner. Correct? So now there are certain things Tableau is trying to convey, after these splits have been created. Okay. See, there are 3 points that you can observe right here. Point number one, you have a blue line on top of all the columns, correct? Except for these 3 columns, split 1, split 2, and split 3. There's no blue line on top of these columns. So what is Tableau actually trying to convey? There's something Tableau is trying to tell you. Okay, see, you have sample superstore, right, on the left corner, top corner, and there you have a blue line right next to it, correct? So that's the color code given to sample superstore, because in future we'll be discussing, in our upcoming topics or in our upcoming sessions, we'll discuss how to connect multiple data sets with Tableau, right? So that's when you will connect sample superstore, and then there might be another customer data or product data that's coming in for a particular country, right? So you will connect that data set as well with the same workbook. You'll be joining both the data sets and then proceed with your analysis. So we'll be looking into all of those things. So when you connect multiple data sets, every data set will be given a separate color code. Okay, so this sample superstore right now is having a blue color code, and that's why all the columns that belong to sample superstore will have a blue line on top. Okay, it's a way for us, it's for a reference purpose that, okay, these columns are actually coming from sample superstore data set. So for that reference purpose, every data set that you connect will have a unique color. It's not customizable, but still, just for our identification purpose, yes, it is given by Tableau itself. Just to, just to show some difference that these columns belong to a different data set. These columns come from a separate data source, just for that identification purpose. Okay. Yes, coming back to this point over here, but there's no line, there's no colored line on top of split 1, split 2, and split 3. Now, what might be the reason behind it? Okay, so Tableau is trying to tell you that all the columns with a blue line on top, they are actually coming from sample superstore, but split 1, split 2, split 3, do these columns belong to sample superstore? No, they don't, right? In Tableau's workspace, we were trying to create these columns by splitting an existing column. So these columns are created in Tableau itself. So it's like the scribbling that we've made on the mirror. Okay, the change that we've done on Tableau's workspace is just for our convenience to proceed with the analysis. It is in no way going to affect the original data source. So that is why it has no blue line on top. Tableau is telling you these columns were created locally in Tableau's workspace. They are not a part of sample superstore. That's why they don't have a blue line on top of it. There's another thing that's trying to convey the same information. See, normally how the data type symbol looks, it is just, the symbol itself. You either have a hash, you have the ABC for string, you have the globe symbol for geographic data type, and so on, right? But if you look into these 3 columns, there's a small equal to symbol right in front of your data type symbol. Maybe if it's too small from my screen, you can observe it, in your software as well, in your system as well, right? There'll be a small equal to symbol right in front of the data type symbol. That's an indication that it is a calculation, or it is a column that was locally created. It is not coming from Superstore. And the third point is that normally on top of column headers, what do we have? We have the table name to which it belongs to. See, product name is a column coming from the orders table. Quantity is a column coming from the orders table, right? But when you look into split 1, split 2, split 3, on top of it, it has something called calculation. So Tableau is telling you it doesn't belong to a specific column from your data. Table. Okay, yes, I'll repeat that point once again, right? Order ID split 1, split 2, and split 3. They do not belong to any table from the original data source, but it's a calculation that was locally created in Tableau, right? So this data type symbol over here, you have an equal to sign right in front of it. See, all the three things are conveying the same information. There's no blue line on top of these columns. There's an equal to symbol right in front of your data type symbol. And above the column header, you have calculation, right? So these three things are telling you that these columns were locally created for your convenience to work in Tableau. They actually do not belong to Sample Superstore. Okay, so which means, can you delete these columns? See, what do we know? You cannot delete any column that actually comes from the original data source. There's no delete option over here. Can you touch your data from Tableau's workspace? No adding rows, no deleting rows, no adding columns, no deleting columns. All you have to, if at all you have to make these changes, you'll have to go to the original data source, make the changes, after which it would be reflected in Tableau. But in this case, in the case of split 1, split 2, split 3, this was something that was created locally, right? So I can very well delete them if I don't require. I scribble something on the mirror, I can take a cloth and wipe it off, right? It's something like that. So I can very well delete my split 1, split 2, and split 3 columns if I don't require it. So that's how you split your columns in Tableau based on a specific separator. Okay, that was the automatic split, but if you are planning to customize your split, you also have an option called custom split, right? So custom split is where, okay, it says, how should this data be split? Use the separator. Might be there are multiple separators in my data. Multiple separators as in, I'll give you an example for that. Something like, okay, might be something like CA hyphen 2013. And then I have a, let's say, at symbol, and then comes my order number, something like this. So there are multiple separators, right? So I can specify which particular separator Tableau has to use based on which my columns are going to be split. Now, if I use the at symbol, what would happen? Two new columns would be created. First column will have this as the value. The second column will have this as the value, right? So based on the separator, Tableau is going to split and give me multiple columns, right? So custom split is where you can specify the separator. In our case, it's just hyphen, okay? And then it says split off, from which direction your split off should start, okay? Whether it should start from the first value, as in from the left side, whether it should start from the last value, okay, from the right side, or all. Okay, now we will first look into examples for split off from the first value, split off from the last value. Okay, let's say split off from the first value. And as a result of this split, how many columns you would like Tableau to create? Okay, after the split, how many new columns would you like to be created? I'll say I want only 2 columns to be created, right? So what would happen is hyphen will be used as the separator. Split off will start from the first value. And as a result, 2 new columns would be created. Yes. So if I click on OK, what would happen? 2 columns are going to be created with country code as the first column, year number as the second column, and that's it. My order number will not be created as column number 3 because I wanted only 2 columns to be created as a result of my split. Okay, right? So we'll do that once again. Now what will happen if I say split off from the last? I'll go into custom split, use hyphen as my separator, split off from the last, and as a result, let's say I would like to create 2 new columns now. Now what would happen is when I click on OK, Split off will start from the last value, as in your order number will be in one column, your year number will be in another column, and that's it. Why isn't it creating the country code as the third column? Because as a result of this split, you want only two columns to be created, right? So I'll click on OK. This is how both your columns would be created. So you are also allowed to customize your split if you do not want Tableau to automatically split your column based on the default separator or delimiter. Okay, and you can very well delete these columns. Why? Because they were locally created in Tableau, and that's the reason they can be deleted, because they do not come from sample superstore. Okay, so that's about the options that we have in our data source page. Okay, and you also have a small expand collapse button over here. It says table details, right? Let's expand this space by clicking on the arrow mark right here. Okay, now this particular is giving us the table details. Okay, it gives us the type, as in the data type of every column, the field name, the table to which these columns belong to, and then we have something called remote field name. Now, field name and remote field name, they seem to be the same. I mean, they look the same, right? But I mean, why do we have two columns, field name, remote field name? In what way they differ from each other? Okay, now, first of all, this space is nothing but the metadata space. Okay, what's metadata? It's just defining the structure of your table, correct? Now, what's the structure of your table? The columns of your table is what we call as the structure of a table, correct? They define your table. Okay, this space over here, known as table details, is nothing but the metadata space. In our earlier versions of Tableau, this space used to be referred as, to the metadata space, but later on, they just renamed it as table details to make it even more user friendly, okay, or user readable. Right? So this is a space that gives you the metadata information, or in other words, it tells you about the structure of your table, right? But yes, what's the difference between field name and remote field name? Correct? Now, as we already know, we have an option to rename our column headers in Tableau, correct? Row ID can be renamed as RID, right? Now, when you look into the metadata space, your field name is RID. Okay, we just now renamed it. But if you look into the remote field name, it still says row ID, correct? So the difference between field name and remote field name is that, see, you can rename your columns multiple times. You can rename all your columns or any number of columns as per your convenience to work in Tableau, correct? That new name that you given for any column within the Tableau's workspace is going to be displayed right here under field name. But remote field name is always going to make sure it is displaying the original column header as per your data source. See, this renaming is just a temporary change that you're making in your local space of Tableau. Is it in any way affecting the original data source? No, right? Your data source will still have the column name as row ID, correct? So if at all you would like to refer, so you've renamed multiple columns, multiple number of times for your convenience, for your analysis purpose and all of that, but at some point you would like to refer, okay? Fine, RID is the name that I had given for the column in Tableau's workspace. I had renamed it, but what was the original, or what is the original column header? For your reference purpose, you can get into the metadata space and check, okay, row ID is my original column header and I had renamed it as RID. So for that reference purpose, you have this metadata information right here. Okay, so that is all about this expand and collapse button, which gives us the metadata information, right? Okay, so we've almost covered, the options, the drop-down menus, and all of that we have in our data source page. And then we have these two radio buttons, the most important topic. Okay, see, though we've connected our data source with Tableau, we still have two different modes using which we can further decide the way data is connected with Tableau, whether it's in a live mode or in an extract mode. Okay, but unfortunately, this option is not available in Tableau Public. We already know Tableau Public has certain limitations, and this is one major limitation that we have. No live or extract mode of connection that we have. I mean, these two radio buttons, you'll not be able to find them in Tableau Public. Okay, but anyways, it's a very important topic. You will have 30% of your interview questions based on live and extract. Okay, so it's one of the important topics. So let's go through it in a very detailed manner, both theoretically and practically. Okay, and might be if you get a chance to download your 14-day free trial, you can practice live and extract at that point of time. Or might be if after you get into your organization also, you might have to definitely toggle between live mode and extract mode. So you will have to know about what is live, what is extract. Okay, so let's get into the details of these modes. But before this, before getting into live and extract, there's one particular topic that we will have to discuss, which is going to act as a base for live mode and extract mode of connection. And that topic is nothing but a note on file types. A note on file types is the different file extensions with which you can save your workbook in Tableau, right? So this is going to be our uh, next topic before we get into live and extract, because only if you know about these file extensions, on top of this, based on this, we can discuss what is live mode and extract mode, because this base is required for you to understand what is live mode and extract mode. Okay, we'll discuss about all the file extensions, and then we'll get into live and extract, right? What are the file extensions with which you can save your work in Tableau? Just like how we have for a Word file, you save it using .doc or docx, right? Images, you save it using extensions like JPG, PNG, and so on, right? Similarly, all the files that we create in Tableau software can be saved using these extensions. Okay, every file extension has its own way of storing or saving the data. I mean, each saves only certain amount of data or certain amount of worksheets, or when I explain it, you'll be able to understand that in a better manner, right? So each has its own purpose is what I'm trying to say. So we will have to pick up the right file extension which is going to serve our requirement. Yes. Okay, so starting with the first file extension, it is known as TW. So the file extensions with which you can save your work in Tableau, correct? So .twb. So .twb stands for Tableau Workbook. Okay, so Tableau Workbook is going to hold workbook as in the whole file, right? It's going to hold worksheets, dashboards, and stories. Now, what are worksheets? Worksheets, see, this particular file that we've opened up is known as book number 1. This is a workbook of Tableau. You can create multiple worksheets. Sheet 1 will have a bar chart. Sheet 2 can have a pie chart. It's all up to you, right? You can have any number of worksheets that you can create. And then you will be creating a dashboard. What is a dashboard? Dashboard is nothing but a collection of worksheets. Okay, so in one dashboard space, you can place any number of worksheets. So one bar chart, pie chart, which is giving us information about all the top 10 products in our store. Okay, and then you can have another dashboard which is having again 6 to 7 worksheets, which is giving us information about the top 5 customers, who've purchased for high amount of sales in the last month. Okay, so you can have multiple dashboards, which is nothing but a collection of worksheets. Okay, and finally, you can create your stories. See, stories are nothing but you will be arranging. Let's say you've created 10 worksheets and let's say 3 dashboards. Okay, you will be arranging your worksheets and dashboards in a sequential manner as if you're narrating a story to someone. So just imagine you're going in for a presentation. Okay, you are presenting your analysis. So you'll arrange your worksheets and dashboards and you'll start explaining your analysis, right? So this is how I started with sheet number 1. I've observed certain things from the analysis that I've made. Then comes sheet number 2, which gives them a little more information about your analysis. And finally, I've built up my dashboard, which will clearly let anyone interact with the dashboard and get more information. So that's how you'll finish your presentation, right? So when you're going in for presentations, to present your analysis in a sequential manner, as if you're narrating a story to someone, you will arrange your worksheets and dashboards and you create your story. Okay, so that's how you create. This is your worksheet space. This small icon over here is the one using which you'll create dashboards and then you can create your story points. Okay, or you can also imagine worksheet might be is like you slowly, combine your alphabets and form words, and then dashboard is like you combine your words to form sentences, and finally your story is like you combine multiple sentences to form a paragraph. Okay, it'll be better if I create, worksheets, dashboards, and then tell you what is a story point, because theoretically this is the explanation. Okay, but we'll definitely come back. See, I know there are a lot of advanced topics that we are, terms that we're already looking into. Present your data as in, see, you have a presentation mode that is displayed right here. Okay, so if you get into a it's like a slideshow, right? It's like the presentation slideshow that we have in PowerPoint. That's how you will be arranging your worksheets. First, I want sheet 1, then I want sheet 2, then I want, uh, my dashboard to be displayed in, one after the other, just like how you have your slide presentation or your slideshow in a PowerPoint. Similarly, you can create a story in Tableau where your worksheets, your dashboards can be arranged in a proper manner and use as a presentation slide or use as a slideshow to present your analysis. Okay, see, we definitely have modules where we will be looking into how to create a dashboard, how to create stories and everything in detail. Okay, you can definitely download not only in a PPT format, download it as an image, download it as a PDF file, download your dashboards, worksheets, everything into a PDF file or in a PPT file. Okay, you can download it into a PowerPoint and then present it, or directly from Tableau, you have the presentation mode using which you can present the story that you've created in Tableau. Anything is okay, right? It's up to the user. Whichever you prefer, you can definitely do it, right? Okay, getting back to our TWP, right? So workbooks hold worksheets, dashboards, and stories, right? So this entire workbook that we have right here is going to be saved as a TWP file. Now, what do we know about Tableau? Is Tableau capable of storing the data within itself? Tableau is completely dependent on data connectivity, right? So let's just imagine that I'm creating a workbook using Sample Superstore and I'm saving it as a TWP file. So how do I save it? I'll create a simple chart. I'll have my category. I'll have my subcategory, and then I'll have my sales. Okay, I think I also have to tell you what are blue colored fields and what are green colored fields, right? I'll tell you right away. We'll just finish TWB and then I'll tell you what are these and then get back to our file types. Okay, right. So I've created a simple chart. Yes, I'll click on File in the menu bar and then I'll click on Save As. Okay, I'll save it in my desktop. Okay, and there you have the file extension that says .twb. This is how I'm going to save my file. I'll name it as twb file. Okay, right, you'll be able to see it in my desktop. Yep, right here. This is my TWB file. Now just imagine I'm sharing this TWB file with all the participants. I'm just attaching it in an email, or I'm just uploading it in a drive so that you can pick it up from there. Okay, so point one, you should have the Tableau software installed in your system. Only then you'll be able to open up the TWB file. Now, is that enough? Will you be able to open it up if you just have the Tableau software installed in your system? No. You should have the data with which this TWB file has been created. Okay. So now if I'm going to share this TWB file with all the participants, what would happen is, even though you have Tableau software installed in your system, Tableau will not be able to open the file and show you what's present inside the file. It will not be able to display the chart that we created because it requires data connectivity. Okay, now with what data I created the TWB file? We created it with sample superstore, right? So it'll tell you, I mean, it'll look for sample superstore in your system. Tableau will do that automatically. Tableau knows that, okay, for me to open up and display the contents of this file, as in the worksheet that we created over here, right? So for it to open up the workbook and display this worksheet, it needs sample superstore. It will go through all the folders in your system, look for the Excel file called sample superstore. If found, then it'll open up and display the chart in this manner. But if not found, it'll pop up a warning. I mean, kind of an alert message, or might be a pop-up message will be displayed telling failed to identify the data source. Okay. If, I mean, see, sometimes what would happen is you would have renamed sample superstore. When I created my workbook, the data source name was sample superstore. Might be you have sample superstore as an Excel file in your system. Okay, but you had renamed it to Superstore Excel data. So Tableau will not know that you had renamed it, correct? So at that point of time, Tableau will pop up a message telling Tableau failed to identify the data connectivity. If you want, you can connect the data manually, is what Tableau will tell you. So you can pinpoint the Excel file that you had renamed. You can, browse and choose that file and tell Tableau, see, this is the actual data. Please use this data and open up the workbook. So that's when a successful data connectivity will be established and Tableau will be able to display the contents of it because the data connectivity is achieved now. Okay. If you don't have the data source, you will not be able to open up the file. You'll not be able to open up the TWB file and see the contents of it because Tableau is completely dependent on data connectivity. So when can I use TWB file extension? When you are sharing workbooks between the members of your team. See, anyways, your peers, your team members will have access to the data. And especially if you're working in a real-time scenario, you'll mostly be working with server or cloud data, right? So in such cases, what would happen? In order to access the data that's present in a particular server, you will have username and password. Correct? So all the members of your team will have their own credentials to access the data that's present in the server meant for your organization. Correct? So it's enough if you simply share the TWB file with them. When they try to open up the TWB file, Tableau will pop up the box where they have to enter the credentials to access the data present in the server. They will have access to the server, right? They'll have their own credentials. So they will have access to the data, and that's why they will successfully be able to open up the TWB file and see the contents of it. Okay, right? But in cases where you are sharing the workbook with someone who has no access to the data, then they will not be able to open up the TWB file and see the contents of it because data connectivity is required for a TWB file to open up and display the charts present inside it. Correct? So TWB is an extension using which workbooks can be saved. Workbooks contain worksheets, dashboards, and stories. That whole thing is known as a workbook. Okay, and for someone to open up a workbook, point one, they should have Tableau software installed in the system, and point number two, they should have access to the data. Okay, and a slight extension of this file type is the Tableau packaged workbook. Tableau packaged workbook is TWBX. Okay, now this is something like a zip file which will not only contain your workbook but also the data with which the workbook had been created. See, now what was the issue, or what was the point that we have to make a note when we were discussing about TWB? Only share it with people who have access to the data, because if you share it with people who do not have access, they will not be able to open up the file and see the contents of it, right? But in contrast, or might be a slight extension of it, is your TWBX, which is the Tableau packaged workbook, which is acting as a zip file, okay, that is going to not only contain, see, TWBX is going to be a package that is going to have your TWB file along with the data file with which your TWB had been created. So now, instead of saving this as a TWB, if I'm going to get into File, Save As, and I'll choose TWBX. Okay, instead of TWB, I'm saving it as a TWBX file. I'll name it as TWBX file. Now in this case, I've saved it as a TWBX file. Now if I share it with all the participants, okay, see, this is TWBX. I'm sharing it with all the participants, and you all have Tableau software installed in your system. Will you, and let's say you people don't have Sample Superstore in hand, but still you will be able to open up this TWBX file, view the charts inside it, because this is a package that is containing the TWB file and also the data file with which the TWB has been created. See, the icon itself differs. This is your TWB file and the size of it is 47 KB, whereas this is the TWBX file. The size is larger. It's 1.1 MB. Why is it larger in size? Because it's a package. Okay, you have the brown strip on top, the icon, or on top of the Tableau icon, and that's kind of, you can just imagine you have a brown strip because it's a package, it's a box, it's a bundle tied up with a rope, because there are multiple things inside it. What do we have inside it? We have the TWB file, and we also have the data with which the TWB has been created, right? So anyone, even though they don't have access to the data, they can still open up the workbook and see the dashboards or worksheets inside it, because the data is present in the package itself, using which the TWB can open up and display the contents of it. Okay, now as a proof, now I will have to give you a proof that, see, this is a package and these are the contents of the package. I would literally like to open up the package and show you all what's present inside it, right? So for that explanation purpose, I will be converting it into a zip file to just, prove that, see, yes, these are the contents of the file. I would like to show you. Okay, now you needn't do this when you're working in a real-time scenario. Converting it into a zip file is actually not required, but just for our explanation purpose, I'm doing it. Okay, just to make it even more clear that, yes, see, this is actually a package containing multiple things inside it. So I'm just converting it into a zip file. Okay, and we literally view the contents of the file. I'll open it. Now you just have to observe the file extensions. Okay, now what's the file extension of it? TWBX, it's a package, right? I'll right click on it and I'll just view the files present inside it. So you needn't do all of these in your working scenario. This is purely for explanation purpose. I would like to go a little deeper and literally show the contents of the package, and that's why I'm doing this. But this is actually not a required thing that you may have to do when you're working with Tableau, right? This is purely for explanation purpose. Okay, let's view the contents of the packaged workbook. See, these are the things. Look at the file extension. This is your TWB file. It's your Tableau workbook, correct? And along with your Tableau workbook, you have the data called sample superstore that's present in the package. Okay, so you have your workbook as well as the data inside the package, and that's how people can open up the file even though they don't have access to the data. Correct? So that's the difference between TWB and TWBX. Now there might be another question that you have in mind. See, in our case, it was a local file. Local file as in, it was just an Excel file. So we were, it was easy for Tableau to place it inside the package and, share it with to whomever we were planning to send it. What if my data is present in a server or cloud? Correct? How will Tableau place my server data or cloud data inside the package? Correct? Right? See, in the case that we just now looked into, we had the TWB file and it was just a flat file. It was an Excel file. So Tableau easily placed that flat file inside the package and saved it as a TWBX. But what if I am working with server or cloud data? Okay, how will this data be brought inside my package? Correct? So in that case, what Tableau would do is it will create a copy of your server or cloud data. Okay, or you can just imagine it's like it will take a picture, it will click a picture. Okay, create a copy of your server or cloud data. Okay, and that would be placed inside the package along with your TWB file, so that even a person who has no access to the data, they will still be able to open up the packaged workbook and see the contents of your TWB file. And this copy of your data, how is it going to be saved? It is going to be saved using the .hyper file extension. So we call them as data extracts. Now, what is a data extract? It's a copy of your data. It's a picture that Tableau clicks of your data. Okay. Now, there are a lot of benefits or advantages or usages for the data extract that we actually create in Tableau, right? And in fact, we will be discussing, this is just 5% of what we've discussed about data extract. It's a copy of your data. Correct? We have a lot more to discuss about the data extract files in our next topic, which is going to be about live mode and extract mode. See, in an extract mode, we will be using our data extract files, which is nothing but the copy of our data. Okay, the local copy of our data or the picture that Tableau clicks of our data is going to be saved using .hyper file extension, and we call such files as data extract files. Okay, right? So we'll come back, we'll keep a little pause over here, as in for this particular file extension. We'll come back to .hyper, how to save local copies, where are they getting saved, okay, in what manner they are going to be used in in our extract mode of connection. So we'll discuss about all of that, but this is just an introduction of what is .hyper. We'll come back to it. Okay, so there was a question about, can I share my TWBX without converting it into a zip file? Yes, absolutely yes. This was just for explanation purpose. I wanted to open up and literally look into the contents of the package. That's why I converted into the, zip file. But you can treat your TWBX as a normal file and just attach it in your email or upload it in a drive and share it with, your team members or whomever you're planning to. Okay. Right. If the data is in the server, it'll copy in Hyper, and with that, we can share it all. Yes. Now, see, what's the concept of, Tableau packaged workbook? People who don't have access to the data can, you know, uh, can share it, can view the TWBX. Why? Because it has the TWB with the data file along with it, right? So flat files or text files or local files in a system can easily be placed in the package and sent to the whomever you're planning to send, correct? But when it comes to cloud or server data, literally your cloud data or server data cannot be placed inside the package, right? So for that reason, Tableau, saves takes a picture of your data, takes a copy of your data, saves it using dot hyper, and that would be placed inside the package along with your workbook. Now you might have a question, will this affect the confidentiality of my data? See, there might be insider threats, correct? There might be people who are planning to leak out your data. So in that case, if they are going to save it as a TWBX file, my server or cloud data's copy will be placed inside the package, and they'll share it to someone outside the organization where they're when they're actually not supposed to do that, right? So what's the point that we will have to remember over here is Tableau maintains the security of your data even though it is shared as a TWBX file. See, for example, you have a PDF file or an Excel file or any file for that matter of fact, server data, cloud data, anything, and let's say it is password protected. Okay, right? Your file, your data file is password protected. If you share it as a TWBX, you will have your workbook called TWB file. Along with that, you will have the data file, okay, which will still be password protected. So if you feel the person on the receiving end, okay, should open up the TWBX file and view the contents of it, you have to share the password with them. You just have to tell them, see, you'll be able to open up the TWBX file because it's a packaged workbook. You have the data inside it along with the workbook, but you have to enter the password to because Tableau maintains the confidentiality of your data. If it is password protected, Tableau retains that security aspect, even though it shares it as a TWBX file. Okay, so that is your TWB, TWBX. And as of now, you just have to remember that dot hyper is nothing but, it's a data extract file. Data extracts are nothing but copies of your data. Okay, copies of your data, or might be it's a picture that Tableau clicks of your data. That's what a dot hyper file is all about. We'll definitely come back how to save it. Okay, what's the purpose of it and all of that, right? Fine. The next two file types that we have, TDS, TDSX. Okay, and I think before that, I'll tell you a small change about what are these blue fields and green fields in Tableau. Okay, now you know what's a TWB, you know what's a TWBX, how to save it by getting into File in the menu bar. We have two options, TWB, TWBX. Okay, next, before we start with TDS and TDSX, a small shift about what are these blue colored fields and what are these green colored fields. See, we just connected orders table from sample superstore. Okay, we placed it into our data source page. On what basis is Tableau categorizing them into blue colored pills and green colored? See, pill, it looks like a pill, right? The shape of it is like a pill. So we call it as blue pills and green pills. On what basis is, we did not categorize them as blue fields and green fields, right? Tableau is categorizing them into blue pills and green pills. So on what basis is Tableau categorizing them? Okay, why does Tableau categorize them into blue pills and green pills, and how are we going to make use of them to build our charts in our workbook? Okay, now starting with these blue pills. Okay, the pills which are blue in color, or the columns that are blue in color, they are known as dimensions. Okay, so hereafter we'll be referring to them as dimensions, and the ones in green color are known as measures. So hereafter, if we say drag a dimension into the worksheet space, it means drag a field or column that is blue in color into the worksheet space. Correct? So they are collectively known as, or they are they are referred to as dimensions, blue colored fields, and the fields that are green in color are referred to as measures. Okay, now what are the characteristics based on which Tableau is placing them or categorizing certain fields as dimensions? Point one, they are discrete in nature. Okay. Point number two, they have finite number of values under them. Okay, they have finite number of values under them. Now, what does this mean? If you look into any field that is blue in color, okay, it will be discrete in nature. Discrete as in it will be separated or independent in nature. Correct? See, you have three independent or separate categories called furniture, office supplies, and technology. So in Sample Superstore, we have three category related products: furniture, office supplies, and technology. It's finite in nature. What's finite in nature? It's countable in nature, right? It's fixed and countable that you have only these three different category related products in your store. If someone is coming and asking you, I need a food product. Now, do we have food related products in our store? It's a clear cut no, because these are the fixed and countable number of category related products that we have in our store. Only products related to furniture or office supplies or technology is what we have in our store. Correct? Similarly, if you pick any other field that is blue in color, might be ship mode. Okay, there are four different ship modes. Okay, it's countable in nature, it's discrete in nature. You have first class, you have same day, second class, and standard class. So they are countable in nature, they are independent in nature. Okay, these are the values that we have under ship mode. So any field that's blue in color will have a countable number of elements under them that are discrete in nature. And in contrast, if you look into fields that are green in color or fields that are known as measures, they will have, as in these columns are continuous in nature, and they have an infinite number of values under them. Okay, see, we have fields like sales, quantity, profit, discount. These are the fields that are green in color. Why does sales fall into measures, or why is sales green in color? Why do we say it has infinite number of values under them? Now just imagine sales is a column, okay? And let's say we have values like 1,000, 2,000, 3,000. Now, can I tell a customer who is visiting my store, see, you've come to my store, you can purchase only for a sales amount of 1,000 rupees or 2,000 rupees or 3,000 rupees. Okay, these are the fixed three value of sales, okay, for which you will have to purchase products in my store. Now, can we tell such a thing to our customer, or does this is it something that normally happens in a store? We can never tell the customer, for the amount they will have to purchase, right? It's completely dependent on their requirement. They will decide, the sales value will be decided by the products the customer choose, the quantity of products they choose to buy, Okay, we have no control on that. So we cannot fix or have a finite number of values under such column called sales. You may tell the customer, okay, or you may tell that normally in my store, people purchase, for a minimum of 10 rupees to a maximum of 1 lakh rupees. This is the normal range. See, it's continuous in nature. You cannot fix or have a countable number of values under such column called sales. You can say my sales value, as in the people who visit my store normally purchase for for an amount that falls within this range, but it's not fixed or countable in nature. Correct? It's continuous in nature. Similarly, if you talk about quantity, can you go tell the customer that, if they are planning to buy 10 products, can you go tell them, no, these are the three, let's say 4, 5, and 6. These are the three values under my quantity column. You either have to purchase 4, 5, or 6 products, not more, not less. Can we go tell this to the customer? No, that's completely depending on their requirement, right? There might be a customer who's planning to purchase 100 pencils, and there might be someone who's planning to purchase only one pencil. So it's completely dependent on their requirement. We cannot have a fixed number of values under such fields, and that's why these fields fall under measures. So on the basis of these categories, on the basis of these characteristics, Tableau is categorizing them into dimensions and measures. Okay, right? So all the pills. Now you might also wonder, is it because these fields are of number data type? So can we generalize this particular point that all the fields that are of numeric data type will be placed under measures? Can we have it that way? It's definitely, we cannot generalize or fix that as the standard way based on which Tableau is categorizing your dimensions and measures. Okay, because we do have an exception for that. We do have row ID, which is of a number data type, but still under dimensions. Why? Though row ID is of a numeric data type, it has countable number of elements under it, right? We can clearly say that it has 9,994 rows of data. It's countable in nature, correct? Which means it is discrete, it has a finite number of elements, so it is falling under dimensions. For that reason, it is blue in color, and it has all the characteristics, to be called as a dimension. So we cannot fix this particular point, or we cannot decide or generalize the point that all the fields which are of numeric data type will be placed under measures. That's not the case. These points that we just now discussed, these are the characteristics based on which Tableau is categorizing our pills, our fields, our columns into dimensions and measures. Okay, so I hope that point is clear, right? So that's how Tableau is categorizing them, and hereafter we'll be referring to them as dimensions and measures. Okay, right. Going back to our file extensions. So I hope you're clear with what's a TWB, what's a TWBX. Okay. Hyper, just the theoretical definition. We still haven't discussed about how, where, why to save dot hyper. Okay. We'll definitely come back. But yes, before that we have TDS and TDSX. Okay. TDS stands for Tableau Data Source. Okay. Now it is the shortcut to frequently used data sources containing information and modifications. The definition is definitely not clear enough, right? But let me give you an example. Might be a scenario based example, after which this definition will make sense. Okay. Now TDS, right? Tableau Data Source. Now let's just think about a scenario based, okay, example where, let's say we have a team and there are 6 members in the team. Okay, a team of 6 members, right? Now, all of us are planning to work with Superstore data. Okay, and what's the plan is, all 6 of us are planning to analyze this data and submit our report by the end of the day. Okay, but this data, it has a list of modification that we may have to do. Modification as in we are planning to create certain calculations, we are planning to split a few columns, we are planning to rename certain columns, and so on. We have a long list of modifications that we are planning to do on Tableau's workspace. Okay, right? As in, we are planning to first connect the data with Tableau, and in the data source page, we are planning to make all these modifications, create calculated fields, split certain columns for our convenience to proceed with the analysis, rename certain columns, might be create certain aliases, etc., etc. Right? Now, for all these modifications to be completed, it nearly takes 45 minutes of our time. Okay, see, this is the situation we are currently in. There are 6 members in the team. All of us are planning to, submit a report based on the analysis of Superstore data. But, we have a certain list, we have a long list of modifications to be done on Tableau's data source page before we begin our analysis work. Okay, and this list is given to all of us. All of us have to connect the data, make all these modifications, and then proceed with our analysis work. Okay, fine. So as the first member of this, as one of the members, let's say we being one of the team members, let's say what I've done is I've started my work early during the day. Okay, I've started my work a little early. I've spent nearly 45 minutes to 1 hour making all these modifications in my data. Okay, see, I have my Superstore data. I've connected it with Tableau. And I'm making all these modifications. Let's say I'm renaming my column header. Order ID is renamed as ORD ID, and I'm also trying to split my order ID column. Okay, 3 new columns are created. Okay, and I'm also trying to rename these columns as, this is my country code. Okay, it becomes easy for referencing them, right? This is my year, and this is my order number. Okay, see, this is just an example that we have here. So similarly, we are, planning to, as in the list that we, as in our team has, is a longer list. So a lot of other changes are being done. Might be more number of columns are split and renamed, and then certain aliases are created. Certain columns are to be hidden. Okay, so for all these changes to be done, I nearly spent 45 minutes to 1 hour of my time. And then I went into my worksheet space, and then I've already started with, visualizing my data. That looks something like this. Okay, I've started analyzing my data. I've created sheet number 1, and then in sheet number 2, I'm planning to have subcategories, and then I'm planning to have profit. Okay, so I'm just proceeding with my analysis. Okay, and at this point of time, what's happening is, see, there are 5 other members in my team. I hope you're trying to understand, trying to imagine the scenario that we are currently in. Okay, now there are 5 other members in my team. Yes. Now what they are, they are coming up to me. I mean, they've come up to me and they are asking me if I can share the modified data with them. Okay, see, this is the list of modifications that all of us in common have to make before we proceed with our analysis, right? And I've already spent this much of time making those modifications. I've modified my data and I've started with my work, with my analysis work. See, each one of us will have their own way of analysis, right? So I am okay with actually sharing the modified data with them. Though I spent 45 minutes to 1 hour. Now, if I'm not ready to share the modified data with them, what will happen? Each one of them should spend, this much of time individually, make these modifications and then begin their analysis work. Okay, but it's okay, let's help them. I'm okay with sharing the modified data with them so that they can save 45 minutes of their time each and right away start with their analysis work. I'm perfectly fine with that. But the problem is, how am I going to share it with them? If I use my TWB file extension, what would happen? See, as I told you, I'm perfectly fine, with sharing. See, whatever modifications that we've done, we've created this new column, renamed our column, okay, split our column and all of that, correct? I'm perfectly fine with sharing the modifications that I've done. But sheet 1 and sheet 2, see, this is my way of analyzing the data, my style of analysis. Okay, so I might be following a certain observational method that I have been thinking about, so that my report should stand out from the others. Everyone will have their own way of analysis, right? But I'm not okay. I do not want them to know my style of analyzing the data. I've already created sheet 1 and sheet number 2, or might be even more number of sheets that I've already created. And at this point of time, they're asking me to share the modified data. I'm okay with that, but I don't want my worksheets to be shared with them. That's the scenario we are currently in. I'm okay with sharing the modified data, but I don't want my worksheets to be shared with them. And what's the file extension that we're already aware of? TWB, TWBX. Now, if I save it as a TWB or TWBX, what would happen? The entire workbook is going to be saved. Whatever modifications I've done, worksheets, dashboards, whatever visualization that I've created, everything is going to be saved as a TWB file. And that is what I, will be sharing with my team members. And I'm definitely not okay with that. I don't want my worksheets to be shared with them. So what else is the solution? How can we share only the modified data with them, excluding the visualization part? That is when we make use of our TDS file. Okay, right? Yeah. So where do we have the option to save it as a TDS file? You just have to right click on your data source name. Okay, right click on your data source name right here on the left side space. And then from the last but third option, you have add to saved data sources. Just click on it. Okay, and you'll have two options over here, TDS, TDSX. Now first we'll see what's a TDS. Okay, I'll name it as TDS file. I'll save it in my desktop. Okay, TDS is the file extension using which we are saving. I'll save it in my desktop. This is where we have it. So this is the file I will be sharing with all my team members. Now let's open this file and see what's present inside the file. So I'm sharing it with my team members. Will they be able to see my worksheets? Will they be able to see the sheet 1 and sheet 2, the charts that I had created? Let's check that. Okay, I'll open up this TDS file and let's see what my team members will be able to see when they open up this file. Yeah, so this is our TDS file. See, TDS file. And what do we have in the file? Do we have the changes or modifications that we did? Yes, this was a new column that we created, the column that we had renamed. See, all these changes, all the modifications that we did, yes, are present in the TDS file. But do we have sheet 1 and sheet 2? When I saved my TDS file, see, the workbook did have sheet 1 and sheet 2. right? But TDS is a file extension which will only save the modifications done to your data, excluding the visualization part. It will not save whatever worksheets or dashboards that you've created. It is going to exclude it and only save the modified data as a TDS file. Okay, that's might be now the definition will make sense. See, it is the shortcut to frequently used data sources containing information and modifications. Now, why do we call it as a shortcut to frequently used data sources? See, I did not want, I wanted to help my team members. I wanted them to save their time. Okay, so I shared the modified data. So it was a shortcut method for them to use the modified data right away to proceed with their analysis, right? So that's, and moreover, see, TDS, see again, for a person to open up TDS file, see, TDS is might be, you can just imagine it's a small note that contains information related to the modifications that you have done on the data. See, you can just imagine this TDS is just taking notes of whatever modification you did on your data. Okay, rename row ID as RID, split order ID into 3 new columns, rename certain, this particular column as year, rename this column as country code. So it is literally taking notes about whatever modifications that you've done on top of the original data. That is what is your TDS file. Okay. For someone to open up the TDS file, they should have access to the data. See, just like how someone who wants to open up a TWB file should have access to the data, because TWB is the whole workbook, but the data connectivity is required for someone to see what's present inside the workbook, right? Similarly, TDS is just a small note. Just imagine someone is taking notes, okay, whatever modifications that you've done on your data source. So for a person to open up and see the modified data, they should have access to the data source, correct? So what will happen is when you open up the TDS, the sample superstore, whatever data, okay, is actually to be connected. Okay, what will happen is your notes, whatever, this particular file containing information about the modifications will be applied on that original data source, and after which they'll be able to see the modified data in this manner. Okay, right? So it's just a small file that contains information about the modifications that you've done on your data source. Now, just like how we have packaged workbook, what is packaged data source? TDSX, it's a zip file containing your data source file along with any related files. See, I'll literally tell you what's a TDSX. TDSX is nothing but your TDS file plus your data file. So this file, which is containing the information about all the modifications, has to be applied on this data file. That's how it becomes the modified data that's visible to all the team members that I had shared it to. Okay, right? So I hope you're getting the difference between TWB and TDS. Scenarios or situations when you have to choose between TWB and TDS. Okay, so that's how they differ from each other, correct? And I think we have one more left out called TBM, Tableau Bookmark, which contains only a single worksheet. This is something new again. Okay, so even for TBM, I'll be giving you a similar scenario based or a situation based example so that it'll be easy for you to connect with your real time scenario, right? So in a real time scenario, when exactly we may have to make use of our TBM file. So we'll discuss it with one such example, but okay. So bookmarks contain a single sheet. Now, what is this single sheet all about? Now, what do we know about a workbook? Workbooks can contain multiple worksheets, multiple dashboards, and story points. The whole, file is known as a workbook. But what is a worksheet? Now we know what's a worksheet. See this particular, okay, yeah. Now this is known as sheet number 2. This is one worksheet. You can just imagine it's just one paper or one worksheet in your entire workbook. Okay, this is one worksheet. So single worksheet can be saved as a TBM file. But what is the purpose of it? As in, why are we going to save just one single worksheet, and in what way are going to make use of that just single worksheet saved as a TBM file? Okay, see, now again, getting into this scenario based example. Okay, let's say we have a team lead and the entire team has 5 members. Okay, now there's a project that's given this particular team, which requires us to create one dashboard which contains 5 worksheets. So the team lead has received this project where one dashboard has to be created, and that dashboard should contain 5 different worksheets. Might be each worksheet is unique in nature. Each worksheet is trying to display information about, might be one sheet is about the top 10 products, the other worksheet is about a map that contains the state-wise sales information. The other worksheet is about, let's say, profit, customers with highest profit. Okay, something like that. So every worksheet is different from each other, and a dashboard has to be created with all 5 worksheets placed in a single space. So that's, that would complete the project. Creation of this dashboard will complete the project. Now the point is, the timeline or the deadline given for the completion of this project is very, very crucial. Okay, it's like we have very short time within which this dashboard has to be completed, right? So now what the team lead is, has decided is, the team lead is planning to split the work among 5 members in their team. Okay, so the plan is, every member or each team member is going to create one worksheet. Okay, so every team member is going to create one worksheet. So at the end of the day, what would happen? 5 members each will create one single worksheet. So there'll be 5 worksheets created. Okay, and then all the team members are going to share these worksheets that they've individually created to the team lead, who is going to combine them and create the final dashboard. So by doing so, what would happen? We'll be able to save a lot of time. We'll be able to finish up the dashboard in a very short span of time. As in, we'll be able to meet or finish the project within the deadline or timeline that has been provided. Okay, so this is the plan. But how are they going to execute it? Okay, so each member is going to create one single worksheet and then share that worksheet with the team lead, who is finally going to combine all those worksheets into one single dashboard. That's the plan. Okay, so let's start. Let's say we are one of the team members. Okay, so from the team members perspective, let's see what are the steps that we will have to perform. So being one of the team members, my team lead has told me, as in he's given me the required, he or she has given me the required instructions, telling me what kind of worksheet I will have to create. So being one of the team members, let's start creating that single worksheet. So I'll open up a new workbook. Simultaneously the other members will also be doing the same thing. Okay, they will have a different worksheet with different requirements. Okay, so based on which they will be working on the worksheet creation from their end. Okay, so as step 1, I'll be connecting my data. and based on whatever instructions that has been given to me by the team lead, I am planning to create my worksheet, just one single worksheet. Yes, all I have to do is just create one single worksheet and share it with my team lead. That's it. My job will be done. Okay, so what kind of worksheet are we going to create? Might be, let's say, a region-wise chart, right? So I have my region. I'll just drag and drop region. See, now we have column shelf, row shelf. Okay. It is definitely not mandatory that only dimensions should go into columns. Measures should go into rows. We have no such rule. Okay. If you pull a dimension into the column shelf and a measure into the row shelf, okay, this is the kind of chart that you create. You get a vertical bar chart. Why? The columns are taken up by category names and the rows are taken up by your sales, your measure. Okay. If you try to see to remove or to basically clear your worksheet, there's a small tool available in the toolbar, okay, called clear sheet. If you click on clear sheet, you'll get back a clear blank worksheet. Okay, right? So now what you can do is drag your dimension into the column shelf, drag your measure into the row shelf. You can consider, I mean, instead of x-axis or y-axis, you can also consider it that way. But you can just imagine it this way. Your columns are taken up by categories, right? It's a vertical bar chart, whereas the row wise or the y-axis has been taken up by your sales measure. And as a result, you get a vertical bar chart. And what would happen if I do the other way around? Yes, I'll clear my worksheet. I'll drag and drop category into the row shelf and then sales or my measure into the column shelf. So now we get a horizontal bar chart. So that's the only change that would happen if you know, swap the pills between rows and column shelf, row shelf and column shelf. This is what would happen. Otherwise, there's no rule that only dimensions should go into column shelf or measures should go into row shelf or vice versa. It's completely based on, uh, I, I, I I mean, we can customize it as in it's depending on our requirement, whether we need a horizontal chart or a vertical chart. Depending on our requirement, you can place rows as in dimensions and measures into row shelf and column shelf. Okay, no such rule. Fine. Okay, so now let's get back to our chart creation. I'll bring in my region into the row shelf. Okay, these are the 4 different region related information that we have in Superstore. And then I'll bring in our might be subcategories. Okay, so this is the region wise subcategory list. And let's bring in profit into the column shelf. Okay, so what do we get here? We get our region, and then there's the list of subcategories for every region and their respective sales. Okay, now again, there are a lot of nuances that you can keep adding to make your chart even more readable. Okay, now see, when you go place your cursor anywhere on the chart, on any mark in the chart, okay, there's a small box that appears telling you, see, exactly where your cursor is placed. This particular bar or mark belongs to the region called central, subcategory called accessories, and this is exactly the profit value. Okay, so wherever you place your cursor, on whichever mark you place your cursor, you will be getting the information related to the region, subcategory, and profit that based on which this particular bar has been created. This small box that appears is known as the tooltip. Okay, see, tooltip. This is the tooltip box that gives us information whenever we place our cursor on any mark. Okay, let's make it a little more colorful. Okay, why don't we add categories into the color marks card. See, now we are slowly, we are slowly starting to use the different aspects that we have, or the different, minute features that we have in our worksheet space. Okay, gradually we'll be getting introduced to a lot of, minute tools or features or cards that we have in our worksheet space. I know as day one, in one single day, we'll be discussing a lot of minute tools and features that we have in our worksheet space. Okay. And we have a lot of marks cards available. See, this is the marks shelf. A lot of marks cards that are available. So using all of these, we'll be enhancing the way we visualize our data, because that's the whole reason why we use Tableau, right? For data visualization. And we'll have to make it as, detailed as possible, as useful as possible for the end user. So we'll be enhancing the way we visualize our data using all these features, all these marks cards available in the worksheet space. Okay, so let's make it a little colorful. I'll drag and drop category into the color marks card. So what would happen is every member of my dimension, what was the dimension I dragged and dropped into the color marks card? Category, right? How many values do we have under category? We have 3 values. As you can see, furniture, office supplies, and technology. So every member of this dimension is given a unique color based on which my chart is colored, right? So now what do we understand, or how do we read this chart? All the blue, bars belong to furniture category. Bookcases, right? Chairs, furnishings, all the subcategories that are blue in color belong to furniture. All the subcategories that are orange in color belong to office supplies. So it's adding more details to your chart. Okay, so this is the kind of chart that my team lead wanted me to create. Yes, so I've created whatever, based on whatever. Okay, how do we change colors? Yeah, this is the default colors Tableau is trying to give, but you can definitely choose any color palette, for the members of your dimension. So how do we do that? There are 2 ways. One is click on the color marks card, then click on edit colors. Okay, you'll be able to open up the edit colors dialog box, where, see, this is the automatic color palette Tableau has picked up. Just click on the drop down menu over here, and you have so many color palettes that you can choose from. Okay, let's say I'll get into color palette for furniture. Click on furniture and choose the color. Click on office supplies, choose a different color, and click on technology and choose a different color. And after which, click on OK. You can use your, you can use the palette of your choice based on which your chart is going to be colored. So everything is customizable. Yes, but yes, so what we've done now, what are we? We are the team member. We've built a chart based on whatever instructions the team lead had given to us. The worksheet is ready. I will have to share this worksheet with my team lead. Now, how am I going to share it with my team lead? Now, what are the file extensions that we already know? We know TWB. Can I save it as a TWB and share it with my team lead? What would happen in that case? The entire workbook will be saved. And just imagine all the other members of my team, if they're going to use TWB as the file extension, my team lead will be receiving 5 workbooks. Okay, with 5 workbooks, he or she will not be able to combine those 5 workbooks into a dashboard to complete the project. Yes, no, TWB is not the choice, correct? Okay. What about TWBX? Again, the same thing. It's the packaged workbook. The whole workbook would be created, not an option. What about TDS? TDS is excluding our visualization, right? It's only going to save the modified data, but that's not what we're looking for in this case. I want my worksheet to be saved. If I use TDS, it's going to exclude my visualization itself. Similarly, TDSX is also the same thing. So that is also not an option to go ahead with, right? So in this case, where or whenever you are working as a team, okay, when you're planning to share only a single worksheet with your team lead, who is then going to combine all those worksheets into a final dashboard, TBM should be the choice that you pick. Okay, so TBM stands for Tableau Bookmark, correct? So just a single worksheet. This single worksheet can be saved as a TBM file, Tableau Bookmark file, and then I can share it with my team lead. Okay, so let's see how that can be done. So where do we have our TBM option? You have window in the menu bar. Okay. Now again, we do not have an option for this TBM file extension in Tableau Public. Okay. Might be after we finish this, we also open up Tableau Public and I'll show you that, that we don't have an option to save our worksheet as a TBM file when it comes to Tableau Public. That's a limitation again. Okay. And I think that would be the final limitation. After this, we will have, as in live extract is not available, bookmark is not available. But yes, after that, all the other topics that we'll be discussing about is available in public as well. So no worries, okay? Right, so how do we save a bookmark file? Click on window in the menu bar, then get into bookmark and then click on create bookmark. So that's where you have the file extension called TBM. Okay, I'll save it as my region subcategory colored chart. Okay, just naming it for our reference purpose, right? Region wise subcategory colored profit chart. Okay, I'll save it in my desktop. So as a team member, I've completed creating the worksheet. I'm saving it as a TBM file. Okay. I've saved it as a TBM file. Just look at the icon. You have a bright red bookmark-like strip on the icon of Tableau, indicating that this is a Tableau bookmark file. So just by looking into the icon itself, you can now identify what would be the file extension of this particular file. Yes, TWB, TWBX, this is TDS. You have a, cylindrical, something like a data source like icon. So it's a Tableau data source file, correct? And you have a bright red bookmark like, symbol on top. And that tells you that this is a Tableau bookmark file. So as a team member, we've created our worksheet, we've saved it as a bookmark file. And the last and final step is to share this with my team lead. I can treat it as a normal file. You can just send this file to the team lead, just attach it in an email or upload it in the common SharePoint location through which you people normally share files among your team members. Okay, just treat it as a normal file and share it with a team lead. So with that, my job is over. As a team member, my job is over. So similarly, all the other members of my team would have created the worksheet, saved it as a bookmark file, and then shared it with a team lead. Okay, so all our job is done. Now, moving on to the team. I hope it's clear till now, right? What should the team member do? Now, moving on to the team lead's perspective. So as a team lead, how are we going to combine all these worksheets into a final dashboard? That's when the project would be completed. Okay, so the team lead has received 5 TBM files, correct? 5 worksheets, each saved as a TBM, Tableau bookmark file, correct? So step number 1, the team lead has to bring or download all those files into his or her system, local system, bringing all those files into the local system. And the next step is the most important step. I'll tell you why and what will happen if we don't, follow this step. Okay. The next step is there's a particular folder where the team lead has to place all the 5 bookmark files, the most important step. This is a very, very important step. And if we skip this step, that would become a very big problem, as in we'll not be able to finish up the dashboard. Okay, I'll tell you why and all of that. But yes, this is the step where the team lead has to basically place all those bookmark files into one specific folder known as the bookmarks folder, available in my Tableau repository. Okay, see, whenever you're downloading and installing Tableau desktop, you will have a folder called my Tableau repository that would be created by default. Created by default as in it's a part of the software, it's a part of the package. When you download and install it, you will have your as in my Tableau repository folder that would automatically be created as a part of the software. And inside my Tableau repository, you will have a folder called bookmarks. See, we did not create any of these folders. Okay, we did not create any of these folders. When you download and install the software, all of this would automatically be created. Okay, so my Tableau repository is the folder where you will have a particular folder called bookmarks. Just get into the bookmarks folder, and the team lead, see, the team lead has to bring all the bookmark files that were sent by the team members and place it into the bookmarks folder of my Tableau repository. This is the most important step. Okay, once all those bookmark files are pushed into the bookmarks folder of my Tableau repository, then the team lead can open up a workbook of Tableau. Now, is the team lead going to create any worksheet from scratch? No, not at all. The team lead is just going to open all the files that were sent by the team members and combine it into a final dashboard, right? So the team lead needn't connect with the data source also. Directly, the team lead can click on, just look into the left top corner of this start page. You have the Tableau you have the Tableau icon over here. Just click on that icon. You'll directly be taken to the worksheet space. Okay, but you still haven't connected any data, right? It's okay. The team lead is just going to open all the worksheets that were sent by the team members. So click on window in the menu bar. How is the team lead going to open all the bookmark files? Click on window in the menu bar, get into bookmark, and this list over here is going to have all the bookmark files that are available in the bookmarks folder of my Tableau repository. Now just imagine if the team lead missed placing a bookmark file under my Tableau repository, then it is not going to be available in the list over here. If the team lead had left it in the desktop itself, he or she did not pull it into my Tableau repository, then it is not going to be listed out over here. If it's not going to be listed out over here, the worksheet, the TBM file cannot be opened up, cannot be, combined into the dashboard that we're actually trying to create. Basically, accessing the bookmark file that's not present in the bookmarks folder will not be possible. That's why I told you it's the most important step. If the team lead is simply going to leave the TBM file in the downloads folder or in the desktop folder or anywhere, we will not be able to access it from the workbook space right here. Okay, so that's why it's very important for us to make sure all the bookmark files are pushed into the bookmarks folder of my Tableau repository, right? So yes, so these are the sheets that were sent by all of my team members. Okay, all of, as in the other members in my team. So the team lead is just going to open them up and combine into a final dashboard, right? So let's say starting with the one that we just now created, right? Region, subcategory, colored, profit chart. The team lead is just going to click on it, and right away the worksheet is brought into the sheet space, correct? Then the team lead will go into a new worksheet. See, I hope you're able to see my mouse pointer. This is the icon using which you will be able to create a new worksheet. Okay. Again, window, bookmark. Let's open another sheet. Might be sub, okay, let's say region, no. State-wise profit, or might be subcategory pie chart. That looks something like this. This was created by another member in my team. Okay. And then another worksheet, window, bookmark, sales table. That looks something like this. Okay. So in this manner, the team lead will open up all the worksheets that were sent by the other members of the team. They were saved as TBM files, correct? Once the team lead opens up all the sheets, okay, he or she will directly then go and create a new dashboard. See, the small icon right next to new worksheet says new dashboard. Okay, so clicking on new dashboard. Okay, this is the dashboard. Now, please do not get confused by dashboards. Space seems to be very new to us and all of that. See, at this point of time, we are just trying to explain or discuss about how to work with TBM files. Okay, so this dashboard that I'm going to create over here is just for you to understand. This is how, when TBM files are used as a team, we can work together, combine all such TBM files into a final dashboard. So for that, just for that reason, I'm opening up the dashboard space over here. But no worries, I know this is a completely new topic called dashboards. So we'll come back to all of that. See, we have a lot more to discuss before we get into the explanation of dashboard space. Okay, so please don't get confused. We'll definitely come back. Okay, right? So we just have to, the team lead will just pull all the worksheets in this single space and create the final dashboard. Okay, see, there are a lot of, again, topics related to dashboard creation. We'll definitely come back, but I hope now you are able to, understand how this particular team or team lead would have completed the project, right? So first, every member is, allotted the creation of one single worksheet. So each member is creating a worksheet, saving it as a TBM file, and sharing it with the team lead, who is then opening up as step one. The team lead has to place all the bookmark files into the bookmarks folder under my Tableau repository. And after that, the team lead is going to open up a new workbook of Tableau. Simply open each bookmark file by clicking on Window in the menu bar. And finally, combine all those worksheets into a dashboard and complete the project. Okay, right? Okay, and one more question about these projects, right? How do we know which kind of chart is to be created? Yes, now we'll again be discussing about charts and graphs in detail in module 4. But I'll tell you as of now, see, when you receive a project from the client side, in some cases, the client will clearly tell you these are the type of charts I want you to create. I want a pie chart for top 10 products. I want a vertical bar chart for the top 5 states based on profit. So this is how they'll clearly tell you the requirement. But in some cases, we also have clients who leave it to the developer because they feel the developer will have a better idea in choosing what type of chart in a software development, or in a project life cycle, when you have your kickoff calls, when you're discussing with the business as in what kind of dashboard they're expecting for, we will have to collect all such information. Sometimes they will have a clear idea, I want this kind of a dashboard, this is the kind of dashboard I'm looking for. They'll give you an image they'll give you a pictorial idea of what kind of dashboard they're exactly looking for. But some clients, they'll tell you the concept. They'll tell you, I need a sales dashboard. Okay, I need country-wise sales, state-wise sales, and all of that. But I leave it to you to decide on the type of chart that would be appropriate for a sales dashboard. That also happens, right? Because they feel we as developers, we have a lot of experience in deciding the type of chart that will look better or that will be apt for analyzing data related to a sales of a company, right? So they leave it to us. So sometimes it depends on the client. I mean, they give us the requirement very clearly, but sometimes they leave it to us, during which we will have to pick up the right type of chart and share it with them. If they're okay, then we can proceed with the development. If they feel, there might be a change in this particular colors that you've used in the chart. So that's how, using an agile method, we try to get feedbacks then and there from the client and then continue with our development work. So that, I mean, it's a long process when you think about a real-time project, right? So that's how we proceed. Okay, right. So once again, going ahead with this bookmark concept, I'll just open up a new file and I'm going to pick the sheets, as in open the sheets that are saved as TBM files in order to finish my dashboard. Okay, right? Window in the menu bar, bookmark, and simply open up the sheets which were shared to us as TBM files. Okay, this is one such chart. Click on new worksheet. Open up the next chart. Okay, so in this manner, multiple charts can be opened up. You can go into a dashboard space and simply pull them. Dashboard creation, we'll come back, but this is just to give you an idea how TBM files can very easily be combined into a dashboard when we've worked as a team. Every single worksheet was created by a different person and then combined by the team lead or a third person. Okay, so that's the whole point. Okay, right. So that was about the complete list of file types with which you can save your work in Tableau, right? You will have to pick the right one depending on the scenario or situation you are in.
Just a quick info, guys. Intellipaat offers a Tableau course. Through this course, you will learn various techniques like connecting to data, transforming data, working with calculations and expressions, visualizing data, and much more from the top industry experts. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth.
We are moving into our next topic, which is about live and extract. Right. So getting into this topic of modes of connecting data with Tableau, one of the most important topics in module number 1, and you will at least have 2 to 3 questions related to live versus extract if you go for interviews related to Tableau. Okay, and that, as a Tableau developer, you will definitely have questions based on live and extract, right? Okay, so first let's look into the theoretical points and then we'll slowly get into the practical explanation of it. Okay, right. Modes of connecting data with Tableau. There are 2 modes, live mode and extract mode. Okay, now live mode is where you have your data no matter where your data is. Let it be locally in your file, let it be in a server, cloud, anywhere. Okay, no matter where your data is, your data will be directly connected with Tableau. Okay, your data would be directly connected with Tableau, right? Now, that's what live is all about. Okay, it says your data is always fresh because it's directly connected. Okay, your data is always fresh. Processing speed depends upon the size of the data source. Now, first of all, what is processing speed? Okay. See, as we know, Tableau is not capable of storing the data within itself. Tableau uses the RAM of our system as a cache to temporarily store our data. Correct? Yes. Now that is what is processing speed. See, to explain it in a much more detailed manner, let me tell you. See, let's say this is my worksheet space. Okay. Now, when I drag and drop any field into my worksheet, see this moment, this exactly this fraction of a second where I drag and drop any field into my worksheet, what would happen is, just imagine, okay, the moment I drag and drop a field into my worksheet, there's a background query that is running all the way to my data source. Now, what's my data source? Sample Superstore is my data source. It's an Excel file locally present in my system. Correct? So the moment I drag and drop category into my worksheet, a background query is quickly running to the original Excel file, Sample Superstore. It picks my category column related information, places it in the RAM of my system, and that is reflected in my Tableau's workspace. So I mean, we are not able to realize that all of this is happening in that fraction of a second. Correct? But there's so much that's happening in the back end. When I drag and drop any field into my worksheet, a background query quickly runs to Superstore Excel file, picks up category related information, brings it into, temporarily saves it in stores it in the RAM of my system, and that is what is displayed inside my worksheet. Okay, so the time taken for this background query for the whole process, to take place, and after which it finally displays my values in the worksheet. So the time taken for this background query is what is the processing speed. Now, in our case, the file is locally present in my system and it's not a huge file. It just has around 10,000 rows of data. Correct? So the processing speed, as in the time taken for the background query, was very, very less. Okay. I mean, it's a very good processing speed that we have. So instantly we are able to see the result. We are not able to realize that there's so much that's happening in the backend. Correct? Means our RAM should be more, as in you mean to say larger in size or powerful. Yes, as you keep, might be if you're using a very huge data, very huge Excel file, then yes, you should have a better RAM, as in a 4G. I mean, at least an 8 GB RAM nowadays. Yeah, for big data, definitely yes, you should have a bigger RAM if you're using bigger data. That will definitely affect the performance, the processing speed, right? But from a general perspective, this is what defines or decides the processing speed, or this is what means processing. This is what processing speed is all about. The time taken, or this is how you define processing speed. The time taken by the background query to go to your original data source, pull that particular column related information, place it in the RAM of your system, and then display it in your worksheet. So for this entire process, there'll be certain time that's taken, right? That is what is the processing speed. Okay. Now imagine if you have a file, if you have your data that is present in a server or cloud or somewhere outside your system. It's not present locally within your system. So what would happen, or what are the other factors that comes into act to affect your processing speed? It's not only the size of your data source, correct? It's also the location of your data source that's going to play a major role over here. And again, it's not only the size and location of your data source, it would also be the speed of your internet connection, correct? All these aspects are going to play a role in deciding your processing speed. Yes. So just imagine if you have your data in a server or cloud. Now this background query has to go all the way to my server or cloud. And for that, it would need your internet connection. only then it can go outside your system, go access the data in your server or cloud. So you should have a good internet connection. Okay. Location of your data source. Why? It's not locally present in my system. It's somewhere outside my system. Correct? So the load for my background query is getting increased, right? It has to do a lot more job. It has to do a lot, a job where it is going outside my system to that particular server or cloud and then trying to pull a column related information. And also the size, if you have huge data, if you have millions of rows in your cloud, what would happen? That would add on, right? That would add on to the burden. Correct? So my background query is anyways going outside my system. Already the data size is huge. And to add to it, let's say I have a poor internet connection. So all these factors will let or make the background query take a longer time to complete this whole process and display the result in my worksheet space. So that's when we say we have a poor processing speed, as in it's taking a longer time for the background query to complete this entire process. So we don't have a good processing speed. Now, there was a question about how do we optimize it? Okay, there are different, might be you can improve your internet connection. That's one way. Next is extract mode of connection. I mean, this is also one of your interview questions because we are facing a lot of issues with processing speed when we are working with a live mode. How do we optimize it? Choosing or moving into extract mode of connection will be the best way to have a better processing speed. We'll see how and why is that. But as of now, these are the points related to live mode of connection. See, each mode has its own pros and cons. Okay, we'll discuss about the pros and cons of each of these modes. Okay, but end of the day, whatever scenario you are in, wherever your data is present, what depending on the size of your data source, you will be the right person to pick up the appropriate mode with which your data can be connected with Tableau. Right? Live mode is where data is directly connected. Your processing speed will definitely depend on a lot of factors like the size of your data source, the location where your data source is placed, the speed of your internet connection, all of these factors will decide your processing speed. And the third point is that data can be refreshed, during which updated data is brought into the visualization of Tableau. So this was something that we were discussing last week as well. The mirror example that I told you. Any change that you're planning to make, any update that you're planning to make has to be done on the original data source. Correct? And after that, what would happen? You have to manually go click on a refresh button. Only then, whatever changes you had done in the original data will be reflected into Tableau's workspace. See, for example, let's say at 8 a.m. in the morning, there are 10,000 rows in my original data source. I've connected it with Tableau, right? Now, how many rows will be reflected in Tableau? 10,000 rows. You can, start building your worksheets, dashboards, and all of that with 10,000 rows of data. Okay. And let's say by 11 a.m. in the morning, see, there'll be a data team that's working in the background, right? They'll be updating the data, they'll be adding new rows or deleting existing rows. A lot of updates will happen to my original data source, right? And by 11 a.m., what happens is there are, let's say, 2,000 new rows added to my original data source. Correct? There are 2,000 new rows added to my original data source. Now, what do you think? Will those 2,000 new rows be automatically brought into Tableau's workspace? No, that's not going to happen. Okay. You have to manually click on a button called refresh. Okay. Unless and until you do this, whatever updates that were happened or whatever updates happened in your original data source is not going to be reflected into Tableau. You have to manually go click on the refresh button, after which new rows will be brought into Tableau's workspace. Okay. Now you might have a question. Then do I have to recreate all my worksheets and dashboards because there are 2000 new rows coming in? That's actually not required. Automatically, your worksheets, your dashboards, everything will get updated with the changes that were done in the original data source. I think if we do this practically, okay, you'll have an idea of how this entire process happens. Okay, practically, what are we going to do? Connect the data with Tableau, okay, build a chart, go back to the original data source, add a new row, and then we'll see how that new row is going to be brought into Tableau's workspace, how my worksheet is going to get automatically updated after I click on the refresh button. Okay, I don't have to recreate any of my worksheets. Okay, so we look into all these points, right? Irrespective of wherever your data is, let it be in your local system, let it be in your server, wherever your data is present, you have to manually come click on the refresh button for all the updates that, there might have been updates, happened since 8 a.m., right? You have around 3 to 4 hours in between, I think 3 hours in between, but during which there would have been a lot of, yes, on Tableau's, see, I'll tell you, inside Tableau's workspace, you will have a refresh button. Okay, if you click on the refresh button, all the changes that are done, all the updates that are done in the original data source will be reflected into Tableau's workspace. So we'll right away do that. See, I have a sample file called live versus extract sample. It's a very simple Excel file that we've created just for discussing about this particular topic called live versus extract. Okay. It's a very simple file with around 5 to 6 columns. Okay, we have row ID, name, date, sales, profit, quantity, and discount. Okay, very few columns with, I think, around 20, okay, 39, I think 38 rows of data. Okay, with all sample data, correct? Now, what are we going to do is we'll connect this Excel file with Tableau. Step number 1. Okay, so I'll open up a new workbook and I'll connect this live versus extract sample with our workbook. It's an Excel file. This is where I have it. Okay, and we'll be taken to our data source page. Okay. Okay, sometimes you have errors with your data. I'll just delete the discount column, might be. Okay, now let's try connecting it. There's some issue with our. Now, sometimes Tableau very rarely behaves in a weird manner. It will not let us, it will pop up such error messages when we try to connect our data, right? But we just have to leave it for some time and then try reconnecting, during which such issues get resolved. Okay. Yeah. So now I think we have our view area, which looks fine. Okay, we have row ID, name, date, sales, and profit. Okay, we have 2 radio buttons over here called live and extract. By default, we will always be connected in a live manner with our data. Okay, as of now, we are fine with live mode of connection. I'll directly go into my worksheet space and let's create a simple table. I'll have my row ID. Okay, and then I'll have all my customer names. Okay, let's have the dates. Okay, and now let's bring in our sales and profit as well. Okay, so something new that we are going to discuss now. See, normally, previously, so far, what did we do? We tried pulling sales into the column shelf. And what will happen if I pull sales into my column shelf? We'll get a bar chart that looks something like this. Okay. But I do not want a bar chart to be created. I would like to see the sales value as numbers. Okay. Just like how it appears in my Excel file. I would like to see the sales value as numbers. Okay. Right. So what do? Drag and drop sales, not into the column shelf, but directly drop it on the table itself. So you might wonder, what is this ABC over here? Now Tableau is telling you a worksheet will be complete, or your analysis will seem complete only when you have a dimension and a measure combined together. See, right now we have row IDs, customer, date, but only when you bring in sales, your analysis seems to be complete, right? So this was the sales amount done by so-and-so customer on so-and-so date. Your analysis seems to be complete, right? So ABC column is normally allotted for measures, right? So instead of dropping sales into your column shelf, just drop it directly on the ABC column itself. Okay, so that you get the sales value in numbers. Similarly, there's one more method of doing the same thing. Drag and drop sales into the ABC column, or drop it on the text marks card. See, you have different marks cards over here, right? You have a text marks card. I need my sales value basically in a numeric form. And numeric as in or a textual format as in numbers as such, and not bar charts, right? So for that reason, you drag and drop sales on the text marks card, and you'll be able to see the sales value in numbers. Okay, but there's again a problem. There's no column header for my sales. Why is that? Because you have only one measure dragged and dropped into your worksheet, you will not have a column header for that. Okay, so what you are supposed to do is, when will my column header be displayed? When you have more than one measure dragged and dropped into your worksheet. See, drag and drop profit on your worksheet, and now you will start getting column headers for the same, right? See, minute things, this is how Tableau works. If you understand that, okay, by exploring the environment, if you try understanding these points, it'll be easy for you to, as in you'll get even more comfortable with the environment, correct? Right? So we'll do that once again. See, whenever you have only one measure dragged and dropped into the worksheet, there'll be no column header for that, correct? So when you start bringing in more than one measure, you will get column headers. So now we have a very simple table with which we are trying to analyze the data. We have row ID, name, date, profit, and sales. Okay. So these are the 38 rows of data that we have. Correct? So now we've been analyzing with 38 rows of data. And meanwhile, what's happening is there's some update that's being made in the original data source. Okay, so there's some issue with the quantity column as well. It's not being reflected in my Tableau's workspace. So I'll just delete it as of now. Might be we'll see why and what's happening with it, right? Anyways, we have 38 rows of data, correct? Now there's a new row that's added to my data source with row ID 39. Okay, 39, and the name goes, some sample data. Okay, and some sample date with, let's say, sales value of 2 lakhs and a profit value of 50,000. Okay, see, there's a new row that has been added up to my data source. Okay, and whatever changes you can make a change to an existing row, add a new row. We'll also see how to add a new column and all of that. Okay, but as of now, keeping it a little simple because we have very less time. Okay, so I'm just adding a new row. Okay, make sure whatever changes we've done, whatever updates we've done are getting saved. Okay, you have to save your changes, right? So what was the change that happened? 39th row was added to my data source. Now going back to Tableau, is 39th row going to be automatically displayed in my Tableau's workspace? No, you have only 38 rows. I don't have my 39th row yet. Though 39th row was added in my original data source, I still don't see that in Tableau. Why? Because you will not be automatically, you'll not be able to automatically get those updates reflected in Tableau's workspace. You will have to go click on a refresh button. Only then those changes will be brought into the workspace of Tableau, right? So where do we have that refresh button? Just right click on your data source name. Then the second option that you have is known as refresh. Okay. The moment you click on refresh, what would happen is whatever changes or updates that were done to the original data source will be reflected into Tableau's workspace. See, I clicked on the refresh button and within a few seconds, you'll be able to see how the 39th row was brought into our worksheet space. Okay. Don't we have automatic refreshes? See, we are, at what stage are we in currently? We are still in the development stage. We are still developing the dashboard. Okay, so when we are developing the dashboard in Tableau's workspace, we only have manual refreshes that are possible. Okay, only manual refreshes are possible. But once your development work is done, once you've published your dashboard in Tableau server or Tableau online, I hope you remember the sharing environments, right? Once you've published your dashboard in Tableau server or Tableau online, we have a lot of options to schedule refreshes. Okay, so you can schedule refreshes like every day at 5 a.m. in the morning. I want my dashboard to be refreshed. So automatically your data and dashboard will be refreshed at every day at 5 a.m. in the morning. You also have hourly refreshes or might be weekly refreshes or might be, let's say, twice a day, 5 a.m. in the morning and 5 p.m. in the evening. I want my dashboard to be refreshed. So you have options to schedule automatic refreshes after publishing it into Tableau server or Tableau online. But when we are still in the development phase, when we are still developing the dashboard in Tableau desktop, we only have an option to manually refresh the data. Automatic refreshes are not possible. Okay, so this was just a small example that I gave you about how refreshing works. Okay, right. So once again, we'll discuss about live quickly with an example and then we'll get into extract. Okay, because we already did discuss about live. Anyways, I wanted to go through it from the scratch again. So live mode is where your data is directly connected with Tableau, right? You have your data. It is directly connected with Tableau. Okay, so if your data is present somewhere outside the system, as in any server or cloud, you will be in need of an internet connection. Okay, now it says data is always fresh in a live mode. The processing speed depends upon the size of the data source. Okay, now what's processing speed? The time taken for the background query. Whenever you drag and drop a field into your worksheet space, a background query quickly runs all the way to the data source to pull information about the particular column, bring it into the RAM of your system, and then display it in the worksheet. Correct? So the time taken for this entire process is known as the processing speed. Okay. Now the processing speed with which you work in a live mode is, it depends upon how large is your data source. If your data source is huge, then the time taken will be affected, as in it will become slower. Correct? It will affect the processing speed. Similarly, the location of your data source, which cloud or server it is present in. right? It has to go all the way to that cloud or server to fetch the column. So that is again going to impact the processing speed. And also the internet connection. If your background query has to go, outside your system to any server or cloud, it should have an internet connection. Right? If the internet connection is poor, not good enough, then the processing speed is again going to be affected, right? So all these factors impact or affect the processing speed with which you work in Tableau when it comes to a live mode, correct? And the third point says can be refreshed. Can be refreshed as in at 8 a.m. in the morning, I connect my data with 10,000 rows. And by 12 p.m. in the afternoon, there might be a lot of changes that were happening to my data source. Addition of rows, deletion of rows, adding columns, deleting columns, updating the existing rows, any such change, right? So to bring all those changes into my Tableau's workspace, I will have to manually go click on a refresh button, during which the updated data is then brought into the visualization of Tableau, right? So this is what happens in a live mode of connection, right? So let's connect our live versus extract sample, okay, with our workbook, okay. And by default, it's in a live mode of connection. Let's leave it as it is. Let's go into our worksheet and let's create a very simple table, right? With row ID, customer name, date. Let's bring in sales and profit. And in order to display the sales value in numbers, we will have to directly bring it into the, as in drag it and drop it onto the ABC column, right? Next, we have profit. We'll drag and drop it into the ABC column, right? So that's how we bring in sales and profit, right? So we've created a very simple table now with row ID, name, date, profit, and sales. In fact, see, I mean, it's not necessary that you have to use the exact same live versus extract sample. You can create your own very simple Excel file with just 4 to 5 columns, add 5 rows of data, and you can start connecting, if you're planning to work along, right? So, yeah, we have 39 rows of data, okay? And then as in we've connected this and we are working with this data set in a live mode, okay? Meanwhile, what's happening is in the back end, as in the database team is working on my data, they're adding a new row with row ID 40, okay? With, let's say, some sample data. See, we have row 40 with some sample data. Right? So a new row has been added up with row ID 40. And then what shall we do? We'll make a change to an existing row number 1. Okay, the sales value is 100 and the profit value is 5. Okay, there's some update that's happening to an existing row. Okay, right? So we've added a new row, we've made a change to an existing row. Okay, and might be let's add a new column, okay, called quantity. Okay, so let's say this is just a sample quantity column that we have, right? Okay, so now what have we done? We've added row number 40, correct? We've added row number 40. And then we've made a change to our existing row and we've added a new column called quantity. So many changes are, have happened in the data source and all these changes are getting saved as well. Make sure you're saving all these changes. Okay. Now these changes, are they going to be automatically reflected in my workspace of Tableau? I still see the old value for row number 1. I still see only 39 rows. I don't see the 40th row. Okay, right? So to bring all those changes that has happened in my original data source into the workspace of Tableau, you have to refresh it. Correct? How do we refresh it? Right click on your data source name. Okay, right click on your data source name and then click on the refresh button. Correct? So within a few seconds, all the changes would be reflected into the workspace of Tableau. See, row number 1 has been updated. Row number 40 is now available. See, row number 40 is now available in our worksheet. And the new column called quantity has been brought into my list of measures. Correct? So all the changes, let it be addition, okay? So that's about, or that's what happens if you refresh your data. All the updates, okay, that were made since you connected the data source will be reflected into the workspace or visualization of Tableau. Correct? That is what is live mode all about. This is pretty simple and straightforward. Correct? I mean, the reason I'm telling this is simple and straightforward is when you go into extract, there'll be a lot of minute things that you'll have to make a note of. It might seem a little complicated when compared to live. Okay, so that's why we say live is a very simple and straightforward mode of connecting the data with Tableau. Okay, right. So next, what is an extract mode all about? Okay, extract mode is where we take a snapshot of the original data. See, in fact, data directly being connected with Tableau is what live mode is about. But when it comes to an extract mode, you have your original data. A copy of your data is created, okay, which is then connected with Tableau. So there's no direct connection between data and Tableau. Okay, you have a copy of your data which is connected with Tableau. So there's something in between your original data and Tableau, which is nothing but the copy of your data. And as we know, this copy of our data is nothing but our data extract file, which is saved using the file extension called .hyper. Okay, we'll see how to save, how to create a copy of our data, how to save it using .hyper file extension. We look into all those points, but this is what is live mode, data being directly connected with Tableau. But you have your data from which a copy of your data is created, which is then connected with Tableau. This is your extract mode of connection. Okay, so extract is nothing but it's a snapshot of your original. If we say this is a data extract file, which means it is nothing but a snapshot or copy, or you can also call it as a picture of your data, right? So it's just imagine it's just like a picture of your data is clicked. That copy of your data is known as the data extract file. Okay, now this copy of the original data is going to be saved locally. How is it going to be saved? Using .hyper file extension, right? So it's going to be saved locally in my Tableau repository. We did come across this folder already, right? My Tableau repository when we were discussing about bookmarks, correct? So the exact same folder called My Tableau repository is going to be the location where your local copies are going to be saved. Okay, see, now what was the issue we had in a live mode? The processing speed was getting impacted by a lot of factors, right? Size of the data source, location of the data source, speed of the internet connection, right? All these points or factors were impacting or affecting our processing speed, correct? Now, in order to optimize it or in order to improvise the processing speed, what we normally do is we shift into the extract mode of connection. So what happens in an extract mode of connection? Your processing speed is much better. How come your processing speed is better? See, now just imagine if you have a server or cloud data, okay, you need a good internet connection in order to improvise your processing speed. And your data site might be huge, your data site, your data size will have millions of rows of data, right? So and to add on that, I don't have a good internet connection. So what will happen? The processing speed is going to take a longer time. It's going to be affected or impacted by all these factors. So what I'm planning to do is Okay, let me create a copy of my data. I'll move into my extract mode where I'll create a copy of my server or cloud data, and that copy will be saved locally within my system under my Tableau repository. Correct? So now what Tableau will do, the background query from Tableau, it is not going to go all the way to my server or cloud with this poor internet connection that I have. It is simply going to go fetch the data from this extract file, the copy of my data, which is available locally under my Tableau repository. So my internet connection, no matter how bad it is, my processing speed is not going to be affected or impacted by it. Why? Because the background query is not going to travel all the way to the original data source. It's simply going to pick up the data from my local copy that's available under my Tableau repository. So isn't my processing speed, definitely going to be improvised because of this? So that's why we say the best way to optimize or improvise your processing speed is to go into an extract mode of connection. If you feel your size, as in the size of your data source is huge, it is present outside your system, you don't have an internet connection, due to all these reasons, you can shift into an extract mode, which is definitely going to give you a better processing speed. Okay. Or we also use it in a travel mode when we don't have access to the original data. Correct. See, let's say I'm planning to travel for 6 to 7 hours today. Okay. And I do not want to waste my time. I'm planning to analyze my data during my travel. Okay. We have the data locally in my Tableau repository within our local machine and in our local system itself. Correct. So you will no longer need an internet connection. Correct. Why? Because I'm not going to connect my actual data with Tableau. I'm only connecting the copy of my data with Tableau, and this copy is locally available. Internet connection is not required to access it. Okay. See, now let's say I'm planning to travel for 6 to 7 hours today. I'm starting my journey at 8 a.m. in the morning. Okay. And for the next 7 or 8 hours, I'll be traveling. I don't want to waste time. I'm planning to analyze my data. So what I will have to do is, before I begin my travel, okay, at home, as in, wherever you are currently, before you start traveling, okay, you have to connect your data with Tableau and create a copy of it. Okay. See, initially, before you travel, the reason I'm telling you is when you have your internet connection before you travel, make sure your data from the server or cloud is connected with Tableau and your copy is getting created. Create your copy before you start your travel. And after that, once your copy is created and saved locally under my Tableau repository, we'll see that. We'll practically see how to create a copy, right? So once you create your copy, and then you can start your journey, you can start your travel. So while traveling, there's no need for an internet connection. You can simply use the copy of your data. Okay. Keep analyzing during your travel for the next 7 to 8 hours. And once you reach your destination, after 8 hours, you can very well go refresh your extract. Okay. See, 8 a.m. in the morning, I created my first copy of the data. Okay. And let's say it had 5,000 rows. Okay. And for the next 7 to 8 hours, I'm traveling, I'm using this copy of my data to analyze. Okay. And let's say after these many hours, might be at around 5 p.m. in the evening, I reach my destination. So I've got back my internet connection. Okay. Once I reached my destination, I have a good internet connection now, during which what will I do? I will go refresh my extract. Now, why should I refresh my extract? Because during these hours, there might be a lot of changes that would have happened to my original data source. Correct? So to bring all those changes into my workspace, I will go refresh my extract. Okay. Now, when you're refreshing the extract, what would happen is, during which the entire old extract gets replaced by a new snapshot of your original data. See, I'll tell you what's happening. At 8 a.m., you created your extract, correct? Now at 5 p.m. in the evening, when you click on the refresh button, what will happen is, the moment you click on the refresh button, Tableau is going to take a new picture of your data. Okay, a new picture of your data will be taken. The old picture that you clicked at 8 a.m. in the morning will get replaced by this new picture, right? Now you might wonder, why is this replacement thing happening over here? Why can't it just make those changes on the original copy that I created in the morning itself? There might be new rows added, new columns added, and all of that. Why can't it simply make changes, reflect those changes in the copy that I created in the morning? Why is it taking a new picture now, replacing this old copy with my new copy that was taken the moment I clicked on the refresh button? See, the concept over here is, just imagine if you had clicked a picture of your house, which was newly built 10 years ago. Okay, 10 years ago, in 2015, you had built a brand new house. Okay, you clicked a picture of it and you've shared it with all your friends to show how your house, is actually looking. Okay, and after 10 years now, recently you had made a lot of renovation work. You had changed the exterior, might be paint color, or some exterior, let's say landscape changes, or might be interior work. You've made some changes in your interiors, rearrangement of furnitures and all of that. So now, to show your friends how the house is looking currently, will you take a new picture and share it with them, or will you make changes to the older picture that you had clicked 10 years ago? Or is that even possible, to make change to an older picture that you had clicked 10 years ago? That's not possible, right? You'll click a new picture now, and then you'll share that new picture with them, telling, see, this is how my house looks right now. That's what you do. Correct? Or similarly, let's say you had clicked a picture of yourself when you were, it might be 10 years old. Okay. And now it's like after 20 years, you are 30 years now. So you'll click a new picture of yourself to see how you look right now. Will you make change to that picture that you had clicked 20 years ago? It's not possible, right? You'll have to click a new picture of yourself. Similarly, that's the same concept happening here. At 8 a.m. in the morning, my data had 5,000 rows. Okay. So when I clicked my picture at 8 a.m., it had 5,000 rows. Okay. Now at 5 p.m. in the evening, there would have been a lot of changes done to my data, right? So I'll have to click a new picture to see how it looks right now. Okay, that's what happens when you click on the refresh button. Refreshing your extract means that moment when you click on the refresh button, Tableau takes a new picture. It just throws that old picture, okay, that you had clicked at 8 a.m. Okay, it replaces this old picture with the new picture to tell you, okay, at this moment, this is how your data looks currently. This is the updated data that you right now have as the new picture is connected with Tableau. So that is what happens when you click on the refresh button. Okay, might be now this sentence will make even more sound even more sensible, right? During which the entire old extract gets replaced by a new snapshot of the original data. Correct? Now might be at 8 p.m. Okay, or let's say 10 p.m. in the night. You're planning to refresh because you got an information from the data team that there were some changes that had happened to the original data source since the 5 p.m. refresh that you made. Okay, so to see how the data looks at 10 p.m., what will you do? You'll go click on the refresh button. And when you click on the refresh button, what is Tableau going to do? Tableau will create a new picture. Tableau will take a new picture of your data, replace this 5 p.m. picture with the latest 10 p.m. picture. That will give you the updated information about how the data looks right now. Okay. Okay, I think we'll right away get into the practical part of it, because I think theoretically we are okay. Okay, maybe practically once we do it, you'll get a clarity, right? Okay, so now live mode is what we are currently in, but we are planning to switch into an extract mode, because for the next few hours I'm planning to travel. So I'm planning to create a local copy of my data so that I will no longer need an internet connection while traveling to proceed with my analysis. Okay, so I'm going into my extract mode of connection. Okay, I've clicked on the radio button called extract, and then I'm planning to go into sheet number 1. Okay, but what will happen is when you click on sheet number 1, see, I clicked on the radio button called extract, and what next? I am planning to move into sheet number 1 so that I can start with my analysis. Okay, but before you are directed to sheet 1, Tableau will pop up a dialog box telling, okay, you are planning to work in an extract mode, which is well and good. But if you are planning to work in an extract mode, what should you do? You should save your extract. You should create a local copy, save it under my Tableau repository. Only then I can connect this local copy with your workbook so that you can proceed with your analysis. Correct? Yes. See, what did we do? We clicked on the radio button called extract, and then I simply tried going into my worksheet space. But before directing me into the worksheet space, Tableau popped up this box telling save extract as. Okay, it's asking me to save my local copy, and what is the file extension? It's using dot hyper is the file extension using which your Tableau data extract is getting created. And where is it going to be saved, the folder? It's known as, see, it is getting saved under my Tableau repository. And under my Tableau repository, you have multiple folders. Specifically under data sources, all your Tableau extract files, your local copies are going to be saved. Okay, so let's name it as my first extract, and we'll have today's date. Okay, my first extract. I mean, this is just for our reference purpose. The way you name it, it's up to you. Okay, I'm just naming it with today's date. So my first extract. I'm saving it under the data sources folder of my Tableau repository. I'll click on save. So it'll take a few seconds to take that snapshot to save the local copy using .hyper file extension under my Tableau repository. And after that, we are automatically directed into the worksheet space. So now is my data, is my Excel file called live versus extract, is it directly connected with my workbook? No, it is my local copy. See, extract contains all the data till 8:38 p.m. as in this is the time you created your local copy. How did we create our local copy? By clicking on the save button. Say save extract as dialog box popped up. We named our local copy and we saved it, right? So that moment is when your extract was created, and that is what is connected with our workbook right now. Okay, you can just go into my Tableau repository. It'll be under documents of your system. Okay, my Tableau repository. And this is where do we have it? Yeah, this was the one that we saved, right? At 8:30 p.m. we had saved it. My first extract, 30/03/2025, today's date. Correct? So this is what is connected with our workbook right now. Okay, fine. So we are, continuing with our analysis. So I'll be traveling for the next few hours. I can very well, even without an internet connection, I can still work because my local copy is saved locally in my system. That is what is connected with my workbook. So I can very well proceed with my analysis. And let's say after a few hours, I've reached my destination. And meanwhile, what has happened is there were some changes happening in the data source. Okay. Might be a new row has been added up, okay, with some sample data again, with some quantity. So a new row has been added up. You can in fact add new rows, delete existing rows, make changes to existing rows, new columns, whatever change. Okay, right? So we've added a new row and we'll go save the changes. Fine. So some changes happened in the original data source. Now, is this change going to be automatically reflected in Tableau? No, we still have only 40 rows. What are we supposed to do? We are supposed to refresh. So right click on your data source name and then click on this refresh button. Let's wait. But the row ID 41, row with row ID 41 is still not brought into my worksheet space. Why is that? Why is the update that was made in the original data source not being brought into my workspace of Tableau? The reason is, are we in a live mode now? No, we are in an extract mode, correct? So this refresh button only works for live mode of connection. But right now we are in the extract mode. We are planning to refresh the extract. Okay, so in order to refresh your extract, this refresh button will not work. You will have to go all the way down. Under extract, you will have a separate refresh button. Okay, so this is what we will have to click on because we are currently in an extract mode of connection, trying to refresh our extract. Okay, so click on this refresh button. What would happen is Tableau will create a new snapshot. Okay, replace the old snapshot with this new one, which is having the latest 41st row brought into the worksheet space. See, now let's go back to the data source page. And this space will tell you extract contains all the data. So this was the exact time, 8:42 p.m. was the, right now we clicked on the refresh button, right? So it was exactly at 8:42 p.m. that we clicked on the refresh button. At that moment, Tableau clicked a new picture, replaced our 8:38 p.m. That was the time, you have to remember these times, okay? So 8:38 p.m. was the first snapshot that we created, first extract file that we created, correct? That was replaced by this new snapshot, which was clicked at 8:42 p.m. And this is the one which contains the latest information about how the data looks right now. Okay, so this is how refreshing works. So I hope you're getting a picture slowly of what's happening in an extract mode. Correct? See, the 41st row is available right now. If the data is coming from SQL or Redshift, or you mean to say any server or cloud, how is it going to be refreshed in an extract connection? See, we are in an extract connection, but in order to refresh your extract, you should have your internet connection. That's what I'm telling you. At 8, in the morning, before I started my travel, when I have internet connection, I'll save my extract no matter where the data is from, SQL or any server, any cloud. Tableau will go to your server, take a snapshot of your data, save it locally under my Tableau repository, with which you will be working throughout your journey. Okay, you reach your destination, you get back your internet connection. That is when you can refresh your extract. You will simply click on the refresh button, during which what would happen? The moment you click on the refresh button, Tableau will again go take a snapshot of your data, no matter where it is, any server, any cloud. It will take a new snapshot of your data, come back, replace that old snapshot with this new snapshot, and due to which what happens? Your visualization gets updated. Correct? We only had 40 rows initially, but the 41st row that was present in the latest snapshot is now being displayed in our worksheet. So this is what refreshing means when it comes to extract mode of connection. Irrespective of where the data is coming from, when you click on the refresh button, Tableau will quickly go click a new picture. Just imagine, Tableau is like, yes, extract refresh needs an internet connection. Okay, because Tableau has to go all the way to your server or cloud to click that picture, right? Now, the reason we, have this point over here you can use extract mode when you're traveling. The reason we tell this is, now just imagine if you're in a live mode, okay, you definitely need an internet connection to connect your data with Tableau, okay? But when traveling, I'll not have my internet connection, correct? So there'll be a cutoff in the connection. I will no longer be able to proceed with my analysis, right? So that's why we say when you're working in an extract mode, you will no longer need this internet connection because, beforehand, before traveling, you took a copy of your data, right? You took a copy of your data, and with that copy, which is connected with Tableau, you can continue with your analysis, right? And once you get, you're not going to waste those 7 to 8 hours of your travel time by just doing nothing. Okay, with whatever data you had clicked in the morning, you had saved in the morning, you're continuing to work, you're continuing to analyze. And once you reach your destination, might be you've also built your worksheets and dashboards, right, during your travel time. And once you reach back your destination, when you get back your internet connection, you'll simply click on the refresh button. The updates that were made will be then reflected in the new snapshot that Tableau is going to click. Okay, and this new snapshot will be connected with your workbook, and in turn, your worksheets, dashboards, everything is going to get updated. Okay, that is what refreshing in an extract mode is all about. Okay, right? So that's about refreshing in an extract mode. We still have a few other points, to discuss. Now you might have questions like, okay, the first extract that we saved, okay, it was saved under my Tableau repository. We named it, okay, and we saved it under my Tableau repository. Now every time I click on the refresh button, Tableau is taking a new snapshot. A new extract is getting created. Where are those files? Are those files also being saved under my Tableau repository? That's question one. Question number two, if at all I have to access one of the old snapshots, where do I go fetch it from? Is it also going to be available under my Tableau repository? Okay, I know these are points of confusion, or definitely such queries will pop up in your mind. Let's clarify all those things right away. Okay, so once again, in an extract mode, once you go into an extract mode, okay, when you try going into sheet number 1, what did Tableau do? Okay, I went into an extract mode and then tried clicking on sheet number 1, during which Tableau did not direct me to sheet number 1. It popped up a dialog box telling save extract as. So I named my first extract. Okay, and where was it getting saved? It was getting saved under my Tableau repository. Once it is saved, it was connected with my workbook. Okay, that was at 8:38 p.m. And then what did I do? Once at 8:42 p.m., when I clicked on the refresh button, Tableau clicked a new picture of my data. It created a new extract. That 8:38 a.m. I'm sorry, 8:38 p.m. snapshot. Okay, this one, 8:38 p.m. snapshot was replaced by this latest snapshot clicked at 8:42 p.m. Okay, might be again, let's do a refresh. It's 8:55 now. Okay, I'll once again right click on my data source, go into extract, and then click on the refresh button. Okay, I feel there might be some changes. So to be on the safer end, to make sure we have the latest data, I'm just clicking on the refresh button and see at 8:55 p.m. Now, exactly at this moment, when I clicked on the refresh button, a new snapshot was taken. 8:42 p.m. snapshot was replaced by this new snapshot, correct? Okay, but where are these extract files actually getting saved? Now let's go check our My Tableau repository folder. Do we have them over here? You can look into these, the date and time over here. This is at 30/3/2025. So I don't see any other file saved today at 30/3/2025, which means it's only the very first snapshot that we create is actually getting saved under my Tableau repository. My 8:42 p.m. snapshot, now my 8:55 p.m. snapshot, I don't see them anywhere over here. I don't see them under the, there should be a Tableau extract file created with .hyper file extension, right? I don't see them under my Tableau repository. So where are they actually getting saved? Every time I click on the refresh button, Tableau is creating a new snapshot. Tableau is creating a new hyperfile, replacing my old hyperfile with this new hyperfile. But where is it actually being placed? Where can I find those? See, right now 8:55 p.m. is snapshot is connected with my workbook. If I would like to see the 8:42 p.m. snapshot, from where should I go fetch it? Where are these files actually located? Okay. See, these files, every time you click on the refresh button, a new snapshot is created, and they are not placed under my Tableau repository, but they are actually being placed in the temporary folder of your system. Okay, so the way you access your temporary folder is just type %temp %. Okay, get into the temporary folder of your system. Okay, you'll be able to find a folder called Tableau temp. Let's search for the Tableau temp folder. See, you'll have a folder called Tableau temp. Just get into it, and inside your Tableau temp folder, you will have all your refreshed snapshots. See, 8:42 p.m. Tableau extract file. Okay, 8:55 p.m. Tableau extract file. Correct? You have all of them over here, right? Now, what is the reason behind it? Why can't, you know, these snapshots go into my Tableau repository itself? Why is that only the first snapshot is saved under my Tableau repository, but after that, every time I click on the refresh button, the new snapshot that is taken is not being saved under my Tableau repository, but instead it goes into the temporary folder of my system? Why is that so? What is the reason behind it? Why is Tableau doing this? Okay, see, the reason is, just imagine at 8 a.m. in the morning, I created my first copy. Okay, and then after that, every 1 hour once, okay, every 1 hour once till 6 p.m. in the evening, I'm clicking on the refresh button, a new snapshot is taken, replacing the old snapshot. So every 1 hour once, I'm doing this. Okay, so just imagine there'll be so many new snapshots taken, new data extract files created. Okay, and if all these files are going to be pushed into my Tableau repository, the folder is going to get overcrowded, correct? But are we even going to be bothered about the older snapshots at any point of time? See, it's always like, for me, how does the data look right now? What is the latest updates that we have in our data? I'll be more concerned about the latest extract containing the latest updated information at 6 p.m. in the evening. Now, at 6 p.m. in the evening, will I ever be bothered about how the data looked like at 10 a.m. in the morning? I'll not be bothered about it. I want to know how the data looks right now. Currently, how many rows we have, how many columns we have, how is the data looking? That is what I will be bothered about, correct? Yes, so that's the reason Tableau avoids overcrowding my Tableau repository folder with all the refreshed snapshots that are getting created whenever I click on the refresh button. That's the basic reason behind it. It simply pushes all of them into the temporary folder of your system, which will eventually get deleted after a short span of time. Okay, because they are, Tableau feels it's no longer required, because if at all, now let's say if at all you are in need of one of the old snapshots, might be the 5 p.m. snapshot, or might be the 6 p.m., the latest snapshot. I am in need of this particular file. Okay, I am not ready to leave it in the temporary folder as it is, because it might get deleted after a short span of time. I would like to save this for my future reference. Okay, I would like to go pull this snapshot and save it in my, any folder locally in my system, so that in future, might be tomorrow or day after tomorrow, I'm planning to open this latest 6 p.m. extract for my reference purpose. I'm not ready to leave it in the temporary folder itself. Okay, so in that case, what you can simply do is just right click on your Tableau extract file. Now in our case, which is the latest one? This 55 p.m. is the latest one, right? Right click on it, click on copy, go back to any folder, whichever folder you're planning to save it, just right click and paste it over there. Okay, and you can simply rename it latest extract and the date. Okay, so this way the latest extract today. So this is how, if at all there's a particular snapshot that you're planning to pull and save it for future reference, you have to go into the temporary folder of your system, copy and paste it into the destination folder, and that's how you save your snapshot. Okay, right? So I hope you're getting the flow of what is Tableau actually doing. The first time in a workbook, you go into an extract mode. The first snapshot is what Tableau will ask you to save under My Tableau repository. Okay, but after that, every time you click on the refresh button, Tableau is taking a new snapshot, replacing the old snapshot with this new one. Okay, every time you click on the refresh button, this is what is happening. But those new snapshots are not going to be saved under My Tableau repository, but instead it would be saved in the, or it would be available in the temporary folder of your system, which will eventually be deleted after a short span of time. So if at all you require it, you'll have to go manually fetch it from the temporary folder and save it somewhere on your local system. Okay, right? Why can't the latest one be kept in Tableau repository? I mean, Tableau will not know which is the latest one. See, every 1 hour once in this particular example, every 1 hour once I'm clicking on the refresh button. So Tableau will not know which is the latest one, right? So only manually, I mean, we will know that okay, after 6 p.m. I'm planning to stop my work, as in the working hours are done. I'm going to wind up. Okay, so after this, I'm not going to continue with my analysis. So 6 p.m. snapshot is the latest one. I'll manually go into my temporary, folder, fetch it and paste it, as in place it under my Tableau repository. So this is something, I mean, Tableau is not going to know which is going to be the latest one, because at 10 a.m. if you click on the refresh button, that's the latest snapshot. But again, at 11 a.m. you're doing the same thing, right? So you keep doing this every 1 hour once. So it might overcrowd the Tableau repository folder if all the snapshots are going to be placed under it, right? So Tableau just leaves it to us. If at all you want any snapshot to be saved in the local system, okay, then you will have to go pull it from the temporary folder and save it under My Tableau repository. Okay, right. So that's how refreshing happens in an extract mode. I know there were a lot of minute things to make a note of, to remember. But yes, as you keep going through these points, as you try recollecting them, okay, you'll eventually understand the flow of how it actually works. Okay. And the last point, we in fact have two types of refreshes when it comes to the extract mode of connection. Two types of refreshes. Okay. The two types of refreshes are incremental and full refresh. Okay, now what did we do just now? What do you think we did just now? Was it an incremental refresh or a full refresh? You see, currently, what are we doing? We have an old snapshot. We are replacing that old snapshot with a completely new snapshot, which means it is a full refresh that is happening. Okay, it's the default type of refresh. Yes, now adding new rows, deleting new rows, adding new rows, adding new columns, deleting existing rows, making changes to existing rows, a complete full refresh. The full old snapshot is getting replaced by a full new fresh snapshot that is taken by Tableau. So a full refresh is what is happening right now. But if at all required, you can go and opt for, you can go enable incremental refresh. Okay. What is incremental refresh? See, as the name tells you, incremental refresh is something where only newly added rows get updated. Any changes made to the existing rows do not get updated during an incremental refresh. See, the main reason why we opt for incremental refresh is full refresh is going to take a longer time. Okay, just imagine if you have a huge data source, Tableau has to go click a picture, create a copy of that huge data source, come back, replace that old huge snapshot with this new huge snapshot. So for the entire full refresh, process, it's going to take a longer time. Okay, but incremental refresh is going to be quicker compared to full refresh. Okay, but it's not, it's not going to give you an update about everything, all the changes that were happening in your original data source. It's only going to give you the newly added rows. Okay, the new rows that were newly added since the previous refresh. Okay, so I'll give you a real-time scenario example when we opt for incremental refreshes. Okay, right. So let's say we have a data. Okay, that's very. It's not only a large data, a big data that we are working on. We are also working on a data that is very frequently getting updated. Let's say we have a store that's open 24/7. Okay, which means orders are being made 24/7. New orders are being made. New rows are getting added to my data source full time. Okay, 24/7. So just imagine we already have 1 million rows of data. It's a very busy store with multiple outlets around the city. Okay, so my data source very frequently gets updated. Okay, it's like 50 new rows are added every minute. Okay, so it's a very busy store. You have multiple outlets around the city, and your data is already having 1 million rows. And very frequently, as in every minute, there are 50 new rows that are being added to my data source, which means 50 new orders are being made in the stores. Okay, so the data source is getting very frequently updated. So now in such a scenario, we working as data analysts or developers, data, basically we're working on data analysis, or we're planning to visualize the data using Tableau. Okay, so now what are the two modes we have? Live mode and extract mode. Now, live mode is definitely going to impact the processing speed because of the size of my data source, okay, and might be the internet connection and all of that. My processing speed is going to be low, so I'm opting for an extract mode of connection. So I'm planning to work in an extract mode of connection. Okay, yes. Okay, right. See, 50 new rows are added to my data source every single minute. We still haven't discussed how are we going to refresh the extract. Okay, so my data source is very frequently getting updated, is what I'm telling. Okay, so my data source, 50 new rows are getting added to my data source. Correct. So when I'm connecting such a data with Tableau, I prefer working in an extract mode because the size of the data is huge. My internet connection is poor, so I can't rely on having a good processing speed if at all I'm planning to work in a live mode. So I'm shifting to an extract mode of connection. Okay, so in extract mode, when I'm working with Tableau, what will happen? A copy of your data will be taken, saved under my Tableau repository, and this copy is going to be connected with Tableau. Okay, fine. See, we know that we have a data that's getting very frequently updated. Okay, new rows are getting added to my data source. Now, as a developer, as a person who's analyzing this data, you will be more interested to know how the latest data looks. Okay, see, you're planning to analyze, and if you're not going to refresh your data often, you will be missing out on the new rows that are getting added to my data source. Correct? So what I'm planning to do is every 15 minutes once, I'm planning to go for a refresh. Okay, every 15 minutes once, I'm planning to go for a refresh. And just imagine if you're going to go for a full refresh, what will happen? It's already a huge data source. Frequently, new rows are getting added up. The size of the data source, okay, is going to be increased, right? So the time taken for the old snapshot to be replaced by this new huge snapshot is actually taking too long. Just might be, I can say it takes 5 minutes for my full refresh to get completed. Okay, so every 15 minutes once, if I'm going to spend 5 minutes of my time for a full refresh, I feel this is going to affect my working time. I can't, sit for 15 minutes, work, and then spend 5 minutes waiting for the full refresh to get completed. It's affecting my working time. Okay, I feel 5 minutes is something I cannot waste. Every 15 minutes, just keep waiting for the full refresh to get completed. Okay, so what is an alternative that we can do in such a case? Now, first of all, why are we refreshing? Because we would like to see what is the update that has happened in my data source. Okay, what are the rows that are newly added since the previous refresh? Okay, so I'm more concerned about getting to know what are the newly added rows. Correct? That is my aim, or that's my motive why I'm going for a refresh. But instead of a full refresh, definitely yes, see, full refresh or incremental refresh, both are done manually only. In fact, in Tableau, whether it's live mode, whether it's an extract mode, refresh is only done manually because we are still in the development phase, right? Only after you publish your data in your Tableau server or Tableau online environment, once your dashboard development is completed, you can go in for an automatic scheduled refresh. Okay, but now you will only have manual refreshes, correct? Right. So our motive is to get to know what are the newly added rows. How is my data looking right now? I do not want to miss out any huge order that was made recently. So I'm more concerned about the latest newly added rows. That's my motive. That's why I'm going for a refresh in the first place, right? But instead of full refresh, which is going to take 5 minutes of time, in order to quickly see what's our motive, I need my latest rows, but in a very short span of time, right? So in a quick manner, I need the newly added rows to be brought into my worksheet space. I need the newly added rows, and at the same time, in a short span of time. I'm not ready to not waste, but I'm not ready to spend so much of time during my working hours going in for a full refresh. So that is when you can opt for or enable incremental refresh. Okay, so if a full refresh is going to take 5 minutes, your incremental refresh will take only 1 minute, which is definitely going to save a lot of time, right? So in 1 minute, it's giving you all the newly added rows, which means, see, there are 50 new rows that are newly added, and might be 2 existing rows are getting updated. So during an incremental refresh, you will only have the newly added rows brought into the workspace of Tableau. Okay, any changes made to the existing rows are not going to be brought into the workspace of Tableau. You will have no idea about if at all there were changes made to existing rows. You will not be uh, you know given or reflected. Those changes are not going to be reflected into the workspace of Tableau. Only newly added rows will be brought in. The reason is, in a short span of time, incremental refresh can only bring you the newly added rows. It can only bring the newly added rows into display. Okay, but you will be missing out the changes if at all anything would have done to the existing rows. Correct? But it's okay. Though we are missing out on the changes made to existing rows. I'm perfectly fine. For time being, my job is getting completed. As in, I am able to access, I'm able to view the latest rows that were newly added in a short span of time. My purpose is getting solved temporarily. So I'll spend 1 minute every 15 minutes going in for an incremental refresh. Okay, so that frequently I'm able to get an idea about the newly added rows and all of that. And after some time, might be when I'm going in for a meeting or I'm going in for a lunch break, for 30 minutes, I'll be going in for a lunch break. So at this point of time, what I will do is I will simply click on the full refresh button. Okay, no matter it's going to take 5 minutes or 10 minutes for my full refresh to happen, it's okay. It's not going to affect my working hours, right? I'll go in for my break for 30 minutes. I'll click on the full refresh button and go in for my break and let it take 5 minutes or 10 minutes. But by the time I come back to my table, by the time I come back to my laptop, the full refresh would have been completed, during which, if at all there were some changes made to the existing rows, they also will be now available in the latest snapshot. Correct? So I'll get back the complete latest snapshot at the end of my full refresh. Okay, but the time taken for the full refresh, no matter how long it is, I did not let it affect my working hours. Okay, so this is how we plan and opt or enable for incremental refresh or full refresh in a real time scenario. Okay, so we'll do that practically as well. We'll see how to go enable an incremental refresh. Okay, and how where do we have these two buttons, as in incremental refresh or full refresh and all of that. Okay, we'll definitely have a look at that. But as of now, theoretically, to a certain extent, at least 50% of understanding, theoretically, I hope is what you have. We'll go do this practically. Okay, we'll might be get a complete clarity after that. Yes. Yes. So how do we go enable incremental refresh? Okay, just right click on your data source name. Okay, go into extract. Now there's just one refresh button over here. And what's the default type of refresh? It's the full refresh. Okay, but now I am planning to opt for, or I'm planning to enable incremental refresh. Correct? So where do we have that option? You just have to click on the extract data button that we have right here. Okay, this will open up the extract data dialog box, right? So, and all the way down, the fifth option over here says incremental refresh. And currently it is not enabled. You just have to click this box or check this box to enable incremental refresh. Okay. Now, table to refresh, as in currently we have only sheet number 1. Okay. It'll normally give you, if you have orders, people and returns, which table or sheet you're planning to go for incremental refresh. That is something you have to choose. Okay. And this is the most important point. Identify new rows using column. Now, what does this mean? See, incremental refresh is going to bring in only newly added rows. But how will Tableau know, or how will incremental refresh know what are the newly added rows? How is it going to identify the newly added rows? Correct? So we will have to choose a column. See, these are the columns. I mean, these are the measure numeric columns that we have. Correct? All the fields which are of numeric data type. Yes, these are the columns. Out of these, you will have to choose one column based on which your incremental refresh is going to identify newly added rows. Okay, let's pick up row ID. Now, what do we know about row ID? What is the maximum value or the highest value that we have in row ID? 41. Correct? So this 41 will be taken as the limit value. Limit value as in a condition will be created by Tableau for incremental refresh, where it will say row ID greater than 41. 41 is my highest row ID currently. correct? So this becomes the condition. So when you click on incremental refresh, this is the condition that Tableau will check for. See, I'll tell you. So we've picked up row ID as the column using which Tableau is going to identify newly added rows, correct? Just click on save settings. Okay, now that's it. Now let's go back to our data source, add a new row with row ID 42. Okay, with some sample data. Okay, so I've added a new row, and what is the row ID of it? It's greater than 41, correct? 42 is my row ID. Might be I'll add another row called 43. Okay, with again some sample data. And quantity. Okay, so 40, there are two rows that are newly added with row ID 42, row ID 43, and let's make a change to an existing row. Might be row 38. Okay, row 38. What do? We add, there's a sales value and profit value that has been updated. Okay, so what are the changes that we've done? Row 38 has been updated. Row 42 and 43 are newly added. I'm going to save these changes. Okay, now if I go click on the incremental refresh button, what will happen? Tableau will identify newly added rows based on the column called row ID. Okay, where is row ID? This is row ID column. So Tableau will blindly look into row ID. It's not going to be bothered about all the other columns that you have in your data source. It is blindly going to, because it has to perform the incremental refresh in a very short span of time, right? So it quickly comes into your data source, blindly looks into row ID, and what was the condition? Row ID is greater than 41. Okay, because it knows that currently there were 41 rows of data. So it blindly looks into row ID. Is there any row with row ID greater than 41? Yes, there are two rows. Okay, these two must be the newly added rows. Let's quickly pull them into the workspace of Tableau. That's how it completes the incremental refresh in a very short span of time. Okay, then what about row 38? Yeah, row 38, right? Yeah, what about row 38? We did make some changes in row 38. Will that not be visible to incremental refresh? Definitely not, because it's only blindly looking for row ID for rows with row ID greater than 41. This is a row having a row ID less than 41. It is just not going to bother whatever change you would have made in such a row which did not satisfy the condition. What was the condition? Row ID greater than 41. This is the column based on which Tableau will identify newly added rows, and this is the logic behind which Tableau is actually identifying the newly added rows. Let's go try doing that. Okay, now I'll right click on my data source name, go into extract, and now you have two buttons. So Tableau is giving you the option. Do you want to go in for an incremental refresh, or do you want to go in for a full refresh? Okay, so what is that you would like to go in for? Now, if I say incremental refresh, what will happen? Quickly, row IDs with rows with row ID greater than 41 only are going to be brought into our workspace. Okay, see, you have row 42 and 43 brought in, but what about row 38? It is still having the old data. We did make a change in row 38, but that is not being brought into our workspace. Why? Because incremental refresh blindly used the row ID column based on which newly added rows are brought into our workspace in a short span of time. That is what incremental refresh does. Okay, now if I opt for a full refresh, what will happen? See, it's telling you performing a full refresh can take a long time. Are you sure you want to proceed? Okay. What about row 38? See, row 30, when we were making changes in our data source, what were the changes we made? 42, 43, these are the two newly added rows, and we made a change to our existing row. There was an update that happened to my existing row with row ID 38. Correct? The sales and profit value were updated, right? But did this change reflect in our workspace when we opted for incremental refresh? No. Why? Why isn't this change being reflected? Because what's the condition based on which we've opted for an incremental refresh? Identify new rows using the column row ID. Correct? But see, now this is the condition, but I mean, there was no space where we particularly mentioned row ID should be greater than 41. We did not mention this particularly. This cannot be customized. In fact, we cannot customize this number over here. Whichever row ID is the maximum number, okay, whichever value is the maximum in row ID column will be taken up as the one used in the condition. Okay, right? Row ID is greater than 41 was used. That was how we brought in 42 and 43, 43rd row into our workspace during an incremental refresh. Now the condition would have got updated. Now what's the latest row ID? I mean, what's the maximum row ID? 43. The condition would be updated to row ID greater than 43. So during the next, no, we cannot customize the condition over here. This condition is taken up automatically depending on the maximum value in the column that you choose. Okay, so we've picked up row ID. So the maximum value of row ID will be used for the condition. Now the condition will be updated because currently what's the maximum row ID we have? 43. So next time if you go in for an incremental refresh, it will blindly look if there's any row with row ID greater than 43. Let's go pull it into the workspace of Tableau. That's how incremental refresh works. Definitely, yes, incremental refresh is having limitations because it is not going to give us the correct value for older rows or for existing rows. But again, we were okay with that. I mean, we are okay, though incremental refresh is not giving us information about the older rows, but looking into the positive side, we're at least able to get hands-on, or we are able to get access, or we are able to view the newly added rows in a short span of time. Correct? I mean, there are limitations. It is not giving us information about the older rows, but okay, just for time being, I'm more bothered about the newly added rows. Okay, so I'm going in for the incremental refresh so that in a short span of time, I'm at least, able to get hold of the newly added rows. Okay. And it's okay. Whenever I have time, I'll opt for a full refresh such that whatever changes that were made to existing rows are also being brought into my workspace, because full refresh is where a new snapshot will be taken, new rows, existing rows. Okay. Whatever changes that I've made will be brought into my workspace. Let's try doing that. I'll go in for a full refresh, but it's telling me performing a full refresh can take a long time. Are you sure you would like to proceed with it? Yes. I mean, in our case, it was a very small data set, right? So it was pretty much, I mean, pretty quick, but still, see, now the change that we made to row 38 is being brought in. Okay. Yeah, we'll do it with other columns as well. Might be if you're planning to enable your incremental refresh, not with row ID, but with your profit column. Yeah, we'll select profit this time. Okay. Now, what about profit? See, profit is I'll just click on save settings. If you look into your profit column, okay, see these three horizontal bars over here will let you sort the values, sort the rows based on your profit value, descending to ascending. Okay, so I'm sorting my rows based on their profit value in a descending to ascend, I mean in a descending manner, basically highest to lowest. Okay, so now what is the, I mean, which is the row with the highest profit value? This particular value, 1 lakh, is the highest profit. So profit is the column using which you're planning to identify newly added rows during an incremental refresh. So automatically, whichever value is the maximum in that column will be picked up for the condition. Okay. Now, how will my incremental refresh work? Profit greater than 1 lakh. This will become the condition. Okay, so you go into your data source, add any number of rows, but during an incremental refresh, Tableau will blindly look into the profit column. If there's any row with a profit value greater than 1 lakh, only such row will be brought into the workspace. Rows with profit value lesser than 1 lakh, lesser than or equal to 1 lakh, will not be brought into your worksheet space during an incremental refresh. It will simply skip it. Okay, let's do that. See, I'll add 2 rows. Okay, some sample data. Okay, this is my sales value. My profit value is 50,000 and some quantity. This is, see, 44, the row with row ID 44 is having a profit value less than 1 lakh. And we'll add another row, okay, with profit value that is greater than 1 lakh. Sales value is high, so profit value is also high. Okay, I'll have a profit value of 1,50,000 with some quantity. Okay, so now what have we done? We've added 2 new rows. Okay, let's click on the save button. Let's go back to Tableau, click on incremental refresh. And now, see, I mean, I'll just, yeah, I've removed the sort now. You'll be able to see row ID 44 is missing. Why row ID 44 is missing? Because the profit value of row ID 44 is not greater than 1 lakh. It did not satisfy the condition. So it simply skipped that row. It only, brought in the row that satisfied the condition. What was the condition? Based on which Tableau is going to identify newly added rows. If there's any row with profit value greater than 1 lakh. Why 1 lakh? Did we go hard code it? No, 1 lakh was the maximum in my profit column. That's why Tableau picked it up as the condition based on which incremental refresh actually worked. Okay, that's how you can simply use these 3 horizontal bars button over here to sort. This is in a descending order. Click on it once again. This becomes the ascending order. Click on it once again to remove the sort and get back the original order of rows as per your data source. And how do I bring in my 44th row? The only way is to opt for full refresh. Okay, so that's how. Now, frankly speaking, incremental refresh has a lot of disadvantages. As you said, you're not getting information about, your older rows and all of that. But still, as I told you, there might be scenarios if you're working with a frequently updated data, huge data and all of that. And this is your motive. You would like to get a hold of the newly added rows, but in a very short span of time. For time being, it's okay if you're not able to get information about the older rows. Then with all these things in mind, you have to opt for incremental refresh. If not, though full refresh takes a longer time, you'll get hold of the complete set of changes that would have happened to the original data source since your previous refresh, right? So as I told you, it's definitely not mandatory, or it's not that, this is the best or this is the best. It depends on the situation we are in. depends on your scenario, depends on the factors that you are going to face in, with your data, with the size of your data, with your internet connection and all of that. So these are the two modes, these are the pros and cons, these are the factors that you'll have to take into consideration. And finally, you will be the right person to choose the best mode, okay, because you know what kind of situation you are in. Okay, so that's the kind of option we can give you, right? And questions put up in an interview are generally about which mode do you think has a lot of advantages, or might be in a live mode we have a processing speed which is very, very low. We are not able to cope up with the size, the location, or the, we are having a very poor processing speed. How do we optimize it, or how do we improvise the processing speed? This would be the generalized question that is normally put up in an interview. You can very well answer with, something like move into an extract mode to have a better processing speed, and you'll have to justify why extract mode is going to give us a better processing speed, because the data is available locally. We're just working with a copy of the data, okay, under my Tableau repository. So even without an internet connection, we can very well proceed with our analysis. Just give some points of justification and might be some examples which will justify your answer. Okay, so that's the kind of general questions they put up in interviews related to live and extract. Okay, yeah, so with that, we are finishing up live and extract. Okay.
Just a quick info, guys. Intellipaat offers a Tableau course. Through this course, you will learn various techniques like connecting to data, transforming data, working with calculations and expressions, visualizing data, and much more from the top industry experts. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth.
Okay, so yeah, starting with the first point regarding the feature. Yes, so relationship was introduced in version 2020.2 version of Tableau desktop and Tableau public. Previously, as in the prior versions, 2020, 2019, 2018, and all of them did not have the feature called relationship. Yes. Whereas when you look into joins and blending, they were already in use right from the beginning, right from when the software was introduced, we've been having these features. Connecting the second, third, or nth data set. So we have an add button on the left top corner of your data source page. You will have an add button. That's how we connect the second, third, or nth data sets, if at all we are planning to relate them or join them together, right? Layer in which this feature is used, logical layer. So our canvas area of the data source page is actually split into two layers, right? We have the logical layer where relationship will be possible. When you double click on a logical layer, you'll be taken to the physical layer, and that's where joining will be possible, right? Data source page, all the data sets that are connected with your workbook will have one common data source page, because we are using the add button to connect all the data sets, right? So they all share one common data source page, right? Where data is combined. Now, as we had discussed, when you're relating the tables, you're just defining the relationship in the data source page. Okay, and when you go inside your worksheet space, sheet 1, you might use data from the left side table. Sheet 2, you might use the data from your right side table. And in sheet 3, if at all you plan to work with combined data, that is when you can combine the data and work with common data from both the tables. So we have the flexibility of deciding what amount of data we are planning to work with in every single worksheet, correct? Whereas when you look into joins, we don't have that flexibility. Once you decide the join type in the physical layer of your data source page, right away the tables would be joined and the respective resulting data will be displayed in the view area. And you have to stick on to that join type. The combined data that is displayed in the view area is what you will have to use to visualize in all the worksheets of your workbook. There's no flexibility where you can decide the amount of data in every single worksheet like how we have in relationship. We don't have that flexibility in joins. Okay. Yeah. How data is combined? Now, flexible, right? Flexible as in when it comes to relationship, Tableau is going to decide the best way to combine your data depending on the nature and shape of your data. Correct? But even after that, if you prefer to decide the way data is going to be combined manually, you can very well do that using something called performance options. I think this is the point from where we'll have to start discussing about today. Okay, and this is something that we know. When you look into the physical layer, there are 4 different join types: inner join, left join, right join, and full outer join. Okay, and this is what we have when it comes to the concept or the feature of joining, right? To continue, performance options. If at all, when you're relating tables, if you would like to decide manually the way your tables are supposed to be related with each other, then you can get into something called performance options and decide the cardinality and referral integrity. Okay, so we'll see what's that. I'll be connecting both my data sets, coffee shop sales and office sales. Okay, I'm planning to relate them together. So this is the add button using which we connect our second, third, or nth data set. We have our office sales. Okay, and when we are relating them together, we'll be relating them in the logical layer, correct? So this flexible noodle line is the one using which the feature of relationship will be represented. Okay, so we'll be defining the relationship between both our tables right here in the data source page. Okay, now when you look into this particular option over here called performance options, if you drill it down, there'll be 2 terms. Now, first of all, Tableau is using, this particular feature is very intelligent. Tableau is going to decide the best way to relate your tables based on the nature and shape of your data. Okay, so it's always recommended to go ahead with these options of cardinality and referral integrity that Tableau is suggesting, okay, based on the nature and shape of your data, correct? Now, suppose, let's say Tableau has suggested the options, the cardinality and referral integrity, but you feel you know the data better than Tableau. If you are so sure about your data, you can then go make changes to what Tableau has suggested. Now, let me give you an example. Now, cardinality, the different combinations that you have is many to many, many to one, one to many, one to one. These are the different cardinality options. Okay, now let's say, for example, you have data that looks like this. Okay, now suppose you have 2 tables in hand. One is the department table, which has values like sales, accounts, and then might be the production department. Okay, and then you have something called the employee table, where you have employees around, let's say, 100 employees who belong to your organization. Now, how or what cardinality will suit, will define the relationship between these 2 tables. Now, I can say every department will have multiple employees who will fall under it, correct? Now, is there going to be a scenario where a particular employee is working both under the sales department and the production department? That's not the case. Okay, so the way I can define these tables, the cardinality using which I can define the relationship between these tables is one to many. One department will have many employees under them. Okay, each department will have, or instead of each, you can say one department will have multiple or many employees under them. So one to many is the cardinality that you will have to pick to define the relationship between these tables. Okay, or let's say there's going to be another table known as the contest table. Might be there's some annual day happening Okay, and there's going to be a dance competition or a quiz contest, different types of activities they are planning to conduct. Okay, dance, singing competition, or might be a quiz competition, and so on. Right, now, how do you define the relationship, the cardinality between these tables? You can have it as many to many. Why? Because multiple employees can participate in multiple contests. Okay, or many employees may fall under many contests. So many to many is the kind of cardinality that would define the relationship between these two tables, right? So based on the nature, now, if you are this sure about your data, if you clearly know that yes, one department will have multiple employees. Okay, so one to many is going to be the cardinality. If you're 100% sure about your data, then you can, if at all you want, you can go make changes to the cardinality that Tableau has suggested. Okay, similarly, referral integrity is where some records of my left side table will match with some records on my right side. Or if you're 100% sure that all the records in your left side table will match with all the records in your right side, you can very well go change it. Okay, but this is what Tableau has suggested for the data that we have in hand right now. Okay, so it's always better to stick on to the option that is suggested by Tableau to have a better performance. Okay, now just imagine if it is supposed to be a many-to-many cardinality, but might be with, let's say you thought that you know the data well and you changed it to one-to-many. Okay, so what would happen if you change the cardinality, which is actually supposed to be many to many, but you misunderstood your data, or you thought, or you were overconfident about the understanding of data and you changed it to one to many, right? So in that case, what would happen is it would drastically affect the performance or impact the performance or pull down the performance of your dashboard. Okay, because that's not the right way the data is actually connected, right? So that's the reason we say very important for you to first know your data well before you come make changes to whatever options Tableau has suggested. Otherwise, you can blindly stick on to whatever option Tableau is suggesting. Okay, right? So that's performance option. Referral integrity is nothing but some records. Now, in our example, if you take these tables, now what's the referral integrity between these two tables? All the records in my department table will match with all the records in my employee table, in the sense there will at least be one employee in each department, correct? Or in other words, you can say there's never going to be an employee who doesn't belong to a particular department, correct? Yes, there's always all the records. Now there's going to be the referral integrity of all the records will definitely match with all the records of my employee table, right? Between department and employee. But on the other way around, consider these two tables. Now it's not necessary that all the employees should participate in at least one of these competitions or contests. It's not compulsory. It's purely optional. Okay, so in that case, you can say some records in my employee table may match with some records in my contest table. It's not necessary that every single employee, or it's not necessary that all the records in my employee table will match with all the records in my contest table. It's purely optional. So some records of the employee may match with some records of the contest table. Right, so that's how referral integrity is defined. Okay, now when we have smaller amount of data with lesser number of columns, it's easy for us to decide on the way cardinality or referral integrity will be defined for certain tables. But if you have larger data sets with multiple columns, it would be very difficult to decide it manually. So it's always better to stick on to the options. You can blindly trust and stick on to the options that are recommended by Tableau. Okay, so that's the whole point about referral integrity, cardinality, or in short, you can call them as the performance options. And this is something that we've that we already know. How do you represent relationship? Using a flexible nodal line. And how do you represent joints? The Venn diagram like symbols that we have in the physical layer. So that is how joints are represented. Okay, so with this we are completing the first few points for relationship and joints. And I hope you remember when we started this topic, I told you first we'll discuss about how to relate, how to join, and how to blend, right? So we've already discussed about how to relate tables in the logical layer, and then how to join tables in the physical layer. Okay, we are yet to discuss about how to blend the data. Okay, and by now I think you must already be familiar with the terms related to relationship and joins. Okay, so we'll do that for blending as well, and after that we'll be getting into the most important technical part of why to and when to proceed with these features. Okay, right, so starting with blending now. Okay, so if you look into blending, this feature has already been in use right from the beginning. Okay, just like how we have joints, this feature has already been used. Now, when it comes to connecting the second, third, or nth data set, okay, we used the add button in the data source page, okay, to connect the second, third, or nth data sets in the case of relationship and joins. But now we are trying to when we are trying to blend the data, we'll be using the new data source tool in the worksheet space. Okay, we'll see where we have this tool. So I'll just open up a new workbook. The way you connect your first data set is just the same, right? From the start pane, from the start page, click on the connect pane, connect coffee shop sales. And here we are into the data source page where you already have coffee shop sales. Okay. Now for the office sales to be connected, or my second data set to be connected, if I use this add button, it means that I'm planning to relate or join my data. But that is not what I'm planning to do. I'm planning to blend my data. Okay. So if at all you're planning to blend, do not use this add button. Straight away go inside your worksheet. Okay. Once you're into the worksheet space, use this tool that we have in the toolbar, new data source tool. Okay, the cylinder with a plus icon, just click on new data source. Okay, and here you have again all the options, the complete list of data sets, cloud servers, from wherever you're planning to connect your second, third, or nth data set with Tableau. Correct? So in our case, it's just going to be our office sales. And now there's something that you'll have to make a note. See, we used the new data source tool in the worksheet space to connect our second, third, or nth data set. Okay. Now, every data set connected has its own separate data source page. Now, this was not the case when we were trying to join or relate. All the data sets that were connected with the workbook had one common. They were sharing one common data source page, right? But when it comes to blending, every data set connected has its own data source page, has its own separate data source page. Let's have a look at that. See, now I'll go into my worksheet. Okay, so there are two data sets connected. And how did we connect them? Using this new data source tool in the worksheet. We have coffee shop sales and we have office sales. Now, if you click on coffee shop sales, you'll have the, you'll have all the fields that belong to coffee shop sales. Go all the way down, click on data source. You'll be taken to the data source page that belongs to coffee shop sales. Okay, go into the worksheet again, click on office sales. If you go all the way down, click on data source, you'll be taken to the data source page that belongs to office sales, right? So when you're blending, what happens is every data source that is connected will have its own data source page. Okay. And then they would be connected with your workbook. right? So these are the data sources that we have, okay? Whereas this is the data source page and this is your worksheet space. Okay, so all your data sets will have its own data source page, and they will literally be displayed together only when you go into the worksheet space. This is how blending works. Okay, but when you were trying to relate or join, how did it work? You had multiple data sets. All of them had one common data source page, and then you were able to go inside your worksheet space. So these are the data sources. This is your data source page. All of them, they were sharing one common data source page, and then they were taken to the worksheet space. Okay, so that's how it works. Okay, so this is what happens in blending, but whereas this is the one on the right side, this is what happens when you relate or join your tables. Okay, so that's about your blending. Now, where or in which layer this feature is used? See, when you blend your data, there's no concept of logical layer, physical layer, because every data set has its own DS page, means data source page. This page that we are right now looking over here. See, this is known as the data source page, right? So when you're relating the tables or joining the tables, all the data sets will share one common data source page. But when you're trying to blend the data, every data set connected with Tableau will have its own data source page. They're going to be displayed together only in the worksheet space. So you have no other go, but it's directly in the worksheet space where you will be able to blend your data. That's the place where your feature is going to be used, directly inside the worksheet. Okay. And again, something similar to this point, where where is your data going to be combined? Only during visualization, your data is going to be combined, right? And now the next most important point is, how is my data going to be combined? What type of join is going to be available in data blending? Okay, now first we'll see how to start combining the data, and then we'll see what or how data is combined. Okay, yes, so when it comes to data blend, this is the tool. The way you connect your multiple data sets with Tableau is using, let's also connect sample superstore. This tool over here, the cylinder with a plus icon, this is known as the new data source tool. Okay, so this is how you connect your data sets. I'll bring in sample superstore as well. See, sample superstore will have its own data source page. Okay, and from the sheets that belong to, or tables that belong to sample superstore, I can pick any one. Okay, and then I can click on sheet number 1. I'll be taken to the worksheet space where I have the complete list of data sets that are connected with my workbook. But each of these data sets will have its own data source page because I've used this tool to connect them, which means I'm planning to blend them together. Okay, fine. Now, how do we start blending the data? I mean, we already know that it's directly in the worksheet space where my data is going to be combined. But how do I start blending? Okay. Now there's going to be a lot of minute points that you'll have to make a note of. Okay, just like how we had last week when we started with these topics. Okay, so again, when it comes to blending also, there'll be a lot of points to make a note of. Okay. Fine. So here we are into sheet number 1. This is a blank worksheet. Agreed? Okay. Now, let's say I would like to see, or I would like to bring in certain fields into my worksheet. Okay. So the very first column that goes into your worksheet, yes, to whichever data source that column belongs to, okay, that would be considered as your main data source, or in other words, you can say that would be considered as your primary data source. See, I'll drag and drop column from coffee shop sales. Okay, is my worksheet blank? Yes. So which is the first column that's going into my worksheet? State from coffee shop sales. So this data set called coffee shop sales will become the primary data source. You have this blue or greenish blue, or let's say blue tick that you have right next to the cylinder like icon over here. Not sure if it's blue or green, but yes, that's the tick that you have. This is one small way you can identify, okay, just by looking into these colored ticks that appears right next to the data source name. You can say, okay, blending is happening over here, right? So these are the states that belong to coffee shop sales, correct? Now let me bring in my coffee sales as well. Okay, these, or I'll just drop it into my column shelf so that we get a bar chart. So what are we doing? We've pulled the state-wise coffee sales from coffee shop data set. Okay, now what I'll do is I'll go into my office sales, right? I'll also bring in office sales measure and drop it into my worksheet. Okay, now just notice, just make a note over here. There's a different colored tick that appears right next to office sales. That's the orange tick. Okay, so orange tick represents secondary data source. Okay, so when it comes to blending, the type of join that we have is only left join. There's no other join type that you can proceed with. Only left join is possible when you blend your data in any worksheet. Okay, now you might have a lot of questions. Then why to go ahead with blending? See, if it's only left join that is possible in data blending, okay, I have different types of joins in my other features like relationship and joins, then what's the point in making use of blending? Or when do I specifically get into blending, though it's only giving me left outer join as an option? Okay, right? So we do have pros and cons in all the features. Let's discuss about that as in blending as well right away. Okay, now as you notice, these are the states that belong to my left side table or my main table known as coffee shop sales. So I have the complete list of states. But when you look into the right side table, which is my office sales, okay, my office sales and coffee shop sales have only 4 states in common, correct? Punjab is not available in office sales. So it just gives me a blank or null over here, right? So by looking into the result of, the blend that I have in my worksheet, I can clearly say that a left join is happening over here. And how do you define left join? All the values from your left side table are brought into display, and only matching values from your right side table are brought into display. If at all there's no match, it would be displayed as a null. So it is a pure left join that's happening. Which is your left side table? Coffee shop is your left side table. And which is your right side table? Office sales is your right side table. Okay, fine. Now I'll go into my sheet 2 and let's see what's happening to these ticks. Okay, so if I get into sheet number 2, all the ticks are disappeared. All the colored ticks are disappeared. Correct? Which means in sheet number 2, you can freshly start, you can freshly decide in this sheet, which is going to be your left side table and which is going to be your right side table. Okay, so in sheet number 2, I might be going to office sales. Okay, I'll pull state from office sales. So you have 7 states that belong to office sales. Okay, then I'll go into coffee shop sales. And now when I bring a measure from coffee shop sales, what would happen? How is the result looking like? You have all the states that belong to your left side table, which is office sales in this case. That is the one which has this blue tick. That's my primary data source. Okay. Whereas from coffee sales, which is my right side table, only the matching values are displayed. If there's a no match, it is displayed as null. Okay. So in a blank worksheet, from whichever data source your column goes into the worksheet first. That becomes your left side table with a blue tick, and the next data set from where you pull the column into the worksheet, that would become your right side table, which has the orange colored tick or red colored tick. Okay, that's an indication which tells you the green tick is your left side table, the orange tick is your right side table, and between those two tables, it's a left join that is possible. Okay, it's not that just because coffee shop belongs, is this whose name appears first, that would become your left side table. That is definitely not the case. So data blending gives you the flexibility of choosing your left and right side tables in every single worksheet that you create. And how is it decided? Depending on, see, I'll go into sample superstore. I have a blank worksheet. Okay, I drag and drop a column from sample superstore. That would become my left side table. So it's definitely not based on the order of how the list of data sources are displayed over here. That is definitely not going to, you know, decide the left or right side tables in any case. Okay, but it all depends on, you have a blank worksheet, from whichever data source the first column goes into your blank worksheet, that is given the higher priority, that becomes your left side table. Okay, that's how right and left tables are decided. Okay, you added sample superstore, it has a red exclamatory mark. The reason is, just click on sample superstore, go into your data source page. You would have, I think you might have missed dragging and dropping orders into the canvas area. That's the reason you get a red exclamatory mark over there. Okay. See, it's not that only the left side table is getting the value, both the tables get the value, but there's a particular point that I would like to add, a word that I would like to add there. Left table gets all the values being brought into display. Okay, it's not necessary that all of these states should belong to my right side table as well. Correct? So left join is nothing but left table will be given the first preference. It will bring all the states that belong to the left side table, and you have those office sales values. But when you look into the right side table, the measure called coffee sales that belong to the right side table, I don't have Bengal in my right side table. I don't have Tamil Nadu or Mumbai. These three states are not available in my right side table. Okay, so it would just be displayed as a null. Only matching values, only states that are matching with my left side table, the coffee sales value will be displayed for them. So that's the definition of left outer join. Okay, right. So going back, so these are the points about data blend, the way you connect your second, third, or nth data set, where exactly this feature is being used. It's directly used in the worksheet space. Okay, every data set will have its own data source page, and it's only left outer join that is possible when it comes to data blending. But even though it's only left outer join, we have the flexibility of choosing the right and left side tables in every single worksheet. So you have that flexibility, right? In one sheet, you may have coffee as your left side table and office as your right side table. And in other sheet, vice versa. In other sheet, two other data sets can be used as your left and right side tables. So it's giving you the complete flexibility of choosing your left and right side tables in every worksheet. Okay, but still, it's only this particular join type that's possible when it comes to data blend. Okay, and blue and orange ticks are the ones using which your data blending would be represented. Okay, so that's something that we know. Correct? Yes. And before we get into these 2 points, what's the basic requirement for you to successfully relate or join or blend? You should have at least one common field between them. Okay. Only if you have at least one common field, you will be able to successfully relate, successfully join, or successfully blend. Okay. And choosing your common field, common key. Okay. See, I hope you remember last week we were looking into coffee shop sales and office sales. Both your data sets did have state as the common field between them. But apart from state, region and market were also common. It's just that the column headers were different. Correct? So in that case, how do we go tell Tableau that, see, you've picked up state as a common field, which is perfectly fine. But apart from state, we also have another field that's actually common between both the tables. So please make use of them to fine tune the relationship join or blending. Okay, right? So how do we do that? We already did that in relationship and joins. See, when you're relating two tables, Tableau will pick up the common field based on the common column header, right? State has already been picked up, but apart from state, you can just click on add more fields. Okay, select a field that says region from my coffee shop is actually equal to market from my office sales. Okay, so this is how you add more number of common fields even though they don't have common column headers. Manually, we know that they're actually the same. So this is how, when you're relating the tables, you can very well add common fields. Okay, and when it comes to joining, how do we do that? We'll first have to go into the physical layer, join the tables. Okay, click on the Venn diagram like join type symbol, and this is where you already have state that has been picked as the common field. Okay, apart from state, you can just go add region from your left side table is actually equal to market from your right side. So based on which you will not only have a join that's happening based on state, but also taking region into consideration. Delhi North will perfectly be matched only with Delhi North. Okay, Delhi South will perfectly be matched with Delhi South. So state and region, combination of both would be taken into consideration based on which a join would happen. Okay, so that's how you tell Tableau about more than one common fields when it comes to joining the tables. And the same thing can be done blending as well. Okay, see now in this case, in sheet number 1, coffee shop is my left side table. Okay, when you go into office sales, when you click on office sales, as you notice, there's a chain-like symbol that appears right next to state. Okay, so this is the way Tableau is trying to tell you that state is the common field between your primary data source and your secondary data source. Okay, this chain-like symbol is the one using which Tableau is trying to represent or tell you that this is the common field between both your tables, this chain-like symbol over here. Okay, fine. Now, how do we go tell Tableau that, see, apart from state, there's also this market from office sales and region from coffee shop sales, which are actually common. Okay, please take them also as common fields between both the tables. How do we tell that? This Word file is going to help you out with everything. It has the complete list of information, right? So when it comes to blending, Tableau does pick the common fields automatically, or if at all you would like to manually decide it, you can very well do that by using the Edit Blend Relationship option under Data in the menu bar. See, if you go check your menu bar, you'll have Data in the menu bar. Click on it, and there you have an option called Edit Blend Relationship. If you get into this option, a dialog box would appear. Okay, see, this is your primary data source, and this is your secondary data source, and there are two radio buttons over here. Automatically, state has been picked up as the common field, correct? But we would like to go customize. We would like to go tell Tableau that apart from state, there's another field called region and market that are actually common between both the tables, right? So just click on custom and then click on add. Okay, so this is where you can tell region from my primary data source is actually equal to market from my secondary data source. Click on OK. Okay, might be you can try doing this right away, because I mean, all those details are available in the Word file. You can very well make use of it. Okay, but if at all you already have it open, if you're planning to work simultaneously, then you can just give it a try. Just click on data in the menu bar, get into edit blend relationship and customize the common fields between them. Okay. Fine. So that's how you do when it comes to blending. And now go into, see, coffee shop is my primary data source, and go just click on office sales, which is your secondary data source. Okay. Now just look into the chain like symbols, right? You have state, which has this chain like symbol, whereas the market that you have, market also has a chain like symbol, but that seems to have, a cross on it, or might be the chain like symbol is broken, or the link is, currently not available or something. Why, I mean, what's the difference between these two? See, Tableau is trying to tell you state and market both are common fields between your primary and your secondary data source. That's why the chain like symbol appears in the first place. Okay, both are common fields between your tables. But out of both of these common fields, state is actively being used inside your worksheet. See, state is being used inside your worksheet actively to link both your tables. That is why the chain link symbol appears to be active. Okay. On the other way around, when you look into market, market is also a common field between both your tables. So state is actively being used inside the worksheet. Okay. That's why the chain link symbol appears to be active. But when it comes to region and market, they are common fields, but they are not actively being used inside the worksheet yet. Okay, that's why the chain link symbol appears to be broken, or it says it is not being actively used currently, right? Now, if I go back to my primary data source, let's pull along with state. Let's also pull region into the worksheet. And now if you go into your secondary data source, see, you'll be able to see how the chain link symbol is active in both the cases, because both are being actively used inside the worksheet. Okay, so that's how in blending you look for the common fields or add more common fields using these options. Okay, so now that we are familiar with how to relate, how to join, and how to blend, let's get into the core topic of why and when should I use these features. Okay, see, there'll be 2 to 3 tables that is handed over to you. You have to combine them. You either have to relate or join or blend them together to proceed with your analysis. But how will you decide which feature to proceed with? Now, the client or the business, or your particular higher officials, whoever is giving you this task of creating a dashboard, is not going to tell you relate these tables, join these tables, or blend these tables, because they'll have no idea about these features of Tableau, right? They'll just give you the data and ask you for a kind of dashboard that they're expecting for. They will not know the technicalities that you have to relate your tables and then only come up with this kind of a dashboard, or join these tables or blend these tables. They'll have no idea about these features. We will be the right person to decide, okay, whether we are going to relate, join, or blend these tables. Okay, so there'll be a lot of factors that you'll have to take into consideration. Okay, what kind of output you are in need of. Okay, what kind of join you are looking for, whether you would like to see the inner join the common values between these two tables, then you'll have to go ahead with the feature of joining in the physical layer. Okay, or if you would like to create a dashboard which is going to have sheets, one sheet will have data from the left side table, one sheet will have data from the right side table, and one sheet is going to have common data between the two. For that kind of flexibility, relationship will be the best feature. So depending on the tables that you have in hand, okay, depending on the kind of output you are looking for, you will be the right person to pick the right feature out of these three. So now we'll be giving you the list of points to take into consideration. That's what we are discussing about right now. Okay, once you're clear about the points, okay, once you're clear on how each feature works, on what kind of output each feature has to offer us, based on all these points, we will have to pick up the feature, okay, that is going to suit our requirement. Yes. Okay, so two core points that we will have to look in our tables. I mean, this is going to be one of the most important factors that you'll have to think about to decide which feature you are going to proceed with. Okay, order of executing joins and aggregation, right? So when it comes to, now first we'll talk about the two existing, I mean the two features that has been in existence since the beginning, joins and blending. Then we'll see how a relationship is going to work. Okay, so when it comes to joining the data is, okay, let's call it as combined. Okay, right. So when you're joining the tables in the physical layer, data is first combined in the view area itself, in the data source page itself. Your data is combined and then only aggregated when you go inside your worksheet space. Now, what is aggregation? Aggregation is nothing but summing up your data. Okay. Now, even in sample superstore, or let's say, for example, in Jan, we did a sales of 500. In the month of February, we did a sales of 1000. So what is the aggregated value? 500 plus 1000. 1500 is the total sales done in both these months. So that's the aggregated or summed up value. Okay, so when you're joining tables in the physical layer, data is first combined in a row level manner in your view area itself and then aggregated. Okay, whereas when you blend, it's the other way around, right? So let's look into, clear-cut examples that is going to explain these points in a very detailed manner. Okay, and the next point is about difference in levels of hierarchy. Duplication is going to occur when you're joining the tables. Duplication can be avoided if you blend the tables. Okay, so this should be the first point you notice whenever data is handed over to you. Whenever multiple tables are handed over to you, make sure, just think about or just look for the levels of hierarchy between them. Now, what is levels of hierarchy? I have two sample files called sample 1 and sample 2, with which we will be discussing about these two technical points that we have. Okay. See, this is sample 1, this is sample number 2. They're very small and simple data sets. Okay, now what is sample 1 having? It has row ID, year, and sales A values. Okay, sales A sheet. Whereas sample number 2 is having, again, serial number, month, year, and sales B. Now, what's the, just by looking into both these tables, what's the instant difference that you're able to find between them? And that's a very, very important difference that we have between both the tables. See, the levels of hierarchy are different between the two. Okay, levels of hierarchy is nothing but you have only year-wise information. What is the year-wise sales in sample 1? Whereas when you look into sample number 2, you not only have year-wise sales, but under each year, what is the month-wise sales is also something that you have. Okay, so sample 1 is having year level data, but sample 2 is having month and year level data. Okay, or in other words, you can also look into this point. There's one table which is having country-wise sales, whereas in another table, you not only have country, but also there are multiple states under the country for which you have the sales value. So isn't the level of hierarchy between the two different? In this case, for every country, you will have the sales value. But in this case, for every country, you will have a list of states under them. And for every state, you will have the sales value. So that's what we call as difference in levels of hierarchy. Okay, right? So these two tables, do they have same levels of hierarchy? No, they have different levels of hierarchy, right? This is having only year-wise information, whereas this is having month and year-wise information. So this should be the first thing that you'll be looking, when you receive data from the client side or basically any data for a dashboard to be created. If you receive multiple tables that are to be related, joined, or blended, this is the first thing you'll have to look for. How is the levels of hierarchy between them? If there is difference in levels of hierarchy, then there might be duplication that would occur. Okay, if there's going to be difference in levels of hierarchy, okay, with that different levels of hierarchy, if you're going to go join your tables, then definitely duplication is going to occur. Okay, but instead, if you go blend them, duplication can be avoided. Now, what we'll do is we have these two samples in hand, correct? Yes, granularity of data. Now, granularity of data is nothing but you compare to this table that has year-wise sales. This is giving us an even more detailed or granular information for 2014. For these 3 months, this is how your year sales value has been split. So you're getting an even more detailed information in sample 2 data set. Okay, so they have different levels of or different levels of granular information is what they have. Okay, now what we'll do is we'll first go join these two tables together and I'll show you how duplication or what is the cause of having duplication when you're joining such tables that are different in levels of hierarchy. Okay, and the next point is that how come duplication is avoided when we blend them? So we'll do both these things, and after which you'll understand why this particular point of difference in levels of hierarchy is so important, why duplication occurs if you still join them together. I mean, still, even after knowing that they have different levels of hierarchy, if you go join them together, how duplication occurs and how your blending is going to avoid duplication. Okay, so we'll quickly open up a new Tableau workbook, and I'm first going to join these two tables together. Okay, so we have sample number 1. Okay, see, this is sample 1, row ID, year, sales A. And I'm planning to join them together, right? So I'll be using the add button over here. I'll bring in sample number 2. Okay, so you have sample 1, sample 2. We are planning to join them. So let's go into the physical layer. Okay, I'm joining them together in the physical layer. What happens when you join the two tables? Data is first combined. So is my data combined already? Yes. Right here in the view area itself, see, these rows belong to, these columns and rows belong to sales A, these columns and rows belong to sales B. Okay, they are right away combined. And how are they combined? What is the common field between them? See, here is the common field between them. So for 2014, of sales A, Tableau is going to look for 2014 row of sales B. and just look into this output over here. There's the same row of 2014 that is repeated for every row of 2014 in my sales B. Okay, they do not have same levels of hierarchical information, due to which there's duplication that is occurring right here. Okay, similarly, see for 2016 also you have duplicacy that's happening, right? So when you're joining the two tables which are not having the same levels of hierarchy, just because the data is combined first itself, a row level combining is happening, duplication occurs, and with this duplicated set of data, if you try to build your worksheet, what would happen? See, now my year is green in color, it's continuous in nature. I'm just converting it into discrete. Okay, so I have my year numbers, I have my sales A, and then I have my sales B. So are these values correct? Let's cross check it with our data set. See, so for 2014, is the sales value 100? No, for us it displays as 300. For 2014, is the sales value 200? Yes, that seems to be fine. For 2016, 300? No, it's just doubled up. It's 600. So we don't have the output which is as expected. There are errors in our output. Why do we have errors? Because point one, we've joined tables that don't have the same levels of hierarchy. And due to which what happened? Duplicacy occurred, because when you're joining two tables, data is combined first, and then during visualization, aggregation is happening. What is happening? For 2014, it goes, picks up these three values, sums them up together, aggregates them together, and then displays as 300 over here. Okay, so data is combined first and then aggregated, due to which duplicacy occurs. Okay, so now I hope you've understood how duplicacy occurs when you're joining the tables, especially when they are not the same in levels of hierarchy. So in such cases, it's better to avoid joining. Instead, if you go blend them together, duplication will be avoided. How come? Because when you're blending the data will first get aggregated individually and then only be combined during visualization. Because of that, duplicacy can be avoided, and as a result, you will not have errors in your output. You will have values as per expectation. Okay, so let's go do that as well. I'll open a new workbook and let's blend these two tables together and check how duplicacy is avoided. See, first I'll bring in sample 1. Okay, and we're planning to blend them together. So just go into your worksheet, use this new data source tool to connect your second data set called sample 2. Okay, it has its own data source page, correct? Going into sheet number 1. Now let me bring in my year. Okay, you will bring in your year. Okay, and then bring in sales A. Now are the values right? Are the values correct? 100, 200, 300. Yes, they look perfectly fine. Why? Because individually, okay, the data is getting aggregated or summed up. Just for the values of sales A, it just sums up the value for each year, displays the result. Now for sales B, what will happen? Individually, first aggregation will happen. Okay, for 2015, I have 3 rows. Sum them up together, aggregate them together. Okay, aggregate them together. Then that aggregated value is what is displayed in your output. So individual aggregation is first happening, and then the data is going to be combined during visualization, which avoids duplicacy. Okay, so sample 2. If you look into sales B, okay, for 2014, it's 100 plus 200 plus 300, which sums up to 600. So this looks perfectly fine, right? So when you look into blend, when you're blending data, duplication is avoided. Why or how duplication is avoided? Even though my tables are different in levels of hierarchy, they are first individually aggregated, summed up together, and then only combined during visualization. So the concept of duplication itself is avoided over there, and you get the results as per our expectation. There's no errors in our output. So the first thing that you should look for when there's data that's handed over to you, you just have to make sure that the tables don't have different levels of hierarchy. That's something you'll have to look for. Okay, and now when it comes to relationship, we already know that it's a flexible feature. Okay, based on the data that you have in hand, data is combined first and then aggregated, or aggregated first and then combined. So this concept, or this order of executing joins and aggregation is automatically decided by the relationship itself, or in other words, to define it, to explain it as per the example that we have in hand. We have these two samples, right? So if we are planning to relate them together, what relationship would do is, this check of levels of hierarchy is done automatically by Tableau. Tableau will look into these two data sets. Okay, they don't have same levels of hierarchy. Okay, let's first aggregate them individually and then combine during visualization, so that because of this, duplication can be avoided, errors in your result can be avoided. So this decision is taken automatically by Tableau. That's why we call relationship as the most flexible feature. Correct? Let's right away go relate these tables and check how duplication is automatically handled by this feature, and how flexibly this feature decides, the way these two tables can be combined in the best way to avoid duplication. We're anyways planning to relate them, so we can use the add button to connect both the data sets. Going to relate them in the logical layer. Okay, and what's the common field between them? Here is the common field between them. Yes, I'll go into before I go into my worksheet, there's something that I'd like to show you. See, just click on performance option and read what appears in the second line over here. Okay, it says, this will aggregate data before joins during analysis, preventing duplication of records or preventing duplication of aggregates. See, this decision of whether to join your data first and aggregate, or aggregate your data first and then join, this decision is taken automatically by this feature, because depending on the nature and shape of your data, it understood that they have different levels of hierarchies, and it just came up with this decision to avoid duplication. Okay, right? So if you simply go into your worksheet and try creating your chart, you'll get a result that would look perfectly fine. No duplication, no errors in your output. The result looks perfectly fine. So relationship is the always go-to feature because of its flexibility. In recent times, okay, once relationship was introduced, this would be the one that everyone would go for, because it takes care of everything automatically. Duplication, the cardinality, referral integrity, the way your data can be combined in the best manner for having a better performance. So all such topics, or all such concepts are taken care by the feature itself. So we consider this as the best feature to go ahead with. Okay, right. So we are almost reaching the end of the table. I think we hardly have 3 to 4 points. Okay. Okay, we'll just finish this up. Flexibility of deciding the join type. It's flexible. In every worksheet, you have the flexibility of deciding with what amount of data you're planning to work, right? So that's something that we've already discussed. But when it comes to join type should be decided in the data source page itself. And that is the only join type you'll have to stick throughout all the worksheets in your workbook. Okay, and for blending, we call it flexible. Why? Because in every single worksheet, you have the flexibility of deciding which is going to be your right side table, which is going to be your left side table. You have that flexibility, right? So that's why blending says flexible, right? Okay, and just one more point, calculation while choosing the common field. Now, what does this actually mean? So I hope you remember we were choosing common fields between our tables, right? State was picked up as a common field automatically by Tableau, but when you when you talk about region and market, we were trying to pick region and market as common fields. We were manually telling it to Tableau that these two are also common fields. Please take them into consideration. Okay, they just have different column headers, but they're actually the same. So we were trying to tell this to Tableau, correct? So in addition to that, say we are in such a scenario where we have two sheets over here, right? Customer and sales. Okay. And when you look into the customer sheet, you have columns like first name, last name, city, customer ID, and full name. Okay. When you look into the sales sheet, you have name, sales, and date. So actually, Tableau will tell us that these two sheets have no common columns between them. Okay. First name, last name, city, customer ID, full name, sales, and date. So according to Tableau, there are no common fields between these two tables. But what do we manually know? We manually know that full name is actually equal to name in my sales sheet, right? It's just it's just a small difference in the column header, but the meaning is absolutely the same, right? Full name in my customer table can actually be matched with name in my sales table, but Tableau will have no idea about this. Tableau will, let's see what kind of message Tableau is popping up when it did not identify any common fields between them. Okay. So I have my customer sheet. Okay. And I'm trying to relate it with my sales sheet. Tableau will give us a red exclamatory mark. Why? Because Tableau was not able to pick any matching field between both the tables. So this is how Tableau tells us about a failed relationship between both the tables. So we'll have to go help Tableau. We'll tell Tableau, see, full name from my customer table is actually equal to name from my sales table. So after that, Tableau will be able to successfully create a relationship between my tables. Okay. Now, just imagine if we did not have the full name column in our customer table. Just imagine there was no full name column in our customer table. What else do we have? How else can we combine them together? Tableau looks for common or similar, the column headers, the column names should exactly be the same. Only then Tableau will pick them as common fields. Otherwise, we may have to tell Tableau that, see, these two columns may not have the same column header, but they're actually the same. Exactly. We'll have to tell that to Tableau. Correct. Okay. Now just imagine there was no column called full name over here. Okay, so in that case, how do we combine both the tables? Again, manually, we know that exactly. First name and last name can be concatenated together. So first name space last name. Okay, so these two columns, if you concat them together, can we match it with a name column in our sales table? Yes, we can definitely do that, right? But there's a small calculation that is involved. This concatenation is involved over here. It's not a straightforward, match of columns that we just now did right here. Okay, just imagine there are no direct common fields between these two tables. So in that case, we may have to go create a relationship calculation. Okay, tell Tableau first name plus, you need a space in between both your names, right? First name space is to be specified within double quotes. Okay, so first name space last name. That's how you concatenate. So I'm having my first name, then comes a space, then comes my last name. Create a relationship calculation like this. Click on OK. This output of my calculation is actually equal to the name field in my sales table. So that's how, when you're deciding or choosing the common field between your tables, you can create such calculations. That is what this point is all about. You can create such a calculation when you are relating the tables. Similarly, when you're joining the tables also, you can create such a calculation, exactly the same thing that we did just now. Okay, go into the physical layer, try joining these two tables, but Tableau will give us a red exclamatory mark telling there were no common fields between them. You can either pull full name and name, directly create a match and successfully join your tables. But in this case, we are going to create a join calculation that would go like first name, then comes a space within double quotes, then your last name. This way of, now what will happen if we don't enter the space over here? I'll tell you what will happen, okay? But yeah, as of now, we have first name, space, last name, which is actually equal to the name field from your sales table. Look at the output. These are the two common rows that are picked up from both your tables. Okay, now what if I missed out this space over here? Okay, I just create a calculation that says first name plus last name. Tableau might successfully join my tables, but there'll be nothing in the output to display because there were no matching rows. Okay, the space is missing, right? So there'll be none of the rows that would match between both the tables. Okay, so that space over there is very important because that's how the name values appear. Okay, first name plus last name. That's how you get the output. Okay, right? So this is inner join. Only matching rows are displayed. Left join, you have all the rows from your left side table. And out of these, only the matching ones from your right side table are displayed. Right join is where you have all the rows from your right side table, from which only matching rows, as in from the left side, only the matching rows are displayed. Whereas full outer join is where all the rows from both the tables are displayed. If at all there's a match, they are displayed as one single row. Okay, so that's about the point over here. Okay, you can use calculations when you're choosing common fields between your tables. Okay, and you cannot do this when you're blending, because what do we know about blending? What do we know about blending? You have to get into data in the menu bar, click on edit blend relationships, and you normally go customize, right? When you're choosing the common fields. Okay, when you click on add, there's only an option where you can directly match, directly match the columns in a straightforward manner. No such calculations or concatenations can be done in this case. That's why we say when you're blending the tables, choosing the common field is only straightforward. No such calculations can be used. Okay, right. And this point, this is one of the, just one more point to go. Okay, but this point, I would like you to go through this point. You would like to go through as in, so I want you to go through this point. How does the data pane, I mean, this is just a point of observation. There's nothing new or there's nothing technical that we have to discuss about this. This is just a point of observation. How does the data pane look like in each of these features? Okay, there'll be a minute difference between them, but how does the data pane look like? What's a data pane? This left side space, okay, where your column headers are normally displayed, that's the data pane. Okay, so how is your data pane displayed for each of these features is just the point that we have here. A point of observation, you can just for you to get familiar with the environment. This is a point of observation that you can go ahead with. And the last and final point is from a general perspective. See, we already know what are the factors you will have to take into consideration depending on the kind of output you're looking for, choose the right feature and all of that. You know what kind of output each feature is going to offer you. Okay, so based on all these points, you will be the right person to decide the best feature for the kind of data you have in hand, right? But from a general perspective, relationship is the most recommended feature because of its flexibility. Okay, and if at all you would like the old school method, you're okay with the join types. Okay, you're fine. You love to play with the Venn diagram like symbols, the join type in the physical layer, then yes, you can definitely go ahead with it as and when required, depending on your data. Okay, similarly, blending is also like that. You can definitely go ahead with blending when you are planning to stick on to only left join. It's okay for me, I'll go with blending. Then yes, you can very well do that. But there's a specific scenario, a special case scenario where you have no other option but just to go ahead with blending. Okay, when you're working with published data sources. Why? Because for published data sources, relationships cannot be applied on them. Now, what's a published data source? See, we already know environments like Tableau Server and Tableau Online. They are sharing tools or sharing environments. Once we are done with the dashboard development, we publish it into these sharing environments, right? So it's not only a sharing environment for dashboards, but Tableau Server is also an environment where you can go publish your data sources. Okay, see, instead of pulling your data source from any other server or cloud, what you can do is you can go, it's something like a storage location. Okay, so your organization has a Tableau server environment through which you normally publish your dashboards and share it with people who belong to your organization. You can not only use that Tableau server environment as a storage space for your dashboards, but also you can store your data sources in your Tableau server environment. Have you ever wondered why do we have Tableau server as the first option in our Connect pane? Tableau Server is a sharing tool, but our Connect pane is having Tableau Server as the first option. Why? Because you can store your data sources in Tableau Server and connect that data source with your workbook to proceed with the analysis. That's why Tableau Server is the first option over here. So when you store your data in Tableau Server, we call them as published data sources. So when you're working with data sources that are published in Tableau Server itself, you may not be able to apply relationship or joins on them. You have no other go but only to blend your data when you're working with published data sources, right? So that's one small point you may have to look, just have in mind. But apart from that, relationship is, from a general perspective, the most flexible and the most recommended feature. But yes, anyways, you already know about these three features. So if you would specifically like to choose any other feature apart from relationship, then you can very well go ahead with it. Okay. So with that, I hope, I mean, as I told you, by the time we reach the end of this table, you will at least have 80% clarity of terms related to these three features and all of that. Joins can be, joins also, both relationship and joins cannot be applied on published data sources. Okay, so blending is the only option that you can go ahead, right? Yes, so still, I mean, at least 80% of clarity is, I believe, what you might have. And gradually you have to keep going through the points that we have in this table, get familiar with them, okay? Just to fine tune your knowledge on these topics. Exactly, publish data source on Tableau server, okay? Right, so with that, we are completing relationship, joins, and blending. So starting with union, now what did we discuss so far? Relationship, joins, and blending, right? So they were the features using which we were trying to append the data in a horizontal manner, right? Yes. So what were we doing when we were trying to relate, join, or blend the data? We were trying to append the tables in a horizontal manner, right? So based on common field between them, we were trying to append the tables in a horizontal manner, right? Now, when we discuss about union, union is about appending the tables in a vertical manner, or in other words, placing the tables one below the other, right? Placing the tables one next to each other was the concept of relationship, join, or blending. But when it comes to placing the tables one below the other, okay, it is the concept of union, correct? So let's see how to create a union between tables. And let's also discuss what, I mean, just like how we have some basic requirements, like the tables should have common fields between them. Only then they can be successfully related or joined or blended together. Do we have any such basic requirements for creating a union between tables? So let's look at, have a look at all these points. And before that, I'll also tell you a scenario, when we go ahead with union. Now, for example, we have 4 tables in hand, might be 4 Excel files in hand that says Q1 sales 2024. Okay. For union, do the column headers need to be the same? We'll look into all those points. I mean, yes, column headers should be the same. Okay. But what about difference in number of column headers? See, this is about placing the tables one below the other. Might be one table has 10 columns, the other table has only 5 columns. So in that case, what will Tableau do? How is it going to let us know whether it will be able to create a successful union or not? Or if our columns, I mean, if the column headers are not the same between the tables, then what will Tableau do? Will it give us a red exclamatory mark, just like how it did in relationship, joins, and blending? We look into all those points, okay? But yes, this is one such scenario when we go ahead with union. Now we have 4 different tables or sheets with quarter-wise sales of 2024, okay? Now, when you're planning to analyze the data of the full year 2024, will it not be easy if you are able to combine all these tables into one lengthy table that contains the complete data of 2024? Or will it be easy for you to analyze it in a quarter-wise manner? Definitely, having one lengthy table, one long table that contains all the rows that belong to all the 4 quarters of 2024. Okay, with that one single table, it will be very easy to proceed with your analysis, right? So that is what union is going to let us do. Okay, that is what union is going to help us with. Okay, so let's see how to proceed with that. I'll be opening up a new workbook, and before that I'll also showcase a small data set that we'll be making use of. It is known as the union sample. Okay, see, this data set, I mean this data source, this Excel file has 3 sheets: March 2019, April 2019, and May 2019. Okay, so March has columns like day, customer, sales, type. So in fact, the columns are absolutely the same between these tables. See, day, customer, sales, and type. Day, customer, sales, and type. The only difference between them is the content, the rows, right? These rows belong to the month, to the transaction done in the month of March. These rows belong to the transaction that has happened in the month of April, and this is about the May month transaction, right? So instead of having month-wise rows of transactions, it will be very easy for me if I would be able to create one single table containing all the three month-wise transactional data, so that in one go I can proceed with my analysis, right? So for that, I would like to place the tables one below the other. And how are we going to proceed with union in such a case is what we are going to discuss. Okay, so I have a new workbook that's opened up, and then I'll just connect my union sample. Okay, now there are two ways of creating a union. Okay, one is go into the physical layer. How do we go into the physical layer? Double click on your logical table. That will take you to the physical layer. Okay, now in the physical layer, we have April 2019. If I drag and drop March 2019, if I place the tables one next to each other, what would happen? A relationship or join or blend would be created. Correct? If I'm dragging and dropping March 2019 and placing it in a, if I'm placing them one next to each other, a join would be created between them. Correct? As in, it means a horizontal way of appending the table will happen, right? But if I place March 2019 below April 2019, I will be appending the tables in a vertical manner. I'll be placing the tables one below the other, which will let me create a union between them. See, look at the output. We have these three rows that belong to April 2019, and then we have these three rows that belong to March 2019. So I get one lengthy table that is giving me data both from as an April sheet and March sheet. Similarly, let's bring in May as well. So you get one lengthy table that has data related to April, March, and May 2019. And in this case, all the three sheets exactly had the same type, same column headers, and same number of columns. Correct? Everything was just the same between these three sheets, just the content was different. This was April transactional data, March transactional data, and May transactional data. Okay, we can do this in Excel itself, but what's the advantage of doing it in Tableau? Now the thing is, I mean, if you can do it in Excel itself, then yes, you can proceed with it. But sometimes Excel also has a row limit. Correct? I think you have a certain amount of rows only that Excel can hold on to. Yes. For let's say you have three big Excel files that needs to be combined together into one single table. Yes. So in that cases, Tableau, using this feature in Tableau is definitely going to be helpful, right? So that's might be, I think 1 million records, or it's exactly some number we have. Okay, one exact count of numbers or number of rows that Excel can hold on to. Yes, so if you have three such huge files, combining them into one single Excel file will not be possible. In that case, this might be a better option for us, right? So this is the first method of creating a union between tables by going into the physical layer, dragging and dropping the tables one below the other. This is how you create a union. This is the first method using which you create a union between the tables. Okay. Now there's another method using which you can create a union. I mean, the result is going to be the same, but the way you do it is different. Okay. you have a button or a tab called New Union right here. Yes, just double click on it and your new union, or basically your union dialog box, appears, and it has two tabs. Okay, one is known as the specific or manual tab, and the next one is known as the wildcard or automatic tab. So we'll start with a specific or manual tab. Now again, there are few points for you to observe and make a note of. Okay, now this connection space over here, it says drag tables here. This is the specific or manual tab. Okay, so manually you'll have to drag and drop the tables over here, click on apply, and that's it. You get the same output. Okay, but this was through the union tab, that dialog box that opened up through the new union tab. Okay, so two ways you create a union: one by getting into the physical layer, dragging and dropping the tables one below the other, or by using the specific or manual tab that appears when you double click on the new union button that we have right here. Okay, fine. So this is about combining or creating a union between tables that belong to the same Excel file. Now, what about multiple Excel files? Okay, so there's one more sample that I have known as union sample S2. Okay, see, this is union sample 2, which is again having three sheets called August 2019, September 2019, and October 2019. Okay, so I would like to combine those three sheets of March, April, May with these three sheets of August, September, October, but they belong to two different Excel files. How are we going to do it? Okay, now why don't we just click on add, connect the sample 2, bring it over here. So now we have August, October, September. Here we have April, March, and May. Okay, so we have all the 6 sheets over here. Now, can we directly go into the specific or manual tab, pull all the 6 sheets over here and create a union between them? Let's see if we can do that, right? So now, see, there's one important point that you'll have to make a note. From where are we double clicking the new union button? See, you have it now. Right now we are under union sample, correct? Double click on new union. The connection name over here tells you union sample. Okay, if you go into sample 2 and then double click on new union, the connection name would tell you union sample 2. Okay, that's the first point you will have to make a note. Next one, let's try dragging and dropping the tables. Okay, see, the connection name is union sample because I had clicked on new union when I'm into the union sample tab. Okay, just drag and drop these sheets, March, April, and May. Let's go into sample 2 and I'll try dragging and dropping August, October, September, but it is not letting me do it. Okay, the specific or manual tab will let you drag and drop the sheets that only belong to this particular Excel file known as union sample. Okay, so why the connection name is union sample over here? Because I had double clicked on new union when I was into union sample. So it lets me drag and drop tables that only belong to this particular connection name or this particular file. Okay, and yes, it's not letting me drag and drop the sheets that belong to a different Excel file other than the connection name that appears over here. Then how else can I combine these sheets together? 3 sheets from union sample, 3 sheets from union sample 2. How am I going to combine all the 6 different sheets together? How am I going to create a union between them? Okay, so that's why we have the wildcard or automatic tab. Okay, so this is the tab using which sheets from multiple files are going to be combined or created a union with each other. Okay. Now, before we discuss about the wildcard or automatic tag, there's one important thing that I'd like to tell you. Okay. See, now when we were discussing about relationship, joins, and blending, okay, I have the customer data in an Excel file, and then I wanted product data from an SQL table, and then I wanted some accounts related information which was present in an Oracle table, right? So Excel file, SQL table, Oracle table. Were we able to or can we relate, join and blend these tables with each other? Definitely yes. No matter where your data is from, one table might be from an Excel file, one table might be an SQL table. Okay, any such combination of data sources can be related, joined or blended with each other. Okay, this was definitely possible. And we call this type cross DB or cross database relationship join or blend. Why cross database? Because they're not of the same type. They're not of the same format, correct? My one Excel file format is getting connected with an SQL table from an SQL server. So it's a cross connection that's happening. We call it as a cross database relationship join or blend. Okay. But when it comes to union, okay, you can combine multiple Excel files together. You can create a union between multiple Excel files, or you can create a union between multiple tables of your SQL server or multiple PDF files. Okay, so it's like when you're planning to create a union, they should belong to the same family or the same file type. That is very, very important, which means when it comes to union, a multi-database union is possible, but a cross database union is not possible. What does this mean? One Excel file with one SQL table. A union between these two is not possible, right? This crisscross connection between databases and file types might work in relationship joins and blending, but it does not work when it comes to union. If you can have multiple files between which a union can be created, but they should belong to the same file type. Multiple Excel files, yes, it's a multi-database union. Multiple PDF files, yes, they belong to the same file type. We call it as a multiple redshifts, yes. Multiple SQL servers, yes. Multiple oracles, yes. But they should belong to the same file type. That is very, very important. Okay. We can have two Excel files that have slightly different column headers, yes, but we cannot do a union between one Excel file and an SQL server. Right, that is definitely not possible. Or one Excel file, one text file. No, not possible. One text file, one PDF file. No, not possible. Union between them is not at all possible. Cross database union is not possible in Tableau. Only a multi-database union is possible. Multi as in all those files or multiple tables should belong to the same file type. Okay. Now, this could be a very, very helpful, or this could be a very interesting answer that you can give in when such questions are put up in an interview. See, now there might be a generalized question in your interview that is something like, name a challenge, or can you let us know one challenge that you faced in your previous projects, in your previous Tableau related projects? Okay, or what feature do you think is still missing in Tableau? How can you, how can you come up, or how can you give, suppose you are planning to give a suggestion to the Tableau software company, this particular feature is missing in Tableau, what would that be? Or what is the challenge because of some missing feature in Tableau? You had faced a lot of challenges, okay? And how will you, and what particular feature is that you feel is missing in Tableau? Some question like this. This is just a generalized question, but this might test you how deep your Tableau knowledge is. Okay, only if you have worked with Tableau previously, you would have come up with such challenges, correct? So that's the kind of question they might put up. And if you are only aware of the topics or features on a high level, you don't have a deeper level of understanding, you might not have an answer for this. You might not have a good answer, or I would say a very interesting answer for this, right? But this particular point about union will be the best answer for all such questions that I just now mentioned. When it comes up in an interviews, you can just tell them that, see, we do have a lot of interesting features, interactive features in Tableau, but still when it comes to union, it is only letting us create a multi-database union. It's not letting us create a cross database union. So this deep level of understanding will be possible only if you've really worked with a software, right? So only if you've come across such a situation where you had to create a union between two tables from two different sources, but you were not able to, then you would have, felt a little difficult. You would have, tried different solutions to come up with an answer for this. So that's when you can you can really tell them that this was one of the biggest challenge that we faced, and we had to might be export. I had one Excel file and one SQL table, but in order to bring them, in order to make them, as in order to make their sources to be from the same file type, I had to export my SQL table into an Excel file first and then create a union between them, which is something which is an additional task that we are doing because of this feature that's missing in Tableau, right? So this kind of an answer will be very interesting if you can come up with when challenges that you faced so far, when such questions are put up in an interview. So, I mean, the point is very simple. Only multi-database union is possible in Tableau. A cross-database union is not possible. So you can just explain this point for such questions. Okay. But yes, this is the whole concept. Now, multi-database union, how to create a multi-database union? This is the one that we will be achieving using the wildcard or automatic tab. Okay. Yes. So in our case, I'm just double clicking on new union. I'll go into my wildcard or automatic tab. Now the next question, I have multiple Excel files that needs to be combined or created a union with each other. Now, first of all, how did Tableau know that I have multiple Excel files? How did it decide the file type? Because I've connected an Excel file with Tableau, I've double clicked on new union when I'm into that Excel file. So that's how it fixes the file type. Okay, so Tableau knows that, okay, you are going to combine multiple Excel files together, right? Next one, search in. Now this first line over here is going to give you the path information. It's a read-only path information that Tableau is, uh, you know, it's letting you know just for your reference purpose. See, this is the particular folder from where your input file has been connected with a workbook. So this is the current folder where Tableau is going to perform a search during the wildcard search that would happen over here. It's a read-only path information, path of the input file that is connected with your workbook. Okay. Okay, next, these two are the most important points for you to make a note of. This is how Tableau will perform a search. You are going to help Tableau what kind of information it is going to search in your Excel files. Okay, the first one says sheet names. Okay, now matching pattern, right? Now what we shall do is, now what is our first requirement? I have union sample with March, April and May data. In union sample 2, I have August, October, September. I would like to combine these 6 sheets together. Now what's the common, what's common between their names? If you just have a look at them, they have a common suffix called 2019, correct? Common suffix called 2019. So you can just use that as a pattern. See, using this asterisk or star that we have, this is how you enter matching patterns. This is how you enter the wildcard matching patterns when you're trying to create a union. Okay, so I'll just say asterisk 2019. Asterisk 2019 is nothing but something something 2019. So my sheet name is going to end with this particular suffix called 2019. Okay, and in my workbook namespace, I'll just leave it blank. Blank is equal to include all. So now if I go click on apply, what will exactly happen is Tableau will go into this folder. Okay, this folder, where exactly do we have that folder? Yeah, this particular folder. This is where Tableau will go into. Okay, it will go include all the Excel workbooks. It will go search in all the Excel workbooks that are present in this folder, and it will specifically look for sheet names that would end in 2019. Okay, that is what Tableau is going to perform when I click on apply right now. Okay, let's see what happens. I'll click on apply. It will take a little time because it has to go through all those Excel files, pick sheets whose name ends with 2019, bring them into your Tableau's workspace, and a union has to be created between them. Yes, you can just check. See, these are the sheets that belong to union sample S2, and these are the sheets that belong to union sample. All those rows tables are placed one below the other. So in the end, you get one single table with all the 6 different sheets related data. So will it be easy for us to go analyze now instead of having 6 sheets in hand, perform analysis on every single sheet individually? Instead of that, this looks much more easier, correct? So that's how you go ahead with a wildcard search. Multi-database union can be achieved using the wildcard or automatic tab. Okay, so your patterns can be like ABC asterisk. ABC is my prefix. So using the common prefix, I'm trying to look for sheet name patterns, or it can be something like asterisk ABC asterisk. Okay, this can also be like something something ABC something something. Okay, so these kind of patterns is what you can make use of. Now let's try something else. Now I'll use the pattern called asterisk sales. Now we do have multiple sheets in our in our multiple Excel files in our folder with sheet names ending with sales. Coffee shop sales, office sales. Okay, so let's bring all those sheets together, but those sheets do not have common columns between them. So let's see how Tableau is going to handle it. I'll click on apply. Now, in a relationship join or blending, if we don't have common columns between them, what will Tableau do? It will give us a red exclamatory mark, alert message telling, see, they don't have even one common field, so I cannot relate or join or blend them together. It's a clear-cut answer given by Tableau. But what about union? See, I'll just scroll to the rightmost part of our table and you'll be able to see these are the rows that come from coffee shop sales. As you go down, these are the rows from office sales. These are the rows from some other Excel file whose sheet name itself was sales. Okay. Now, these tables called coffee shop sales, office sales, they actually don't exactly have the same number and type of columns between them. But still, Tableau has just placed them one below the other. Okay. And it has given you the output for whatever union you wanted to create. Whatever tables that you wanted a union to be created between has been created, and you have the result right away. But do you think this seems meaningful? Right? Though a successful union has been created, there's no point in creating this kind of a union with having so many null values, right? So when union is the feature that you're working with, we will have to take care, or we will have to choose the right kind of tables. We'll have to choose tables that exactly have the same number and type of columns between which we are trying to create a union, and then proceed with an analysis which seems meaningful, right? No matter what tables you give Tableau, it is simply creating a union and giving us the result or output in our view area. But that doesn't seem meaningful. Tableau is not bothered about it. Okay, but we'll have to pick up the right tables or the right scenario where union is actually going to be meaningful and helpful in our analysis. Okay. So yeah, and what is the scenario that we use union in MNCs? This is one important point, as I told you. We normally have quarter-wise files. See, the client is giving us quarter-wise sales sheet. Okay, Q1 sales sheet, Q2 sales sheet, or might be we have 4 Excel files. They are quarter-wise data. I would like to combine them, combine all the 4 quarters together into one single table so that a year-wise analysis can be made. Correct? Or let's say you have employee data that's coming in, but you have it in a department-wise manner. Sales department data. Okay, you have sales department data. Let's say you have the employee ID, employee name, all the employee related details. Okay, uh, this is just meant for the sales department. Employee name, employee might be ID, and then employee address and all of that, the complete employee information. You have the same set of employee details for every single department, but they are present in 5 different Excel files for 5 different departments. Okay, so I would like to get one whole file known as the employee details. So I can create a union between them, okay, and just have it as one single file. If someone is asking me, give me the employee information, I can just get into that file, and no matter to which department they belong to, I can fetch their contact details, and it'll be easy for me to handle the combined data, by creating a union between them, right? As you said, weekly performance is also something. Any such example where you feel the data is split into multiple files which can actually be combined and maintained as one single file, you can very well go ahead with union. Okay, and what is the alternative for cross database? I think exporting is one common thing that we've been doing, one easy and common method. So if you have SQL tables, Oracle tables, okay, or any other server or cloud table, I think one common thing that we can do between them is exporting them into a, might be CSV file or an Excel file. Okay, just export them into one common file format and then create a union between them. But this is definitely additional work from our end. But yes, there's no other option. This is definitely one challenge that we will have to face if we are put in such a scenario, because a cross database union is not possible in Tableau. Okay, right. So a little more about the wildcard or automatic tab, just a few more points. See, just like how you give sheet name patterns, you can also give workbook name patterns. In our case, now we have Excel files that end with this suffix called sample, correct? If I'm going to say asterisk sample, I'll be pulling sheets from join calculation sample, live versus extract sample, let's say union sample. Okay. Yeah. So if I am adding something like this, okay, asterisk sample, and this is not case sensitive. So you can very well use lowercase, uppercase, that wouldn't be an issue. It's not case sensitive. Okay, now this is going to be my suffix asterisk sample dot xlsx. Now if I click on apply, I'll be getting all the sheets that belong to workbooks as in Excel files whose name ends with sample. It's not the sheet name, it's the Excel file name itself for which a pattern has been specified. Okay, so that's how this particular workbook name works. And then your next question was about, in cases where I'm planning to create a union between files, all those files should be kept in the same folder. Otherwise, it is not going to work. See, that's a very important point, because the search in path information is only going to search in the folder, in the current folder, from wherever your input file has been connected with Tableau. Okay, or a slight search expansion is possible. See, expand the search to subfolders or expand the search to parent folders. Might be this is the maximum search expansion that is possible. Okay, this is the, you can either have your files in the current folder or in your subfolders or in the parent folder, but nowhere apart from this. These are the three different places to which your search can be expanded during the wildcard, wildcard search that is happening for a union. Now, what do we mean by subfolders and parent folders? This is my current folder. These are my subfolders. Okay. And the folder to which my, this particular folder, this is my parent folder, right? So that's how, these are the three different places where you can have your files, and an expansion of search is possible in these three places. Okay, right. Parent one, yeah, parent. Now, if you look into my desktop, now I have a folder called updated Tableau PPT. Now, this folder, correct? This updated Tableau PPT. What is the parent of this folder? My desktop is the parent of this folder. Okay, as in, where does this folder belong to? It belongs to my desktop. So that's the parent of my folder. Or in other words, let's say you have, okay, I have something called new folder. Okay, now what's the parent of my new folder? To which folder this belongs to is its parent, correct? So my data sets is the folder to which my new folder belongs to, correct? So the parent of new folder is my data sets, to whichever folder that belongs to. I hope I wasn't confusing you. Okay, or let's say pivot file, right? So this pivot file, this is my current folder. The folder to which this belongs to, this pivot file belongs to, becomes its parent. Okay, that way. These are the three places where you can expand your search when you're into the wildcard or automatic tab. What is the alternative for cross database union? As I told you, exporting is the alternative. Exporting as in, I have 3 SQL tables and then 2 Azure tables, okay, and 1 CSV file. Okay, I would like to combine all of them together using my union option, but they are from different sources or different databases, different file types. I'll not be able to create a union between them in Tableau. So let's make all of them, as in let's bring them down to a situation where they belong to one single family. Okay, so I'll be exporting both my Azure tables into a CSV file, all 3 SQL tables also into a CSV file. Now all of them belong to the CSV family. Okay, I can very well create a union between them in Tableau. Okay, that's the only option we have. I know it's a little work from our side, but no other go. We have to proceed with such options or solutions when we have to go ahead with a cross database union. Okay, right. Okay, so with that, we are done with module number 1. We are starting with module number 2. So module 2, I know module 1 was very lengthy, okay, but it's all about setting up the connection, okay, uh, as in setting up, preparing the data with which you are going to proceed with your analysis. So that's very important, right? You should be, what and all data is handed over to you, you'll have to combine them, bring it into a good shape so that you're ready to proceed with its analysis, right? So yeah, so that was all about module 1. Okay.
Just a quick info, guys. Intellipaat offers a Tableau course. Through this course, you will learn various techniques like connecting to data, transforming data, working with calculations and expressions, visualizing data, and much more from the top industry experts. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth.
Okay. Now, all the topics in module 2 are going to be very interesting and fun to work with because they are going to add interactivity to your dashboard. Now, what's interactivity? Anyone who is using your dashboard should be able to analyze data based on their requirement. Correct? That is what interactivity is. And one such important feature which will add interactivity to your dashboard is filters all about. Okay. Now, the definition of filters is it narrows down the data to focus on relevant information. Okay. Now, just imagine you have 4 different regions. Okay. Let's say 4 different regions. South, north, east, and west. But you are the regional manager of, let's say, the western region. Will you be bothered about the other regional information or the data related to the other regions? You would like to focus only on western region data, correct? So in such a case, you can apply a filter narrowing down the data to focus only on relevant information. Okay, right? You can apply a filter telling, give me only Western region data. So just like how, content goes through a sieve or a funnel or a filter paper and only the, only whatever had to come out will come out. Similarly, you are filtering down the data or narrowing down the data so that you can only focus on whatever you are in need of. That's filters all about. Okay. Now we have a specific order. We in fact have different types of filters in Tableau, which is again a very, very important interview question. There'll be a lot of questions related to filters as well. Okay. Because there are 5 different types of filters. Okay. What are the 5 types? 5 major types. And then we have, few other, let's say few other smaller or less prioritized type of filters. Okay. But the most important ones, or the ones that you will have to answer when such questions are put up in an interview, is these are the 5 major types of filters: extract filter, data source filter, context filter, dimension filter, and measure filters. Okay, 5 important filter types. See, sometimes we will go apply a context filter first, and then we'll go apply a measure filter. Then we'll go apply an extract filter. No matter in which order we apply the filter, Tableau follows a specific order in executing them. Okay, so again, just like how we have nuances or minute things to make a note in whatever previous topics we had discussed, similarly in filters also we have certain minute points that you'll have to make a note of, try to understand. Why do you think, or what do you think is the reason we have to understand how Tableau actually works? Okay, see, only if we understand the language in which, or the method in which Tableau is working, okay, if we understand the way Tableau works, it will be easy for us to get get whatever output we are looking for. As in, through the way Tableau works, we can if we understand that method, it will be easy for us to fetch whatever output we are looking for in that exact method how Tableau works, right? So though we have 5 different types of filters, and no matter in which order you apply the filter, Tableau follows a specific prioritized order in which it is executing them, and understanding that is very, very important. And it's definitely going to be a very interesting topic because we have examples where I'll explain you about the theoretical points and we get into practical hands-on examples. Okay, so what are the 5 types of filters? Extract filters, data source filters, context filters, dimension filters, and measure filters, right? So starting with, now first we'll just talk about these 2 types. Okay, then we will get into the rest of the filter types. Okay, so as of now, just think about these 2 types, or just focus on these 2 filter types. Okay, the first one says extract filter. As the name tells you, this is going to work only in an extract mode. Okay, it is known as a precondition filter. It is executed before the extract creation. Now what do we know about an extract mode? We know that an extract mode is where my data source is not going to be directly connected with Tableau, but a copy of my data is going to be taken, saved using the .hyper file extension. That copy is then going to be connected with my workbook of Tableau, correct? That is what happens in an extract mode. Okay, but this extract filter, it is a precondition filter. It is executed even before my extract gets created. And as a result, ultimately what would happen? It is going to affect the volume of data with which my local copy is getting saved. Okay, only the filtered data will be saved as an extract file. So this is how you reduce the amount of data with which your local copy is getting saved. Okay, so your extra, so that there are certain key terms that you'll have to remember. Okay, extract filter is applied only in an extract mode. It's known as a precondition filter. Why precondition filter? Because it is executed before your extract creation. Okay, I hope you remember there'll be a save as dialog box, save extract as dialog box that would appear when you go into an extract mode. Yes, you'll be saving your extract file, your .hyper file under my Tableau repository. Okay, so before your hyper file is getting created, your extract filter will be executed. That is why the term pre comes over here. Precondition filter is nothing but before, prior, okay, to your extract creation, your filter would be applied. That's why we call it as a precondition filter. When we look into 2 or 3 examples for extract and data source filters, why precondition, why post condition, that's when you'll get a complete clarity. Okay, for sure you will get a clarity after that, right? And in contrast to extract filter, we have the next one that comes in priority. So this is the filter with highest priority, known as extract filters, whereas the next level of priority is given to data source filters. Okay, this is something that can be applied both in a live mode and in an extract mode. We call it as a post condition filter. Why? Because it is executed after the extract creation. So this is executed before the extract creation, and because of that, it is impacting or affecting precondition. Tableau is giving the priority for these filters. We are not prioritizing them. Okay, Tableau is following this level of priority, or Tableau is giving certain filters with these levels of priority or importance. So it's telling us, see, this is my prioritization way. I will prioritize extract filter first, then data source, then context, then dimension, and then measure filters. So you have to know Tableau is telling us you have to know my prioritization, levels, and based on that understanding, make use of these filters. That is what we are trying to understand now. How Tableau is treating these filters, what level of priority Tableau is giving to these filters. On that basis, we will have to make use of them. Okay, so data source, it's a post condition filter. So only after my extract gets created, as in my hyperfile will get created, will be saved, and only after that, to the background query during visualization, my data source filter will be applied. So my hyperfile that is getting saved will in no way be affected by the data source filter. I know there are a lot of points which may confuse you as of now, okay, but I've tried to limit it as much as possible. I've just tried to give a very crisp and straightforward, to the point explanation right here. Okay, so filters. Filters are going to help us narrow down the data to focus on relevant information, right? You may have 3 different countries related data, but you are planning to focus only on data related to one particular country, right? So you can apply a filter and make sure only those many number of rows, or that particular country related data is displayed on your worksheet. That's how you can apply filters and focus what you're actually in need of, right? We have different types of filters, right? So we have extract filters, data source filters, context filters, dimension filters, and measure filters. Okay, Tableau follows a specific order in which it executes these filters. So it gives extract filter the highest priority, then comes the data source filter, then comes the context filter, then comes the dimension filter, and finally we have the measure filters. Okay, so these are the 5 different types. So what is an extract filter? Now we'll just discuss about the first 2 as of now, and then we'll move on to the next 3 types. Okay, so extract filter, as the name tells you, it can only be applied in an extract mode. It's known as a precondition filter. Why precondition filter? Because it is executed before the extract creation, right? And because it is executed before the extract creation, the extract that is getting created, the local copy that is getting saved under my Tableau repository, will only contain the filtered data, right? Then we have data source filters, which can be applied both in a live mode as well as in an extract mode. So when it comes to live mode, it's going to be simple and straightforward, because out of these 2, we only have data source filters that can be applied in the live mode, correct? But when it comes to extract mode, that's where a slight confusion comes in, because in an extract mode, you can apply both your extract filters and your data source filters. So that's where we'll have to make note of some important points to avoid confusion. Okay. It is known as the post condition filter, right? Data source filter is known as the post condition filter, which is executed after the extract creation, which means your .hyper file gets saved. After it is saved, your data source filter is going to be applied only to the background query during visualization. So our hyperfile that is getting saved is no way going to be affected by the data source filter. Okay, so with these points in mind, let's get into an example during which let's see if you're able to guess what will be the amount of data with which our local copy is going to be saved after applying certain filters. Okay, so that's when you'll understand on what basis these filters are executed by Tableau, how the prioritization is given by Tableau, and all of that. Okay, and before we begin, it's actually not mandatory that you have to apply extract filter, all of these filters in a single workbook. It's not mandatory. But in case if you apply both your extract and your data source filter, how is the output going to be? You should be aware of that. right? So for that reason, we are taking this particular scenario where in case you apply both the filters together, what is it you will have to make a note of and what kind of output you should expect for. That's the reason we are getting into this example. Okay, but otherwise it's up to you. You can either apply extract or data source or any of these filters or any of 2 or 3 together. That's up to you. But we are looking into the worst case, I mean, not the worst case scenario, but the scenario where if at all you apply both together, what kind of output you will be, you should expect for. Okay. Anyway, so we'll open up a new workbook and by default, whenever you connect, and we are moving back to our sample superstore data set. Okay. So I'll just connect our sample superstore. Okay, and by default, whenever you connect a data set with Tableau, you will be in a live mode of connection, right? So in a live mode, out of these two, out of extract filters and data source filters, it's only data source filters that can be applied in the live mode. Okay, so where do we have it? You have, I mean, in the right hand top corner, you have a button called add, correct? So you just have to click on that add button. Your edit data source filters dialog box opens up. Okay, you just have to click on add again, and then you can choose any field on which you're planning to apply a filter. We'll start with category. Okay, I'll click on category and then I'll click on OK. So out of these 3 categories, we'll go through the tabs, the radio buttons and all of this. Okay, but as of now, out of these 3 categories, which category related data you're planning to focus on, or you're planning to apply a filter on which category? We have furniture, office supplies and technology, right? So I'll click on, let's say, furniture. I need, or I'm planning to focus only on furniture related data. Click on OK. So this is my data source filter applied on the field called category, which keeps only furniture related data, right? So as we know, what is the total number of rows that we have? 9994 rows of data is what we have in sample superstore, especially the orders sheet, correct? Now, after we've applied the filter, I'll just click on OK and you'll be able to see if you look into the column called category, you will only have furniture related data. Why? Because a filter, see this view area, what is the view area? It's the reflection of our data from sample superstore, correct? So at the data source level itself, at the sample superstore level itself, a filter is applied, okay, such that it gives us only furniture related data in the view area. So now when you go inside your worksheet and when you try to build your worksheets and dashboards and so on, you will only have furniture related information because you've applied a data source filter. Okay, see, you've applied a data source filter that is giving you only furniture related information because that is what you wanted to focus on. Okay, that's about the data source filter. So this seems to be quite simple and straightforward. Okay, now moving on to the next filter type known as the extract filter, right? See, no matter in which order you apply the filters, Tableau follows its own prioritization order in executing them. Okay, so now we have our data source filter, okay, which was applied in a live mode. So it was pretty straightforward. Now I'm planning to move into an extract mode. Okay, so when we move into an extract mode, we will have an option to apply both data source filters and extract filters, correct? We've already applied a data source filter. Now, what's the data source filter that we've applied? On category keeps furniture data. Yes. Now, along with this data source filter, I also would like to add an extract filter, right? So click on the edit button that appears right next to extract, and you'll have a dialog box that will open up, which seems to be familiar because we've used the incremental refresh option right from here. Okay, and now we are planning to make use of the filter option. Okay, just click on filters and see there's a small suggestion that Tableau is trying to give you. It says, now what is this filter? Category keeps furniture. Tableau is telling us you've already applied such a data source filter. And what was our data source filter? It was applied on category and it keeps only furniture related data. Correct? Yes. So Tableau is telling us, it's giving us a suggestion that you've already applied a data source filter on category column that keeps furniture related data. Okay. If you want, you can retain the same as your extract filter. This is the kind of suggestion Tableau is trying to give us. Okay. But we are not going to retain the same. I'll just remove it. I'll add a new field on which my extract filter is going to be worked on. Okay. Might be I'll go down and choose region. Okay, so out of these 4 regions, I'll pick up central. You can also multi-select. Okay, but now keeping it simple, I'll just need the central region data. So this becomes my extract filter. Okay, so you just have to remember these. What is my data source filter? Category, which keeps furniture data. And what is my extract filter? Region, which keeps central data. Okay, just click on save settings. Okay, and now when I try moving into my worksheet, Tableau is asking me to save my extract as. Correct? Now this is where you will have to tell me what will be the amount of data with which my hyperfile will be saved. I'll give you 3 options. Okay, so you have to remember certain key terms. Okay, we are working in an extract mode. We've applied a data source filter that keeps furniture related data, and we've applied an extract filter that keeps central region related data. Okay. Data source filter is a post condition filter executed after the extract creation, whereas extract filter is a precondition filter executed before the extract creation. Okay. Having these points in mind, you will have to tell me what will my hyperfile contain? Okay, 3 options. Option number 1, it will contain only furniture data with all regions. Option number 2, it will contain only central region data with all categories. And option number 3, it will have a combination of furniture under central region data. Okay, so what are the things you have to keep in mind? My extract filter is going to be executed before the extract creation. Now, what are we trying to do over here? We are trying to create our extract file. Okay, so out of these 2 filters, it's only the extract filter that would be executed before the extract creation. My data source filter will be executed after the extract creation. Okay, let's look into the answer for this. Okay, now I would say the answer would be option number 2. Let's see why. Okay, see, we had applied. Now once again I'm telling you, we applying the filters in any order, okay, is okay, but Tableau will have its own prioritization of executing them, which is the most important part. You may apply the filter in any order, but Tableau will have its own prioritization, order in which it would execute the filters. Correct? So in that manner, we have our extract filter and data source filter. Now, what are we trying to do over here? We're trying to create the extract. So it will only be your extract filter that is going to be executed before the extract creation, which is going to affect the volume of data in my extract. So the central region data filter will be applied. Only the central region data with all the categories will be saved as my hyperfile. Okay. And once your hyperfile is saved, and then connected with your workbook. During visualization, whenever you drag and drop a field into your worksheet, a background query will go all the way to pick up that column related information, right? That is when your data source filter would be applied. Okay, data source filter is executed after the extract creation, only during visualization. This is in no way going to affect my hyper file, right? So we'll do that practically. Now it is asking us to save. We have a data source filter applied. We have an extract filter applied. Okay. And then it's asking us to save our hyper file. So when I'm saving, when I'm creating this hyper file, my extract filter would have been executed with only central region data. My hyper file will be created. It will contain all the categories. Okay. My data source filter is in no way going to affect my hyper file creation. Correct? So let's click on save. The hyperfile will be created and will be taken to our worksheet space within a few seconds. Correct? Let's go check. Now the hyperfile that is connected with our workbook is present under my Tableau repository. Correct? Which one? The one that we just now saved. Only central region data. Let's open this hyperfile and see what is present inside it. Okay. See, as expected, it has only central region data. But if you look into category, it's not only furniture data, but you have all the categories. You have technology, office supplies, everything, which means my data source filter has in no way affected my hyperfile creation. Okay, it is only affected by my extract filter, right? Yes, this is the hyperfile that is connected with our workbook over here. So if you pull region, you will have only central region data because your hyperfile is also having only central region data, correct? But when you look into category, now the category column in my hyperfile contains all the three different categories, correct? It has furniture, office supplies, and technology, right? But now, at this moment, when I'm trying to visualize using the column category, when I drag and drop this field into my worksheet, a background query will run all the way to my hyperfile to pull the category column related information, right? So at this moment, my data source filter will be applied such that it brings only furniture data from the hyperfile, correct? So hyperfile contains all the three categories, but to the background query, my data source filter is applied such that it brings in only furniture related data. Okay. Yes. So now I hope you're clear why option number 2 is the answer for what will my hyperfile contain after applying such an extract filter and a data source filter, right? So we call extract filters as permanent filters because your hyperfile is permanently created with only that amount of data, but your data source filter is considered to be a temporary filter. See, in this case, okay, in this case, our hyperfile contains all the three categories, correct? But for now, for time being, for temporary purpose, I'm planning to see only furniture related data. Okay, but I can very well go change this filter. I can just click on edit. Okay, I can go edit my data source filter. And let's say I need office supplies data. Okay, now can I change this? Very well, yes. Why? Because my hyperfile anyways contains all the three categories. Okay, but for time being, I need only office supplies data. See, you now have only office supplies data. So an extract filter is a permanent filter, whereas a data source filter is a temporary filter. Okay, so that is how or that's the reason why we call extract filters are preconditioned filters. They're executed before the extract creation, due to which the amount of data with which your hyperfile is getting saved is affected okay, by the extract filter. Whereas a data source filter is a post condition filter executed after the extract creation. Okay, so our hyperfiles are in no way affected by the data source filter. Okay, so that's about extract filters and data source filters. Next, before we discuss about context filters, what we'll do is we'll first see what's a dimension filter, because only when you know what is a dimension filter, we'll be able to discuss what a context filter is all about. Okay, so dimension filter, that comes fourth in priority, and then we have measure filters, which comes fifth in priority. Okay, as the name tells you, when you apply a filter on any dimension, we call it as a dimension filter. Okay, I'll go back to sample superstore. Right, so we have our filter shelf, correct? See, when you look into the worksheet space, we have the column shelf, row shelf, page shelf, filter shelf, and marks shelf. Okay, so here we have the filter shelf. When you drag and drop any dimension into the filter shelf, that becomes, or that is known as a dimension filter. When you drag and drop any measure into the filter shelf, we call it as a measure filter. Okay, now you might wonder, what's the difference between a data source filter and a dimension filter? See, data source filter, if applied, all the worksheets will be able to display only that amount of data. Okay, whereas dimension filters are worksheet specific filters. See, now in this worksheet, I have category, let's say subcategory, and sales. Okay, so in this worksheet, only in this worksheet, I would like to apply a filter. I need only furniture related data. Okay, so this is a filter, this is a dimension filter applied on sheet number 1. Now in sheet number 2, this is in no way going to affect my sheet number 2. I will have all the 3 categories in sheet number 2. Okay, so dimension filters and measure filters are worksheet specific filters. In every single worksheet, you can separately apply a different dimension filter and a different measure filter. Okay, right. So now, see, when you drag and drop, let's have a simple chart. Okay, let's have subcategory and sales. So minute things that you may have to notice over here is, when I drag and drop any dimension into my worksheet, the values of that dimension are listed out in an alphabetical order. Okay, the values of that dimension are listed out in an alphabetical order. Okay, so now when I just pull in subcategory into my filter shelf. Okay, I'll drag and drop subcategory into my filter shelf. Your filter dialog box opens up. Okay, so this is how the dialog box, the filter dialog box, is going to be when you drag and drop any dimension into the worksheet. You will have 4 tabs: general, wildcard, condition, and the top tab. Okay, there'll be 4 tabs that would open up: general, wildcard, condition, and top tab. See, drag and drop segment or any dimension into the filter shelf. This is how 4 tabs would appear. All these radio buttons, everything will just be the same. Okay, so that's how a dimension filter dialog box would actually look like. So the options are pretty simple. See, when it comes to the general tab, you'll have select from the list. So from the list of subcategories that we have, you can simply uncheck the ones that you don't want. Click on apply. See, your worksheet will get affected, will get filtered once I click on apply. Okay, your accessories, as in the ones that you've unchecked, are filtered out from your worksheet space, right? The subcategories that that you had unchecked are simply removed from your worksheet space, right? Filtered out. Correct. Now if you would like to might be uncheck all the boxes. Okay, you needn't do it manually. You have these buttons over here. Check all the boxes at once or uncheck all the boxes at once. Okay, so these are just buttons to help us checking or unchecking these boxes. Okay, then you have a small exclude box over here. See, normally what happens if I check a box. Okay, checking a box means I need these subcategories in my worksheet. Only then I'll check the box. Okay, but to make it the other way around, you have to click the exclude button. Okay, if you don't want a particular subcategory, then check the box. Now, if I click on apply, all the subcategories apart from the first 5 would be brought into my worksheet. So that's how exclude works. It's just the other way around how normally we make the selection. We check or uncheck the boxes. Okay. Next, we have the radio button called custom value list. See, this was a list from which we were manually selecting, correct? Next radio button says custom value list. So you can just keep on adding, keep on creating your customized list, okay, based on which the subcategories would be displayed in your worksheet. So the list that you create should have values that belong to your data set. Okay, so that's how you create your own customized list. And then we have use all. Use all, see, I hope you remember when we were going through some of the sample dashboards in class 1, okay, we have options to make the dashboard interactive by giving this filtering option to the end users who make use of our dashboard. Correct? So that is when, as a developer, we can tell Tableau, just use all the options and let the end user apply the filter based on their requirement. So we call that as interactive filters or quick filters. So we'll see how to create them right after a few minutes once we are done with these, tabs over here. So that is when use all button would be used. Okay, so the general tab is just a tab where you will manually select the subcategories or select the values of your dimension that you would like to have in your worksheet or you would like to filter out from your worksheet. Okay, next we have the wildcard tab. Okay, wildcard tab is where you have a match value text box over here, and then you have 4 radio buttons. Contains, starts with, ends with, and exactly matches. Okay, so contains is where, let's say, I'll add a substring called AB. Okay, click on apply. So all the subcategories that contain this substring called AB will be displayed in our worksheet. Or if I say starts with, all the subcategories that start with P. So this match value box is not case sensitive. Okay, so I'll just enter P. So all the subcategories that start with P will be brought into my worksheet space. Okay, now all the subcategories that ends with, now if I say ends with ES, right? So all the subcategories that end with ES are brought into our worksheet space. Okay, and finally we have exactly matches, right? So I'll just type table. Okay, that's I've typed table. If I click on apply, what would happen? There's just a blank worksheet that we have, which means there's no subcategory that exactly matches with whatever I've typed in over here. Okay, we do have a subcategory called tables with an S in the end. Okay, so whatever you type in the match value box should exactly match with the subcategory name that we have in our data set. So that's how you perform a wildcard search using these options. Okay, and there's an exclude checkbox over here. So all the 4 options would turn the other way around. Turn the other way around in the sense it would turn negative. Does not contain, does not start with, does not end with, and does not match. Okay, so based on these options, you can perform a search. So enter something that does not contain whatever substring. Okay, so that's how the exclude button changes these options in a negative manner. Okay, and then clear button is to clear whatever you've typed inside the match value box. Okay, just clear my match value text box. Okay, and then you have another checkbox over here, include all values when empty. See, my match value box is empty. Yes, when I click on apply, what would happen is automatically all the subcategories are included in my worksheet space. Okay, so that's what it means, include all values when empty. Okay, next we have, in case you uncheck this box, what would happen is when my match value box is empty, exclude all the values. You'll just get a blank worksheet, all the values would be excluded. Okay, so that's about these check boxes. Then comes our condition tab. Okay, yeah, based on a specific condition. See, so far we've been either manually choosing values based on which a filter was applied, or using the wildcard search based on which a filter was applied. And then comes the condition tab. Based on a specific condition, you can apply a filter. Okay, right? And this becomes a generalized condition that you will use based on which data would be filtered. Okay, so we have the by field option, correct? So by field as in based on sum of sales, that's the measure we are using, right? So based on sum of sales, give me all the subcategories whose sum of sales is something greater than, let's say, 1 lakh. Okay, click on apply, and what would happen is your worksheet is going to display all the subcategories whose sales value is greater than 1 lakh. Okay, fine. Before we do this, I'll just make sure I'll add labels to my chart. Okay, so you have this particular tool in your toolbar known as show mark labels. Just click on it to label your chart, and let's also sort the subcategories in an ascending order or descending order based on their sum of sales. See, you have these two tools in the toolbar using which sorting becomes very easy. And you might wonder why a few bars are not labeled. What must be the reason? It's just because of lack of space and nothing else. Okay, you can simply again use these options in your toolbar. Just click on entire view so that the entire view in your worksheet space gets occupied. All the marks or all the bars will have enough space for labels as well. Okay, right. So now let's pull in subcategory into the filter shelf. Go back to the condition tab. So based on sum of sales, give me all the subcategories whose sum of sales is something greater than 1 lakh. Okay, click on apply, and you'll be able to see how only those subcategories whose sales value is greater than 1 lakh is displayed in our worksheet space. Okay, so you can apply any such generalized condition based on which a filter would be applied. Okay, now this range of values is a read-only box. If you're not sure, just click on load. If you're not sure, see, out of all the subcategories we have, the maximum sales value is 3,30,000, whereas the minimum sales value is 3,000 something. Okay, so based on this, you can decide, okay, what conditional value can I use for applying a filter is something you can decide. Okay, the same condition can be applied in terms of a formula as well. You just have to type in sum of sales should be greater than, or let's say lesser than, 50,000. Click on apply, and you get only those subcategories whose sales value is less than 50,000. Okay, so that's how you make use of the condition tab based on which filters are applied. Okay, either the by field option or the by formula option. Okay, and finally we have our top tab. See, moving into the top tab, by field, I would like to see the top or bottom. You in fact have two options over here. Give me the top 5 subcategories by sum of sales. Okay, I need the top 5 subcategories by sum of sales. Okay, so based on sum of sales, okay, the top highest sales and the corresponding subcategories would be displayed in our worksheet. Okay, right? Or you can also choose, let's say, bottom 3, the least 3 subcategories with sales would be brought into display. Okay, so that's how you have an option to pick 50, top 100, top uh, top 20. Okay, any number of top values and any number of bottom values can be picked up using the top tab. The same can be specified in terms of a formula. Give me the top 10 or the top 5 or the top 20 by sum of sales. Okay, right? So that is how you make use of the top tab, right? So these are the 4 different tabs when you drag and drop a dimension into the filter shelf. So that's how your dimension filter dialog box would look for when you drag and drop any dimension into the filter shelf. Okay. Okay, this is something that we as developers can make use of, correct? Now, the end users are not going to have access to the filter shelf or the filter dialog box and all that. Yes, so instead of we developers applying a filter and showing them the filter data, why can't we let them apply filters based on their requirement and interact with the dashboard or interact with the worksheet? Yes, because one user might want a few subcategory related information, whereas the other user might have a different idea or different perspective of analyzing the data, right? So instead of we as developers applying a filter, giving them or showing them the filtered data, why don't we make it interactive in nature? Why don't we add interactive filters that the end users can make use of? Okay, and just interact with the dashboard and analyze data based on their requirement itself, right? So for that, to make the end users apply the filter and interact with the dashboard based on their requirement, we can have quick filters or interactive filters in our worksheet. You can call it either way. It can be called as a quick filter or as an interactive filter. Let's see how to create it. Okay, we have our dimension over here called subcategory, right? You have the drop down arrow mark right next to it. Just click on this drop down arrow and you'll have an option called show filter. The second option says show filter. So click on show filter and that's it. You've created your interactive filter. So this is something the end user will be able to see, right? So the end user will have access to or will be able to make use of this interactive filter. So they can check or uncheck the boxes based on their requirement and filter whatever information is displayed inside the worksheet space. Okay. In fact, you have a lot of options in choosing how the interactive filter is supposed to look like. Okay, whether it should be a multi-select filter or it should be a single select filter, how should your interactive filter behave? We as developers have the complete freedom, or I would say we have all the options to customize how and how the interactive filter should look and behave for the end users usage. Okay, the client sometimes the client will specify this as well, that I need this kind of a filter where the end user is able to choose either multiple values or single values. All those customization will also be handed over to us in the requirement gathering session. by the stakeholders or the clients. Okay, right. So we'll see how to customize our interactive filter, right? So on the right top corner of your interactive filter, there's a drop down arrow mark. Okay, just click on it and you have a lot of options right here. Okay, the first option says edit filter. So when you click on edit filter, the filter dialog box opens up, and as I told you, the use all button has been chosen right here. Why use all? Because from the developer's perspective, we are not doing anything. We are not selecting from the list, or we are not applying a wildcard condition or a condition, based on which filtering is going to be done. We are telling Tableau to use all the values because the end user is going to apply filters. That's what edit filter tells us. Okay, then you have remove filter. If you no longer want a subcategory interactive filter, you can simply remove it from your worksheet. Okay, this dimension filter will be removed from the filter shell. Okay, then we have apply to worksheets. Now, yeah, this is our quick filter or interactive filter. And how did we create this? You have your dimension in the data pane, correct? Just click on the drop down arrow right next to it and then say show filter. Your interactive filter will be displayed. Okay. Yeah. The third option says apply to worksheets. Now this option is not going to be used as of now, but when you go into a dashboard space, a dashboard is nothing but a collection of worksheets, right? So that is when you can make a normal filter as a global filter using this particular option. So what's a global filter? One filter that is going to affect all the worksheets in your dashboard. That's what is known as a global filter. Okay, so 100%, 200%, we will come back to this particular option when we move into our dashboard space. So definitely we'll come back. Okay. Next, we have format. The basic formatting options like what should be the font, alignment for the title of my interactive filter. See, when you click on format, the left side space has a separate box, which is nothing but listing out the formatting options for the title and body of your interactive filter. Okay. Then we have customize. Now customize is nothing but, see, you have the all button over here. So with one click, you can either check or uncheck all the boxes, correct? Okay, if you feel there's no required, it's not actually required, you can remove the all value button. Or you can also add a show apply button, okay, where even if you keep unchecking the boxes, there's nothing that's happening to my worksheet. Why? Because once I've done all the checking and unchecking, only if I click on apply, these options or this particular filter will be affecting my worksheet. Okay, so that's about the show apply button that is added to our filter. You can just click on customize and add or remove that button. Okay, so all these options are very simple, right? Adding or having the title or not having the title can be decided by checking or unchecking this box. Then we have the edit title, where if you would like to edit the title, right now the default title is subcategory. You can just edit the title if required. Okay, next you have, this is the main part of this particular drop down list. Okay, how should your interactive filter behave? By default, it's a multiple value list using which the interactive filter is displayed in our worksheet, correct? See, right now it's a multiple value filter and it has a list of options from which you can multi-select. So multiple value list is what is created now. Okay, next you have multiple values drop down, right? So instead of having such a long list over here, which is occupying so much of space, you can make it as a multiple value drop down. Okay, it will still let you choose multiple values, but from a drop down list you can choose multiple values. So this is basically saving space in your worksheet. Okay, so that's about multiple value drop down. Then we have multiple value custom list. So using this multiple value custom list, the end user can create a customized list by typing in all the subcategory names as in the ones that they require. This is how they can create a multiple value custom list. So multiple value list, which are checkboxes. Multiple value drop down is nothing but a drop down which lets you choose multiple values, and this is where you can create a customized list. Okay, and on the other way around, we have options to create single value filters as well. Single value list, instead of check boxes, you will have radio buttons. Okay, so you can choose only one subcategory at any point of time. That is your radio button, single value list all about. Then we have single value drop down. Okay, you have a drop down from which multi-selection will not be possible. You can only select one particular value at a point of time. Okay, then we have single value slider. Okay, you just have a slider using which one subcategory can be picked at any point of time. Okay, so these are the different ways of displaying your interactive filters so that end users can make use of them and interact with a dashboard. Correct. And finally, we have the wildcard match. So if you remember the wildcard tab that we have in our filter dialog box, yes. So this specific interactive wildcard match behaves like the contains option. Okay, so I would like to see all the subcategories that contains the substring AB. You have tables and labels. Okay, so that's the kind of wildcard match box that has been created. Okay, so these are the different options using which you can display the interactive filter. Okay, so that end users can make use of it and interact with your worksheet or dashboard. Okay, then comes the next option known as only relevant values, all values in the database. You can toggle between these two, but what and where are they used for? Okay, there's a lovely example. It's in fact a very useful option. Okay, when you're making use of multiple filters, right? So using these options, we can create something known as cascading filters. Now this particular term, okay, called cascading. So now what did we just now create? A quick filter or an interactive filter or a user filter. See, you call this particular filter over here, you can call it as a user filter, quick filter, or interactive filter. You can use any one term, okay, because users can quickly apply a filter. So that's the reason we call it as a user filter or a quick filter. Users can interact through this filter with your worksheet, and that's why we call it as an interactive filter. Okay, fine. And next we have something called cascading filters. Okay, see, normally this particular type of filter is not often, when you look for interview questions, when you Google for, when you look into YouTube videos where they are explaining about filters in Tableau, it's not common that they mention about this particular type of filter. Okay, but such a filter does exist, and we'll see what's this cascading filter all about. And when you when asked about filters in an interview, if you try explaining or mentioning such terms, it would seem very interesting for the interviewer itself, because it's a very important and useful filter, but not often it is highlighted as one of the important type of filter or one of the important interview questions and all of that. Okay, so you can just use such catchy terms when you're answering questions in an interview. Okay, now cascading. Now, first of all, what's a cascading effect? It's like a wave effect. Okay, you make a change in one filter that would impact the other filters in your dashboard or worksheet. So it's a, rippling effect or a wave effect is what is known as a cascading filter. Okay, so we look into an example for that. Now, in our worksheet, let me add a field called category. Okay, so now we have category, which has a list of subcategories under it, and you have the corresponding sum of sales. Okay, now let's create an interactive filter, one for subcategory and one for category. Correct? So I have interactive filters created for category and subcategory. So now what will the end user do? Now the end user will look for, let's say they'll try to focus on only one particular category. Might be office supplies, okay, or let's say technology. Okay, so the end user only wants to focus on technology related data, and my worksheet is responding to it, is interacting with the user. It is displaying only technology related data. Now, till this, it works fine. But next, if you look into the subcategory interactive filter, what will we normally expect for? See, I already have technology related data. Only these four subcategories that actually belong to technology should be displayed in my subcategory filter. That's when it will seem as if my filter is working in relevance with my worksheet. Correct? You have phones, machines, accessories, and copiers. These are the four subcategories that belong to technology. And out of these four, might be my subcategory filter should let me apply a filter further. Correct? But instead of that, what is happening right now? My subcategory interactive filter is displaying the complete list of subcategories, though they do not belong to my worksheet right now. So this shows that there's no sync between my worksheet and my subcategory filter. It is not working in relevance with my worksheet. Okay, so what are you supposed to do? Just click on the drop down arrow of your subcategory interactive filter. Okay, and then see right now what's happening, it is displaying all the values in the database, but we don't want that to happen. We need only relevant values to be displayed in our subcategory filter. See, don't display all the values in the database, only display the relevant values is what we are telling the interactive filter. Okay, so when you click on this only relevant values, what would happen is, depending on your worksheet, okay, or depending on the selection that you make in your interactive category filter. See, if you need only furniture data is displayed in your worksheet, correct? And your subcategory filter now displays only those subcategories that fall under furniture. So now isn't it acting like a dependent filter? Correct? The values of my subcategory filter is dependent on the selection that you make in your category filter. It is working in sync with my worksheet, and now it seems meaningful, right? So we call this as a cascading filter. Why? Because based on the selection you make in one filter, the values are displayed in another filter. So it's like a cascade or waving effect based on which values are displayed. Okay, so that's how cascading filters are created. Okay, so that's about the only relevant values and all values in the database. Okay, then what else do we have? I'll remove category. Okay, next, what do we have? We have include values and exclude values. Include values, normally, how does it work? Unchecking something removes it from our worksheet, whereas checking a box means it is still displayed in our worksheet. But when you say exclude values, it just turns the other way around. If you check any box, that would be excluded from the worksheet. Okay, so that's about include and exclude values. And finally, hide card. If you no longer want your interactive filter to be displayed, you can simply hide it by clicking on hide card. Okay, so that's all about your dimension filter, right from the tabs that we have in our filter dialog box and how to create an interactive filter so that the end user can make use of it. Okay, these are the different options that you may have to know regarding the dimension filter. Okay, and very similar to this is our measure filter. You drag and drop a dimension into the filter shelf, that becomes a dimension filter. When you drag and drop a measure into the filter shelf, it becomes a measure filter. Okay, let's say we have sales, right? I'll drag and drop sales into the filter shelf. Okay, how do you want to filter on sales? You have different aggregation options, but our default aggregation is sum. So I'll just pick sum. Okay, I'll click on next. And here we have the filter dialog box for our measure. Okay, we have range of values. So you can see this is the minimum sales for a subcategory. This is the maximum sales for our subcategory. So you can choose or pick up a range. Give me only those subcategories whose sales value falls within the range 50,000 to 1 lakh. Okay, click on apply. You get only those subcategories whose sales value fall within the range 50,000 to 1 lakh. Okay, next we have the at least option. Okay, the at least option where it acts like the greater than symbol. Give me all the subcategories whose sales value is greater than 2 lakhs. Okay, so only those subcategories whose sales value is greater than 2 lakh is displayed. Okay, next we have the at most option, which acts like the greater than symbol. Give me all those subcategories, lesser than symbol, right? Give me all those subcategories whose sales value is less than 1,50,000. Okay, and finally we have our special tab. Special tab is nothing but this is the tab using which you can filter out the null values in your data. If you say all values, by default, all the values, null, non-null, all the values are displayed. If you particularly need only the non-null values, remove null values. Okay, this is what you will have to choose. Give me only the non-null values. Okay, right now we don't have any null values, but yes, this is how you filter them out. Or if you're planning to focus only on the null values, then choose the first option. Okay, so that's how you make use of the measure filter dialog box, which is very, very simple compared to our dimension filter dialog box, right? And just like how you create a dimension interactive filter, you can also create an interactive filter for measures as well. Correct? So you have your sales measure. Click on the drop down arrow right next to it and then say show filter. Okay. So you get a slider. The end user can interact with this and decide the subcategories that they would like to view in the worksheet space. So this becomes the interactive filter for a measure. Okay, so that was dimension filters and measure filters, the ones that come fourth and fifth in priority. Okay, dimension filters and measure filters. So now that you know what is a dimension filter and a measure filter, it will be very easy for us to discuss what is a context filter all about. Now, frankly speaking, this is a very rare filter that we make use of, and we don't prefer using this filter basically. The reason being, this filter, okay, this context filter will seems to be a little heavy, it pulls down the performance of your dashboard. Okay, so ways of optimizing or ways of improvising the speed of your dashboard. The first point or one of the important points would be avoid context filters. Okay, because context filters are a little heavy. It has it has a lot of it absorbs a lot of processing speed. Okay, it reduces the performance of your dashboard, so it's better to avoid context filters. But anyways, we have to know what's a context filter. If in case required, we have to make use of it. So let's discuss what a context filter is all about. Okay, right. So let's say we have a worksheet where there's the list of states in our data set, and you also have the list of cities under each state. Each state has a list of cities, and we have the corresponding sales. Okay, so now we have such a long list over here. Let's try to apply a filter and focus only on relevant information. Okay, now I would like to fetch only Texas related data. Okay, or let's do it the other way around. First, I would like to pick the top 5 cities based on their sum of sales. So I'll pull city into my filter shelf. I'll go into the top tab and I'll say I need only top 5 cities based on the sum of sales. Okay, click on apply, then click on OK. So these are the top 5 cities based on the sum of sales. Okay, right. So now 2 of them belong to California, New York, Pennsylvania, and Washington. These are the top 5 cities based on sum of sales. Okay, now I would like to drag and drop state into my worksheet. See, I am planning to focus only on Texas related data. Okay, so manually, what do we know from this, or manually, what are we expecting for? See, I would like to focus only on the state of Texas. So I need the top 5 cities that fall under Texas. But when I choose this state called Texas from the state filter and click on apply, what's happening is a blank sheet is what Tableau is giving me. So there's some confusion that's happening over here. Okay, the reason for this confusion is both your filters are dimension filters falling under the same priority. Correct? So Tableau is executing both of them at the same time. And what did you apply first? Your top 5 city filter. What was the result of it? It gave us top 5 cities. Okay, based on the sum of sales. And then you're telling Tableau that you need Texas related data. So none of the top 5 cities that Tableau picked from our data source were falling under Texas. Correct? So there's a contradict between the result of both your filters, and in the end, there's nothing for Tableau in hand to visualize. It just gives you a blank worksheet. Okay, this confusion, it actually arises very rarely, but still, for you to understand where exactly we make use of context filters, I'm trying to explain with this example. Okay, so now what was the confusion over here? The top 5 cities that we saw in our worksheet, none of them were belonging to Texas. So there's a contradict between the result of both your filters, and that's why you have a blank worksheet, because there's a clash or contradiction happening between the result of both your filters. So in order to give Tableau some clarity, or in order to explain Tableau what exactly we're expecting for, we have to prioritize one of these filters through which Tableau will understand, okay, I have to first pick up all the cities that belong to Texas, and from that I will have to choose the top 5 cities. This has to be conveyed to Tableau, right? So how will we convey this to Tableau? We will increase the priority of our state dimension filter, and by doing so Tableau will understand that it has to execute this first and only then execute the city filter. Okay, so as per the order of prioritization, we currently have both as dimension filters. Currently both are under 4th level of priority. Now what I'm going to do is I'm going to convert my state filter into a context filter. State filter, which is right now a dimension filter, is going to be converted into a context filter. Just click on add to context. If I do so, what would happen? My state filter will be converted to a context filter, which is having 3rd level of priority. So Tableau knows that context filters are higher in priority, so it will execute them first, and then on the result of my context filter, which is nothing but the cities that belong to Texas, the top 5 would be picked up and displayed in our worksheet. Okay, so this is how, when you have multiple dimension filters, to prioritize which filter has to be executed first. To convey this to Tableau, you will be adding one of them as context filters, through which Tableau will understand I have to execute the context filter first, and then on the result of my context filter, the city filter has to be applied. Okay, see, if you had applied, okay, you have your state, you have your city, and then you have your sales. So initially itself, if you had applied filters like first give me Texas data, it will give you the cities that belong to Texas, and now from this list of cities, give me the top 5 based on sum of sales. If this would have been your approach, then there would have been no confusion. Tableau is giving you exactly what you're looking for. But the confusion arose when you first applied your city filter and then applied your state filter. There was a contradiction between the result of both the filters, and Tableau was not able to give you what you were exactly looking for. And that was when we had to tell Tableau, by adding the state filter as a context filter, we did convey it to Tableau that please execute the state filter first, and then on the result of the state filter, execute the top 5 city filter. Okay, so this is not often used in a real-time scenario, but the way you can define, theoretically, when questions are put up in an interview about what is a context filter, you can define it theoretically as when you have multiple dimension filters, in order to prioritize among them, they all fall under the same priority level, right? So among them, prioritize which is to be executed first and which is to be executed next. Prioritization among them can happen with the help of this context option. Okay, so that is what is context filter all about. So these are the 5 different types of filters. We just have a few additional points that I've mentioned over here. I think a few of which we've already discussed. No matter in which order you apply the filter, Tableau will execute it in the above order. Okay, we already know that. No matter in which order you apply, Tableau follows its own fixed prioritization level of executing them. Correct? Then we have, I think this is just about an explanation about our extract filters and data source filters. Okay, extract filters will reduce the number of rows in your hyper file. Correct? Because if you have 4 different regions related data, and if you say I need only central region data in my hyper file, the number of rows is drastically reduced with which the hyper file is getting saved. Okay, that is what is extract filter. And this is a small task that I would like you to try it out or try out, and be right away if possible. Okay, so I want you to create a worksheet which is a region-wise colored subcategory sales data. Okay, and let me help you in creating this worksheet. Okay, we'll create this worksheet, but I want you to create an interactive filter which is going to at once let the end user view only one single region related data. Okay, I want you to create that kind of an interactive filter where the end user will be able to view only one region related data at any point of time. They'll not be able to view multi-regional data in the worksheet together. So that is the kind of filter. See, this is how the clients will tell you, this is the kind of interactive filter I need. Now, they will not know how to create such a filter in Tableau, but we will, we'll definitely know, right? So we'll have to make sure their requirement is satisfied with whatever options we have in hand. We'll have to explore and come up with a solution for it. Create a filter as per their requirement. So let me help you in creating the worksheet. Okay, so it's a subcategory wise sales chart. Okay, and our chart is going to be colored using the region dimension. So drag and drop region into the colored marks card. Okay, so this is how you have a colored a region wise colored subcategory and sales chart. Okay, now this is the chart you have. Now you are going to create an interactive filter which is going to let the end user view only one region related data at once. At once in the sense, I should have a filter where when I'm able to see central region data, I'll click on west, I'll be able to see only Western region data. I'll click on East, I'll be able to see only Eastern region. At any point, if I need both Central and Western region data together to be displayed in my worksheet, I will not be able to do that. So we are restricting the amount of data that is displayed to the end user, okay, using such filters. So you have to create such an interactive filter. Okay. Right, so our next topic would be about sets and bins. Okay, sets, bins, parameters, and actions. These are the 4 topics, rest of the 4 topics in module number 2. Okay, so let's start with sets and bins. Right, now sets and bins. Okay, now sets are nothing but sets are created under dimensions. Okay, sets are nothing but it's just a subset of your data which is linked to some condition. Correct? Let me give you an example. Let's say we have a class of 50 students. Okay, now we can have set 1, students with top 5 marks in a recent exam that was conducted. Okay, top 5 students. Okay, so this would become set 1. So top 5 students who belong to my class. Okay, it's a subset of my data. Okay, and what is the condition? They have secured the top 5 marks in the recent exam that was conducted. So this becomes a set. Okay, another example is nothing but we have a set of 10 students for a dance competition. Okay, so this also is a set, a subset of your data. Out of 50 students, the teacher has picked up 10 students to participate in a dance competition. Might be those students perform well or they are already going in for dance classes or something, right? So this is a subset of your data. And what is the condition? They dance well, okay, as per the teacher or from whatever the teacher knows. They are interested in dancing. So she or he has picked up 10 students out of 50 students in the class to participate in a dance competition. Correct? So this is what a set is all about. Okay, now we have different types of sets in Tableau. Starting with a constant set, As the name tells you, once created, even if the underlying data changes, the members of the set do not change. It's a manually created set. Okay, so constant set is manually created, and as the name tells you, once the set has been created, even if the underlying data changes, the members of the set do not change automatically. As in, manually, you can go edit the set, but automatic updates are not going to happen in the case of a constant set. Okay, it can be created across multiple dimensions. Now, an example of a constant set is this that we have created. Okay, this is an example of a constant set. Why we call it as a constant set? Because the teacher has picked up 10 students from the class to participate in a dance competition. Okay, this is a constant set. Okay, we'll see what's a computed set and then we'll compare the two. Why do we call it as a constant set and why do we call this as a computed set? When we compare, it'll be easy for us to, understand. So what's a computed set in contrast to a constant set? A computed set can be created only under one dimension. And the most important point is it is updating its members accordingly if any changes happen in the underlying data because it is linked to a generalized condition. Okay, now we call this as a computed set. Why? Now, how did we create this set? Based on the results of exam 1 that was conducted recently, the top 5 students, based on what the top 5 students are picked up, they had scored the highest marks, the top 5 marks in exam number 1. And that's how top 5 students were picked up and placed inside set 1. Okay, now after a couple of months, we get the results of exam number 2 that was conducted. Okay, now based on the results of exam number 2, do you think it would exactly be the same 5 students in set number 1 now? See, now based on the results of exam 2, we might have a shuffle. There might be students who, were previously not under top 5 in exam 1 may now have performed well and moved into top 5. So it's not necessary that it would exactly be the same top 5 students now as well. There's a change that's happened in my underlying data. The recent exam that was conducted, the result of these exams are out. Now, based on the changes in the result, okay, based on the latest results, we will have the top 5 students that would go inside set number 1. So there'll be an automatic update that is happening in the members of our set because of the changes in the underlying data. Okay, whereas you just think about this set of 10 students who have been picked up for a dance competition. Okay, now how was this set created? The teacher manually picked up 10 students from the class, okay, based on their interest or based on whatever the teacher had idea about the student, this particular student dances well and all of that. Based on that knowledge, manually 10 students were randomly picked up from the class to participate in the dance competition. Now, there are some changes in the underlying data. The results of exam number 2 are out. Okay, now is this result or is this underlying data, change in the underlying data or update in the underlying data, is anyway going to affect the members of my constant set or the members of the dance competition set? No, right? So no matter what the results are, what the score of these students are, these are the 10 set of students who will participate in the dance competition. No change in that. Okay, so that's the reason we call this as a constant set. Even if the underlying data changes, the members of the set do not change. So such a set that has been manually created is what we call as a constant set. And on the other hand, a set which is created based on some condition. What is the condition? top 5 marks of the exam. Okay, top 5 marks based on which students are picked up and placed inside the set. So in this case, depending on the change in the underlying data, the members of the set get updated automatically. Okay, so that's the difference, or that's how we differentiate between a constant set and a computed set. Now, how do we create these in Tableau? Now, first of all, what is the purpose of this particular feature or concept of sets? Normally, when we go in for presentation, okay, we make use of the sets. Okay, when you are presenting your analysis, when you're planning to highlight certain marks of observation in your analysis, you can create sets so that the audience will be able to focus on what exactly you are trying to explain, or what exactly, what's the exact observation that you've made is something that you can showcase through the creation of sets. Okay. Right, so let's go into Tableau and discuss how to create a constant set, and then let's see how to create a computed set. And after that, we'll come to the third point known as combined sets, or third type known as combined sets. Okay, right, so let me start with constant set first. Okay, so sets can be created only under dimensions. So let's have our subcategory wise sales. Okay. Right. Now, how do you create a constant set? A constant set can be created across multiple dimensions, and it is a manually created set. So let's first bring in multiple dimensions in our worksheet. So let's have category, then we have subcategories, might be I'll bring ship modes as well. Okay, so you have multiple dimensions and you are manually going to create a constant set. Okay, so from my observation, let's say, see, you can either click on your worksheet and drag to get this rectangular selection through which you can select marks. Okay, you can select marks, or you can click on a mark. Okay, it gets selected. Press Control in your keyboard and start multi-selecting. Okay, so these are the marks that I would like to push inside a set. Okay, now what I'll do is, once I'm done with the manual selection, place your cursor on any one of the selected mark and you'll get a pop-up on top of your tooltip. Okay, see, this is the tooltip, but when you wait for a second, there'll be a pop-up on top of your tooltip, correct? There you have a particular symbol which looks like this, two rings that are linked together. Okay, so when you click on this two rings linked together symbol, you will have an option to create a set. Just click on create set. So your constant set or your manual set is created. I'll call it as my constant set. Click on OK. Okay, so that's how your constant set has been created. Correct? Yes, we'll do it again. Just multi-select, just select marks from your worksheet. You can either click, drag, and select multiple marks, or press Control in your keyboard and keep selecting multiple marks. Okay, so once you've selected multiple marks, place your cursor on any one of the selected mark to get a pop-up, and in that pop-up, two rings that are linked with each other. Might be they look like, again, a Venn diagram. Okay, circles that are overlapping or intersecting. Yes, just click on it, and that's how you create a set. Okay, so we've created a set known as my constant set. This is the symbol using which sets are represented. This is a very common certification exam question. They'll give you the symbol, and they'll ask you, what does this represent? It represents a set in Tableau. Okay, so once your set has been created, drag and drop it into the colors marks card. This is something that we do when we are presenting our analysis. Okay, when you have your set that has been created, see, it's a manually created set, correct? We manually created it by picking marks or selecting marks from the worksheet, and it can be created across multiple dimensions. Yes, we have multiple dimensions and we've created our set. Okay, drag and drop it into the colors marks card, and what will happen is you will get something known as the in and out mode of the set. See, this is known as the color key or the color legend. It is the in and out mode of the set. Now, what is in and out mode of the set? The members that are inside my set are blue in color, whereas the members outside my set are gray in color. You can very well edit these colors. It's not necessary that they should always be blue and gray. Okay, just click on the color marks card, edit colors. For in, I need green. For out, I need red. Okay, you can use any palette from these to customize your colors, and this is how they will look like. Okay, but the default color would be blue and gray. Blue for the members inside the set, gray for the members outside the set. So when you go in for presentation, you can make the audience focus on the members inside the set. So the blue ones are inside the set. These are the special marks that I have observed, might be for the past 6 months, and I want the audience to focus on it. So I've created a set of these members. Okay, and I've just highlighted it in my worksheet. So when you go in for presentation, you can very well use the in and out mode of the set to let the end users or the audience focus on whichever marks you are trying to explain about. You're trying to explain about your observation in the analysis, right? So that's when you can create a constant set. Now, the very first point over here, once created, even if the underlying data changes, the members of the set do not change. What does this mean? So it might be after a couple of months, there'll be a data update that is happening. Okay, a data refresh that is happening. Might be the sales of these marks, of some of the marks are increasing, the sales of this particular mark is decreasing. Okay, that is in no way going to affect the members of my set. Just because there's a drastic increase or decrease in sales in the underlying data, it doesn't mean this particular mark will be removed or added to my set. No, they are in no way going to affect the members of my set. That is what it means. Okay, so a constant set is manually created. Even if the underlying data changes, the members of the set do not change. I have to manually go edit the set. See, in future, I feel I don't want this mark to be a part of my set. Okay, just click on it. Okay, click on the two intersecting circles and say remove from my constant set. So manually you can edit the set. Manually you can add or remove members from the set, but you cannot do that. I mean, it's not going to happen automatically because of changes in the underlying data. Okay, fine. So the next point is about computed set. I mean, this is all about constant set. So in contrast to this, you will have computed set, right? So computed set is where, what were the points under computed set? It can be created only under one dimension. So unlike a constant set, a computed set can be created only under one dimension. Okay, it updates its members accordingly if any changes in the data, because it is linked to a specific condition. So we look into that particular point. So we have our subcategory and sales. Okay, right? Yep. So how did we create a constant set? We were directly picking marks or choosing marks from the worksheet. But a computed set cannot be created like that. To create a computed set, you have to click on the drop down arrow right next to whichever dimension under which you're planning to create a computed set. So subcategory is the dimension of our choice now. So I'll click on the drop down arrow right next to it, go into create, and what are we creating? We are creating a set. Okay, click on create set. Your create set dialog box opens up. Now this dialog box looks very similar, right? Are you able to recollect where where we had an opportunity to look into a similar dialog box previously? General tab, custom tab, condition tab, top tab, and all of that, all these radio buttons. There was another dialog box that we discussed with similar options. It was the filter dialog box, if you remember, especially the dimension filter dialog box, which had these tabs. But the filter dialog box had 4 tabs, if you remember: general, wildcard, condition, and top. Correct? But over here, we have only 3 tabs: general, condition, and the top tab. Correct? So this, it's exactly the same. The options, the tabs, except the wildcard tab that is missing over here. All the others are just the same, like the one we had in our filter dialog box. Okay, so this is a create set dialog box. So we'll use the condition tab or the top tab directly. Okay, so condition tab is where I would like to create a set of subcategories whose sum of sales is greater than 1,50,000. So subcategory greater than 1,50,000 set. Okay. So what will happen? All the subcategories whose sales value is greater than 1,50,000 will be placed inside my set. Drag and drop it into the colors marks card. You'll get the in and out mode of the set, where clearly we are able to see that only those subcategories with a sales value greater than 1,50,000 are inside the set, whereas all the others are gray in color, which means they are outside the set. Okay, so this is how you create a computed set only under one specific dimension, which is linked to a generalized condition. What was the condition? Sum of sales should be greater than 1,50,000. Correct? And then what about this point? It updates its members accordingly if any changes in the data. What does this mean? See, now let's say after a couple of weeks, there's an update. There's, a new, let's say this particular month sales data has been released. So there's a refresh or update in our underlying data. Now, tables which initially had a sales value greater than 1,50,000, there's some drastic decrease in its sales. Tables has reached to a sales value which is something less than 1,50,000. So automatically tables would be removed from the set. It will become gray color. Why? Because it no longer satisfies the condition. So what was the generalized condition? Sum of sales should be greater than 1,50,000. So if it no longer has a sales greater than 1,50,000, then just remove it from the set. So automatic updation of the set is what would happen. Might be bookcases. Currently, it's not satisfying the condition. It has a sales less than 1,50,000, but might be after a couple of weeks when there's an update that's coming, it reaches to a sales value which is something greater than 1,50,000, and it would automatically be included or pushed inside the set. So an automatic update happens when there's a change in the underlying data. That's what a computed set is all about. Okay, so these are constant sets and computed sets. Both can be used. You can use the in and out mode of the set in both the cases. Just drag and drop it into the colors marks card. You'll get the in and out mode of the set. Okay. theoretically, I think, you'll be able to understand this concept, just like how there's an update in the sales value in our case. Okay. Now, in this case, top 5 students. Okay. The same thing you can do it over here as well. Instead of the condition tab, what you can do is click on subcategory create set, go into the top tab. For students, what will you do? Give me the top 5 students based on the marks. But over here, we'll say give me the top 5 subcategories based on the sum of sales. So you can call it as the top 5 subcategory set. Okay, click on OK. You have the top 5 subcategories set. Drag and drop it into the colors marks card, and you'll be able to see how the top 5 subcategories based on the sum of sales are inside the set, whereas all the others are outside. Might be when there's an update in the data. Suppose, let's say binders, is having a sales value something lesser than machines. So automatically machines would go into top 5 and binders will come down. It'll be removed from the set. So automatic update will happen in the set. Okay. That's how you create a computed set. Right. Yeah. So that was constant sets and combined sets. And finally, we have the third type. That was constant set and computed set. Finally, we have something known as combined sets. Okay. Sets created under the same dimensions can only be combined. So we have an example for this. Okay, so with that example, we'll discuss what a combined set is, in what way combined set is going to be helpful and useful. Okay, right. Suppose you are asked, okay, let's say for example, we have our customer names and their profit or sales. Let's pick profit this time. Okay, just for a change. Okay, so we do have customers with positive profit and negative profit. Okay, or might be in our next topics, upcoming topics, we'll pick up profit. Let's keep sales right here. So we have customer wise sales. Let's sort them out in a descending order. Okay, so these are the list of customers and their sales values. Okay. Fine. So now if the client is asking you to create a set of, or might be, let's say you are planning to go in for a presentation and you have to create a set of top 10 customers. How will you do it? Seems to be pretty easy, right? You'll get into customer name, click on the drop down arrow, create a set, straight away go into the top tab, top 10 customers by sum of sales. So this becomes my top 10 customers set, correct? So top 10 customers by sum of sales. Okay, so it's that easy. Top 10, a set of top 10 customers has been created. Okay, fine. Now, if there's a question about how will you create top 20 customers, that's also easy, just like how we did just now, right? Create set, go into the top tab, top 20 this time instead of top 10. So this is how you create your top 20 customers. Yes, easy, right? Top 50, same way. Top 100, same way. Yes, but if there's a question about create a set of top 11 to 20 customers, how are we going to do it? Okay, now what do we have? Let's go through the condition tab. Let's go through the top tab. Let's see if we have an option through which we can achieve this creation of top 11 to 20 customers. Okay, so this is by field. Now, based on sum of sales, I can use these conditional operators, enter a value, create a set of customers with sum of sales less than or greater than sales value is something that I can enter. Okay, and top tab is having, in fact, it's having both top and bottom, but it always starts from the topmost value or from the bottommost value. These are the two options we have. Create a set of customers. If it's top 100, starting from the topmost value, 100 customers are going to be placed inside my set. If I say bottom 10, starting from the bottommost value, the least 10 are going to be pushed inside my set. These are the only two options we have. But our requirement is to create a set of 11 to 20 customers. It's neither starting from the topmost value nor from the bottommost value. It's asking us to create a set of customers lying somewhere in between, correct? It should start from the top 11th customer. How do we tell Tableau, or how do we create this kind of a set in Tableau? Okay, so this is where our combined set is going to help us. Okay, so we are just going to combine our top 10 customers and top 20 customers in such a way that our resulting set will have top 11 to 20 customers. Okay, so we'll see how that can be achieved. All you have to do is, now these are the two sets that we are planning to combine, correct? Just click on the drop down arrow right next to any one set. It's okay. You can click on the drop down arrow right next to top 10 or top 20. That doesn't matter. Okay, just click on the drop down arrow mark right next to one of the two sets that you're planning to combine. Okay, and there you will have an option called create combined set. Just click on it and you have your combined set dialog box that would appear. Okay, let's name it. I'll be naming it as top 11 to 20 customers. Yes. Okay, next one. How would you like to combine the two sets? Now, top 20, this was, top 10 customers. This was the one from where I had clicked on create combined set. That's why it is already appearing over here. Okay. Now, coming back to this example, how would you like to combine the two sets? Now, first of all, what are the two sets we are planning to combine? Top 10 customers. Along with that, top 20 customers. See, now what was the condition to create a combined set? Sets created under the same dimensions can only be combined. Yes. First, we have our top 10 customers. Okay. Next, what is the other set? See, though we have our constant set, we have this subcategory greater than 1,50,000 set. We have the top 5. We have so many other sets, but why is only top 20 displayed over here? Because these are the only two sets created under the customer dimension. So what's the condition based on which two sets can be combined? Two sets created under the same dimension can only be combined, correct? So that's why you only have top 20 customers set in the list over here. Okay, so these are the two sets we are planning to combine. Now you have 4 options. Okay, how did we get this dialog box? Click on the drop down arrow mark of any one of these two sets that you're planning to combine together and click on create combined set. That's how you get this dialog box. Okay, let's name it as top 11 to 20 customers and we'll choose the two sets that we are planning to combine, and you have 4 radio buttons. I hope you remember, just like the 4 join types that we had. Okay, not exactly the same, I would say, but something similar to it. We again have these Venn diagrams, shaded part and all that. Okay, quite similar, but not exactly the same like how we had our join types. Okay, but yes, using these 4 buttons, we'll have to choose the best one, which is going to help us create a set of top 11 to 20 customers. Okay, now what do you think about the first option? If I use option number 1, can we get the output as expected? First option says all the members in both the sets. So if I'm going to include all the members in both the sets, will I get 11 to 20? No, we'll again get 1 to 20. That is not what we're looking for. What about second option? Shared members in both the sets, or I would say common members in both the sets. So what are the shared members in both the sets, or what are the common members in both the sets? See, top 10 customers will have 1 to 10 customers, right? Whereas top 20 will have 1 to 20 customers. So what are the shared or common members in both the sets? 1 to 10. So top 10 customers are present in both my sets. So they are the shared or common members. Correct? So is that what we are looking for? No. Okay, what about the third option? Top 10 customers except shared members. Now, if I use this option, what do you think will my combined set contain? Give me the members of top 10 except shared members. What are the shared members? 1 to 10 are the shared members. So give me the members of top 10 customers set except the shared members. So ultimately, if I use third option, there'll be nothing inside my combined set. Okay, it will just give me a blank set. Why? Because there's nothing else in top 10 customers if you exclude the shared members, which are the 1 to 10 customers. Okay, so that is also not the one will give us the result we are looking for, which leaves us with only the fourth option. Fourth is about give me the members of top 20 customers excluding the shared members. So from 1 to 20, if you exclude 1 to 10, what else remains? It's 11 to 20 that remains. Correct? So this is what we are looking for. So option number 4 will be the one that we have to make use of. Click on OK. Your top 11 to 20 customers has been created. Drag and drop it into the colors marks card to get the in and out mode of the set. See, you have your set that starts from the 11th member to the 20th member, or the top 11 to 20 customers that are pushed inside the set. Okay, so that's how you create your, that's how you make use of your combined set. Okay, now there's another question about how do we place. Now let's discuss about that particular point with subcategory wise sales. Now I would like to show the top 5 and bottom 5, or might be top 3 and bottom 3 subcategories in the same set. How will we do that? First, we'll have to create our top 3 subcategory set. Okay, top 3 subcategory set. Okay, similarly, create your bottom 3 subcategory set. Okay, now we will be combining these two sets in such a way. Okay, combining bottom 3 and top 3. I'll use the first option. Okay, I'll use the first option because I need all the members from both the sets to be in my combined set, right? So that would give you top 3 and bottom 3 in the same set. Okay, so using these 4 radio buttons, as in 4 Venn diagram like symbols, you will have to pick up the right one based on whatever your requirement is, based on whichever is satisfying and giving you the kind of output you're looking for. You will have to choose that particular option and combine your sets in such a manner to get the desired result. Okay, so that's about combined sets. Okay, so this concept of set itself is just meant for dimensions. Then what about measures? Can we I mean, do we have such options for measures? Yes, we definitely have. And that is what is known as bins. Okay. Frequently, now it depends, all three sets, I mean, computed sets are used very frequently, but again, it depends on our requirement. Okay. We equally use all the three sets in real-time scenarios, but computed is one step higher. Computed and combined are one step higher when compared to constant sets. Okay. But yes, all the three are equally important, equally useful, depending on the scenario, right? Then comes our concept of bins. Okay. Now, bins are nothing but a process through which you bin or bucket your data. See, now it was pretty easy for dimensions, right? Dimensions are discrete in nature, they are finite or countable in nature, so it was easy to split them into multiple sets. You have a class of 50 students, pick 10 from them, place them into the dance competition set. Might be pick another 5 students and send them to a quiz competition. So it was easy for us to split the members into multiple sets as they were countable and discrete in nature. But when you look into measures are continuous in nature. They have infinite number of elements under them. Okay, so splitting them will be easy with the concept of bins. Okay, so I'll give you an example. Suppose you have 5 bottles of water. Okay, you can very easily give it to 5 people. That's easy, to distribute. Okay, but instead, if you have a tank with 100 liters of water, how will you distribute? You need some medium through which you can distribute it. Okay, you need a bucket, or you need a bottle, or you need a glass, or you need a bin through which you can distribute the water to n number of people. Correct? So when you have 100 liters of water, there are two terms, or two basic, two aspects that you will be in need of in order to smooth out the distribution process. One is how many bins or buckets, how many bins do you require? Bins or bottles or buckets all just mean the same. Okay, how many bins do we require, and what should be the capacity of each bin? Okay, these are the two things that you will require in order to smooth out, or basically perform the distribution process. Okay, now if I am giving you, let's say, 5 bins, okay, in order to distribute 100 liters of water, what should be the size of each bin? It should be of 20 liters capacity. Okay, if this is the case, will you be able to distribute 100 liters of water? Yes, right? So in 5 bins, each of 20-liter capacity, you will just, transfer the water and distribute it. Yes? Or if I give you 4 bins, each bin of 25-liter capacity, again, it'll be easy for you to bin is like a bucket or a container. I mean, it's just our imagination. Okay, bin is nothing but a container, a vessel, a bucket. Okay, binning is also known as bucketing. Yes, so you can have it that way. Okay, so this is how you will distribute the measure values, because measures are continuous in nature. So what are two things you'll have to look for? How many bins and what is the capacity of each bin? Okay, at least one of it is something that you should know. So if I tell you I'll give you 5 bins, then you should say, okay, if you're giving me 5 bins, make sure the size of each bin, the capacity of each bin is 20 liters. Only then I can distribute my 100 liters of water. Okay, so these are the two things we'll have to remember. One is number of bins, and the next one is the capacity or size of each bin. Let's call it as size of each bins and number of bins. These are the two things we will have to think about. Okay. Yes. So now Tableau is going to help us out. Okay, there's in fact, now, I mean, in this case, it was easy, right? 100 liters of water. So it was very easy for us to distribute it among the bins and the capacity of each bin that we have in hand. But when you look into the data set that we have measures like sales, profit, or might be cost. Okay, different KPIs that we'll be working with. KPIs are nothing but key performance indicators. Might be in real-time scenarios, you'll come across this term very often, and it will seem as if it's a technical term that we are not aware of. Okay, so key performance indicators are nothing but the measures that you have in your data set. It's nothing new. It's just the way we refer to the measures in our data. So if you look into a sales dashboard, what is the key performance indicator of your sales dashboard? It'll either be your sales measure or your profit measure. Okay. If you get into domains like supply chain, you'll have a lot of key performance indicators like on time delivery, or might be minimum order quantity. What should be the minimum order for someone to you know send an order out or deliver a particular product, okay, or accept an order? These are the different measures which is going to literally decide the performance or indicate the performance of your organization. That's why we call them as key performance indicators. It's not, I mean, it's nothing new. It's just in general referring to the measures that you have in your data source. Okay, right. So in as we say, I mean, as we just now discussed, in our data source or in any data source, you will have measures like sales, profit with different values, might be high values, which are decimal, which is having decimal values and all of that. It'll be difficult to handle, right? It's not this easy to distribute it among n number of bins and the size of each bin being proportionate. It will be difficult for us to find out the number of bins and size of bins. Okay, so for that, Tableau is definitely going to help us out. There's some formula that's involved, using which the size of the bin and the number of bins are calculated. But Tableau is doing all this in the back end. We needn't uh, substitute the values in the formula, calculate and find out the result. But let's see how Tableau does it. Okay. Yeah. So how do we create a bin, or how do we understand? First of all, why do we create a bin? To understand how the measure values, okay, are distributed within our data source. Now you have sales as a measure. How is it distributed, within our data source? Correct? That's the concept of creating bins, or I mean bins for fields under measures. Okay. Right. So we have our sales as a measure. Now, how did we create a set? Click on the drop down arrow right next to your dimension, create a set. This is how you create a set. Okay. So for now, sales is our measure. Click on the drop down arrow right next to it. Again, go into create, and the third option over here is bins. So exactly the third option under dimension was set, but the same thing for measures would be bins. Okay. So let's click on create bins for the sales measure. You get your edit bin dialog box that appears. Okay. So edit bin dialog box, the name of your bin, you can name it. And then comes the size of the bin. See, Tableau is suggesting us the bin size. So based on the data that we have in hand, okay, Tableau is suggesting us a bin size. Now, how did Tableau suggest this? There's a formula in the backend based on which Tableau is just giving us a suggestion. So you can very well go change the bin size according to your requirement. Okay, that's up to us. But first of all, let's see how Tableau is suggesting the bin size. Okay, so it makes use of a formula that says size of the bin is equal to max minus minimum divided by number of bins. Now, first of all, what is max? What is minimum? Okay, you have these 4 boxes over here, which are read-only in nature, giving us the values of min and max. Okay, so now from where did it pick up the min and max value? From our sales measure. Okay, if you go into the data source page and if you look into our column called sales, you'll be able to find a row which is having a minimum value of 0. You'll be able to find a row which has the maximum sales value of 22,638. Diff is nothing but the difference between your max and min. Okay. And then you have CNTD. CNTD stands for count distinct. Okay. Now, what's the total number of rows that we have in our data source? 9,994. Correct? Count distinct is nothing but how many distinct values of sales do we have in our data source? That is count distinct. Let me give you an example. There's a difference between count and count distinct. Okay? Count distinct. Right? Now, let's say we have might be customers who are visiting our store. Okay, since morning, it's already evening. So since morning, we've been having customers visiting our store. So customer IDs go like 04, 05, 02, 01, 02. Again, the same customer is revisiting the store again. Okay. Now, these are the list of customers, list of customer IDs who visited our store and made orders since morning. So if I'm asking you for the count of customer ID, what will be the value? You'll simply count 1, 2, 3, 4, 5, 6, 7, 8. 8 will be the count of customer ID. But instead of count, if we are using count distinct, what will be the answer? You will skip the duplicates in this case and give us, exactly. You'll give me only the distinct values. So it will be 1, 2, 3, 4, 5 because the others are repeated. Okay. So 5 will become count distinct. So in the same manner, this CNTD or count distinct over here is telling us there are out of 9,994 rows of data in Superstore, you have 6,144 rows with unique values or distinct value of sales. Okay. See, we cannot go count this manually. It's going to be time consuming and tedious and all of that, right? So Tableau is helping us out with all of this, and it is substituting these values in the formula that we have here. Okay, it is substituting the values. So we know what's max, we know what is min, and then it is divided by the number of bins. And there, again, you have a formula for number of bins. 3 plus log base 2 of n multiplied by log of n. What is n over here? N is nothing but the count distinct number of rows for that particular measure. So we have all the values. Tableau is substituting all of these values and straight away giving us the size of the bin based on the data that we have in hand. So that's how it came across the value of 447. Okay, size of the bin. Now we needn't, see, we're not going to use this formula anywhere, or we're not going to substitute the values and find the size of the bin anywhere throughout the whole process. But this is just for your information purpose. If at all you would like to know what's happening in the back end. So this is the formula that is being used in the back end. And again, just for your information purpose, but we are not literally going to use it anywhere as such. Okay. Right. So yeah, so that's how Tableau is suggesting the bin size. So now we know the backstory, but it's not necessary that we have to use exactly the size of bin that was suggested by Tableau. We can come up with, we can make use of our own bin size. I'll use 1,000 as the bin size. Okay, and I'll click on OK. So what are we creating? We are creating a bin for the sales measure. And surprisingly, the sales bin that we just now created went into dimensions. It is blue in color. Why is that? See, our measure is green in color, is continuous in nature. But after creating a bin for the measure, the binned measure went into dimensions. It became discrete in nature. How is that, or why is that? See, going back to our water example over here, you have 100 liters of water, which is continuous in nature, which will be green in color, which is a measure. Okay. But after distributing these 100 liters of water into 5 bins, isn't this countable or discrete in nature now? Why can't we consider this as a dimension? It's countable in nature. It's finite in nature. It is now in a discrete manner so that we can easily distribute it to 5 people, correct? So the same concept, if you have a measure which is continuous in nature, after binning or bucketing the measure, you are binning or bucketing the measure into countable number of bins, which becomes finite in nature, which becomes discrete in nature. So a binned measure, this is just a measure, but this is a binned or bucketed measure, which becomes discrete in nature, which becomes a dimension. Okay, so yeah, that's how you create a bin. Okay, now the next challenge is to understand what exactly it is trying to convey. Okay, so if you look into it for the first time, it might be a little confusing, but let me explain. Okay, I'll bring my sales bin into the column shelf, and I'll bring my sales measure into the row shelf, and we get this is the kind of output we get. Now, what is it actually trying to convey? Or how do we read the data? What do we understand from this kind of a visualization? Okay, so this is about binning our data. We are binned or bucketed our sales measure. Okay, so these are the number of bins. Okay, we have the 0K bin, we have the 1K bin, 2K bin. These are the buckets. Just imagine these are the containers into which we are, distributing our measure values. Okay, what's the size of the bin that we picked up? 1000 is the size of our bin. Okay, so now 0K bin has a value of 13,07,032. Now, what is this value all about? From where did it come? 13,07,032 is the sales value, correct? So how did this sales value go into 0K bin? Very simple. Let's go into our data source page. Okay, scroll to the rightmost part of your table and just check for the sales column and your sales bin column. Okay, so every row which is having a sales value falling in the range 0 to 1000. Why 0 to 1000? Because 1000 is the size of our bin, correct? So every single row which is having a sales value falling in the range 0 to 1000 will be picked up, summed up together, and pushed into our 0K bin. So the sum of all the values falling in the range 0 to 1000 comes up to 13,07,032. See, you can just check these two columns. Okay, see all the values that fall under every single sales value that is falling under 0 to 1000 is picked up and pushed into the 0K bin. Okay, now what's our bin size? 1000 is our bin size. Yes, so if you look into this value, it falls in the range 1001 to 2000. See, the way our bins are distributed, 0, 0 to 1000, 1001 to 2000, 2001 to 3000. This is how our bin size is 1000, and this is how our bins are created. This is my 0K bin. Okay, this is my 1K bin. This is my 2K bin. This is how your bins are created, because 1000 is the bin size that we entered while creating the sales bin. Okay, so now into 0K bin, what is going to go into the 0K bin? All the sales value that falls in the range 0 to 1000. Okay, yeah. If you look into this column, all the values, each and every row, it checks the sales value in each and every row. If it is falling in the range 0 to 1000, push it into the 0K bin. This is a sales value into which range it falls, 1001 to 2000. So push it into 1K bin. That's why it's pushed into the 1K bin. So as you scroll down, might be, yes, exactly, it is summing them up together. This is also falling in the 1K bin. So what would happen? This is pushed into 1K bin, then that would be summed up with this value, which is also going into 1K bin. Okay, whereas this is falling in the range 3001 to 4000. That would be our 3K bin. So it's pushed into the 3K bin. So in this manner, every single value is checked as in which range it falls into. Depending on that, they are pushed into the bin that we have over here, bins that we have over here. Okay, so from this, we are able to understand that most of the rows in our table has a sales value falling in the range 0 to 1000. Whereas my 15K bin is empty. What does it mean? There's not even one single row in our data source which is having a sales value falling in the range 15,001 to 16,000. There's not even one single row that falls, that has a sales value falling in this particular range. Similarly, see, you have certain empty bins, which means there's not even one single row which has a sales value falling in that particular range. So this is how the water example was pretty simple, but that's how we started discussing about what is binning or bucketing all about. But when you apply it with measures like sales and profit, this is how they are actually distributed among the bins, depending on the size of the bin that you choose while creating a bin. Okay, so 1000 was our bin size. You can also try using 2000 as your bin size or 5000 as your bin size, based on which the sales values would be distributed. Okay, right. Yeah, so that was, can you sales into 3 steps? 3 steps, you mean to say creating a bin? It all depends on the size of the bin that you choose. I can also go ahead with 5000 as my bin size. Okay. Yeah. So what would happen? All the sales values falling in the range 0 to 5000 will be picked up and pushed into the 0K bin. All the sales values. Okay. Right. So that was all about bins. Okay.
Just a quick info, guys. Intellipaat offers a Tableau course. Through this course, you will learn various techniques like connecting to data, transforming data, working with calculations and expressions, visualizing data, and much more from the top industry experts. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth.
And now moving into parameters, right? Now parameters are one of the interactive features that we have, right? The definition or the way we define parameters is about dynamic values that replace the constant values, correct? So the ultimate goal of creating Tableau dashboards is to let people analyze data based on their requirement. Now, having a static dashboard, okay, using which they are not able to analyze whatever they are trying to focus on, there's no point in having such a static dashboard, right? So that's why we try to make the dashboard as interactive as possible so that anyone from any perspective can analyze data using such interactive features. And one of those features that we had discussed is about filters, the most important of all the features that we have. Next, we also have parameters, which is considered to be an equally important feature in making your dashboard interactive, right? So, I mean, what does a parameter do? Wherever we make use of constant values, okay, with help of parameters, we can replace those constant values with dynamic values, okay? The user can feed in whatever value they are in need of based on which the dashboard is going to give the results, right? So isn't that, and I mean, isn't that making our dashboard extremely interactive, right? So let's look into an example. And we have the first two, right? Parameter with filters, parameter with sets and bins. Okay, so it's quite limited as in the way we can use parameter with filters, sets, or bins. But the most widely used method of incorporating parameters in your dashboard is through calculated fields. Okay, so in calculations, we make use of parameters where constant value can be replaced by dynamic values, because of which the output that is displayed in our dashboard is going to be dynamic in nature based on the user's input that is fed into the calculation, right? So we look into examples for each, starting with parameter with filters. Okay, so we already know what a filter does. It lets us focus only on relevant information. It narrows down the data, letting us focus only on relevant information, right? So where exactly can we make use of parameters inside a filter dialog box? So if you remember, there are 4 tabs in our dimension filter dialog box, correct? The general tab, wildcard, condition, and the top tab. Okay, so inside the top tab, you have a particular space. I'll just create a small chart with subcategory and sales. Okay, I'll just swap these pills between rows and columns because I would like to have a horizontal bar chart. Okay, you have the tool over here known as swap rows and columns. With just one click, you will have all the fields that were into rows moved into columns and vice versa. Okay, I'll sort them out in a descending order. Okay, right. So now I'll drag and drop subcategory into the filter dialog box. So I hope you're able to recollect all this, right? The way we make use of filters. Yes. So when you drag and drop your dimension into the filter dialog box, into the filter shelf, you will have the filter dialog box for that dimension that opens up with 4 tabs: general, wildcard, condition, and top. Okay. If you go into the top tab, right, that's where we normally enter some value. Give me top 10 customers, or give me top 20 customers, give me top 100 products, right? So there's some constant value. Now, only developers, as in only we developers of the dashboard, will have access to this dialog box, correct? The end user will not be able to open up the dialog box, and suppose they are planning to see top 50 products or top 50 subcategories. They'll not be able to come here, edit the number, okay, so that the worksheet is displaying top 50 subcategories. They'll not have access, or they'll not be able to open these dialog boxes, correct? So that is where, there's some interactivity that's missing. Okay, so what we can do is, instead of we developers entering a constant value over here, we'll be creating a parameter, and through the parameters, we will be letting the end users enter values. Okay, so we'll see how that works. Now, instead of entering a value manually, I will go create a parameter. Okay, now there are multiple ways of creating a parameter. You can either get into the filter dialog box and then click on create new parameter. Okay, this will open up your, go into the top tab. Okay, so instead of entering the constant value, you can simply create a new parameter, or you can create a new parameter by clicking on the drop down arrow mark here. Okay, the second option says create parameter. Just click on it. Your create parameter dialog box opens up. Okay, so we'll go through the points one by one. So you can name your parameter. How shall we name this parameter? Let's call it as top n. Now, why am I naming it as top n? Because n, top 10, top 20, we don't know what n value is going to be. That depends on the user. Okay, so top n is going to be the name of my parameter, and we would like it to be of an integer data type, right? Just like how our columns have data types assigned by Tableau, you can also assign data types to parameters while creating them. Okay, so what kind of input this parameter is going to expect from the end user? Okay, is it going to be of a string data type or an integer, date and time, float, and so on, right? So we'll start with integer because in our case, it's going to be top n, and n is never going to be a float or a string value. It's always going to be an integer. Okay, then comes the display format. Okay, if you would like to have a currency format or a percentage format, we'll go through them one by one. But as of now, the basics: name your parameter, make sure it is of an appropriate data type. Okay, and then these two again we'll come back. The most important part is the three radio buttons that we have over here: all, list, and range. Okay, we'll start with range. Now I am going to create a slider. Okay, I'll tell you once we finish, you'll be able to see. Now there are a total of 17 subcategories in my data set, right? So I'll have a maximum of 17 because the end user can view a maximum of 17 subcategories because we don't have anything else apart from that. Okay, so or if you want, you can also have it as 20. Might be in future there'll be one or two subcategories newly launched. Okay, so that's when you can come change this value, or as of now we'll have it as 20. So this is how you enter the values and create your parameter. We'll slowly see, we'll complete this example. It might be during the next examples, you will slowly start getting clarity. Okay, I'll click on OK. So as you can see, there's a separate space allotted for parameters. Okay, so all the parameters that you create will be listed out right here in your left bottom space, okay, of the data pane. This is our top n parameter, correct? Now what we'll do is we are going to drag subcategory into the filter shelf, go into the top tab. Instead of entering a constant value, I will replace this constant value with a parameter. Okay, so top n parameter is going to be used right here. I'll click on OK. Okay, now how will the end user decide the parameter value? Like, for filters, we had check boxes, drop down menus, radio buttons. Okay, but how is the end user going to decide the parameter value? So for that, you just have to click on the drop down arrow next to your parameter name and say show parameter. Okay, now this show parameter slider that we have is something like a remote control that you have in hand. Okay, so using this, and we call this as the parameter control. You can just compare it with your remote control, your television's remote control. Okay, now through this parameter control, the end user will be able to control or decide the parameter value. Correct? See, as an end user, what we'll do is using the slider, let's say I need top 5 subcategories. So what's happening? The moment you fix the slider value as 5, this value is directly going into the dialog box. Okay, 5 is going to be placed over here. Okay, right, and you get the top 5 subcategories right here. Okay, yes. Why phones came first? Because as per because initially by default the parameter value was set as 1. Okay, when we created the parameter, the value, the current value was 1. That's why the moment you tried using the parameter over here in the filter dialog box, the initial value while creating the parameter itself was 1, top 1. Okay, so that's why only top 1 subcategory was brought into display. That's the subcategory with highest sales. Okay, that's why phones was displayed. Okay, so depending on the slider value you set or the end user is going to set, that value would directly come into the dialog box. Okay, so I mean, now the definition will have a justification, right? Instead of a constant value, we are replacing that constant value with a dynamic value with the help of this parameter. Okay, so isn't this parameter increasing the interactivity of your dashboard? Correct? Yes, so the end user, though they don't have access to the dialog box of your filter, yet using the parameter, they are able to dynamically decide how many top subcategories are to be filtered and displayed in the worksheet with the help of this parameter. Okay, so this is one example of how a parameter can be used inside the filter shelf. Okay, inside the filter dialog box. The top tab is where you can make use of your parameter. Now, the next point that we have is parameter with sets and bins. See, similarly, the set dialog box, create set dialog box that we have, isn't it similar to our filter dialog box? The only difference is the wildcard tab is missing, right? So I hope you remember that. When we go into our create set dialog box, there'll be general, condition, and the top tab. So again, in the top tab, exactly right here, instead of entering a constant value, you can simply replace it with your parameter. If you want, you can create a new parameter for this. But I feel top N is again going to suit the requirement we have. How many top subcategories we are going to push inside the set. Okay, so I'll name it as top N subcategory set, and N is a value that would be dynamically decided by the end user. So all you have to do is replace that constant value using, yes, you're creating a set using parameter, correct? Because previously what we used to do, push top 10 customers into the set. So we call it as the top 10 subcategory set. It's static in nature, right? But now with parameters, we are creating a dynamic set. See, I'll drag and drop it into the colors marks card. I'll just show the parameter control. What's the parameter value right now? 5. Okay, that's why 5 subcategories, the top 5 are inside the set. Okay, you can just increase or decrease it dependingly to push those many top subcategories inside the set, whereas all the others would be outside, right? So both in the filter dialog box and in the set dialog box, the top tab is where you can use your parameter, the constant value being replaced by dynamic values. Yes, you can very well change the colors. Click on the color marks card. Okay, edit colors, and you can choose any palette from this. Or if you feel the color you're specifically looking for is not available in any of these palettes, you can go, just double click on, let's say instead of blue, I would like to see, I have the RGB or hex codes for a particular color that my organization is looking for. Organizations have themed colors, have themes, or they have specific colors that will match the theme. Okay, so they feel the dashboard, the colors used in the dashboard should also match the theme of our organization is what sometimes, they prefer. And they'll give you the codes, specific hex codes or RGB codes for the colors they are looking for, which you may not find in the readily available palettes. Okay, so in that case, you just have to double click on this color box. Okay, you have options to enter these values or hex codes, HTML or hex codes, RGB codes. Okay, you can just enter them, or you can manually choose the color from these customization box over here. Or if you need some of the basic colors, you can choose from them. Okay, click on OK, and that's how you change your color. Okay, both for in and out, you can change the colors, right? Yes, so that's how So I hope, slowly you're trying to understand what exactly a parameter is doing. Wherever you have a constant value, replace it with dynamic values. These dynamic values are going to be fed by the end users through your parameter control. So that's the remote control using which the end user is deciding the parameter value, based on which it goes into the filter dialog box. The top tab, that's where it goes, the value that we decide with the parameter control. It goes into the dialog box and it's being used, to decide how many top values are to be either pushed into the set or filtered out, depending on whichever dialog box you make use of it. Okay, so that's about parameter with sets. Similarly, while creating a bin, okay, suppose I'm creating a sales bin. What is something that we add as a constant value over here? The bin size, right? We use a constant value of 1000 or 500 or 5000, whatever value. But instead of that, let's make it dynamic. Okay, you can create a new parameter. Okay, the stop n will not be, we cannot use that over here because it has only a maximum of 20. The slider, see, the slider that we have has a minimum value of 1 and a maximum value of 20. How is the slider having minimum 1 and maximum 20? Because while creating the parameter, we were the ones who entered the minimum and maximum value based on which our slider has been created. Okay, so everything is under our control. We can customize everything and create these parameters based on our requirement. Okay, so bin size is something that we normally enter as a constant value, but why should we do that? Why can't we leave it to the end users? So instead of entering a constant value, you can replace it with a parameter. Okay, so see, let's first create a parameter for that. We have a similar question in the assignments as well. Okay, we can have a max to 50. Is there any limit? No limit as such. You can have any minimum, any maximum value, no limit at all. But in relevance with whatever data we are using, we usually try to, limit the values. Now in this case, see, we know we have only a maximum of 17 subcategories in our data sets. But if I'm going to give the maximum slider value as 1000, then it will not seem relevant, right? My data set is only having 17 subcategories, but with this, with this long slider range, with such a long range, it doesn't seem meaningful, right? So depending on whichever column you are using or whichever data set you're using, based on that, we can decide the maximum value, but Tableau is in no way limiting us from choosing the minimum or maximum values. Okay, right. So creating your sales dynamic bin, let's first create a parameter. I'll name it as dynamic bin size. Okay, and I would like it to be of an integer data type. I'll create a slider with minimum value of, let's say, 500. Okay, at any point, the end user will be able to create a bin which is minimum of 500 as size. Okay, so these restrictions is something that we can, the client will tell us, okay, create this kind of a parameter such that the end users, should be able to, this should be the minimum bin size they'll be able to create. Okay, maximum, let's have it as 5000. Okay, and there's something called step size also. Step size is nothing but your minimum value is 500. What would be the next value in your slider? What would be the step size? The jump between any two values in your slider is nothing but the step size. Let me tell you. Let's have a step size of 100. Okay. So now when you just show the parameter control, see, this is how it would look like. My minimum value is 500, maximum value is 5000, and as we make use of these arrow buttons over here, the jump between this value and the next value would be 100. Okay, so it jumps, the slider value jumps in terms of hundreds. Okay, if you give 500 as the step size, my first value would be 500, the next jump would be 1000, 1500, 2000. Okay, that is what step size is about. So your parameter is ready. Let's create a bin. Instead of constant value, I'm using my parameter over here. Click on OK. Your bin has been created. Okay, and depending on whatever value you choose, your bin size is going to dynamically differ, right? So that's how you make your dashboard interactive. Any constant value that you have can be replaced with dynamic values with the help of your parameter. And this concept of constant values being replaced by dynamic values is done using this feature called parameters. Okay, so it's parameters are all equally important in making the dashboard interactive. Okay, so these were the first 2 points. Okay, you have certain, a closed space over here. We have to, okay, it's not, I mean, you can create your parameter, and where are you going to make use of it? Okay, right here. Yes, see, I've created my bin size parameter. Where or which constant value you would like to replace with dynamic values, there you will have to make use of the parameter, correct? See, while creating my bin, when I was creating my bin, I normally enter a dynamic value over here. Okay, I mean, I normally enter a static value over here, but instead of that, I'm using my parameter. I'm letting the end users enter a value based on which the bin size is being decided. The reason why 0 is high, I think that was the concept of bins, right? So now what does it mean? It's a sales bin that we've created, right? So if you go into your data source and check for every single row, the sales value of every single row, okay, the first bin, all the sales values that fall within the range 0 to 1500 will be summed up together and pushed into your 0 bin. That's why it has the highest value, because most of the orders in Superstore is made within the range 1000 to 500. I mean 0 to 1500. Right? The concept of bins is just the same, just like how we discussed in our, yes, exactly, last class, right? But the size of the bin is something that we are dynamically letting the end users decide. Okay, so when we were using parameter with fill, exactly 1500 to 3000 will be the second one. 3001 to 4500 would be the second one. Okay, that way. The second, I mean the third or the fourth one. It just goes on in terms of 1500. Yes. Yeah, so using parameter inside the filter dialog box, particularly in the top tab. Using parameter inside the set dialog box, particularly in the top tab. Using parameters inside the bin dialog box to dynamically decide the bin size, correct? So you have certain points, limited spaces where you can make use of these parameters. But the most widely used method is using parameters in calculations. Okay, let's look into an example for that. Parameter in calculations. Okay, so this is the most widely used method because there are specific spaces inside these dialog box only where parameters can be used, but this is the most commonly used method of using parameters. So let's look into one or two interesting examples, simple ones, because I want you to get the concept. Okay, so the examples would be simple, but they'll clearly tell you what a parameter is actually trying to do, in what way it is trying to make our dashboard interactive. Okay, yes, so parameter in calculations. Now, first of all, I'll create a simple chart and I'll tell you, in this case, why are we trying to make use of parameters. I'll make sure the entire view in my worksheet space is occupied. Sort it out in a descending order, and let's also label our chart. Okay, now I'm planning to categorize these subcategories into the ones with high sales and the ones with low sales. Okay, so that I can identify these subcategories are always having high sales, or as per the data we have, these subcategories have high sales, these subcategories have low sales. Okay, so I would like to categorize them. So let's see how are we going to do it. So we'll be creating a very small and simple calculation for that. Okay, so click on the drop down arrow mark in your data pane right below your data source name. Click on create calculated field. Okay, so this is known as our calculation box, or in Tableau we specifically call it as a calculated field. Okay, so Tableau there's no need for any coding knowledge in order to work with Tableau, because Tableau has, or it gives you the complete list of available functions and calculations. See, this is alphabetically arranged. All the inbuilt functions are listed out. You also have the syntax, a small description of what this particular function does, and also an example that you can have a look at. So it completely lets us learn, okay, how the syntax is supposed to be, what it does, and with an example as well. So you can just go through these whenever you have time. Not necessary that you have to be by heart with all the inbuilt functions right away. Okay, that's definitely not possible, and it's not expected as well. So on the go, as you come across situations and scenarios where you have to make use of a particular function, you'll gradually get familiar with them. So there's nothing worry. Okay, we don't need to know code. Yes, but it's not always that we write codes in Tableau, and it's not always lengthy codes that we write. Yes, the basic if else function or the case function, or might be a running total. These are some of the basic ones. See, every project differs, or every dashboard requirement differs from each other, but in most cases it is just the basic functions and calculations are enough. And again, I mean, the reason I told you there's no need for any coding knowledge is you have everything that's available within Tableau itself. So if you are in need of a function that should round off your values, okay, so you can just go through the number related function. Okay, you might find something called ceiling, and there's something called floor. It rounds the number to the nearest integer of equal or greater value. So this is how you can explore and get whatever you are looking for. The reason I told you is you needn't be aware, okay, that aware of these functions beforehand. So you can manage with the readily available ones in Tableau, because Tableau is just having all the information that we are in need of, and we can manage, okay, with whatever we have in Tableau, right? So, and see, the most important part is about visualization, right? But not necessarily huge calculations. Not every project, I would say, will require, I mean, I would say at least 70% is not going to ask you to create lengthy codes in Tableau. Okay, but again, it differs from project to project. If your data is not performed enough ETL work, sometimes they ask you to create those columns in Tableau, or create those functions in Tableau. So it depends. It just depends. From a general perspective, this is what we have. Okay. Right. Anyway, so we'll start with a very simple calculation known as high versus low. I'm naming it as high versus low. Okay. So it's a very basic if else function. Okay. So if my sum of, yeah, so my condition, okay, there's a particular condition based on which I'm categorizing my subcategories. Okay, so if my sum of sales is something greater than, let's say, 50,000, then let's call all those subcategories as high sales. Okay, else let's call them as low sales. Now, what does this mean? If the sum of sales, okay, the values that we have here, is anything greater than 50,000, then let's label all those subcategories as high sales. Otherwise, if there's any subcategory whose sales value is lesser than or equal to 50,000, Okay, let's label them as low sales. So this is my if condition statement, or one single line of code using the if then else function. Okay, and even if you miss out, if you make some mistakes in the syntax, Tableau will help you out in understanding where exactly the error is, how to debug it, and so on. Okay, so if everything is fine, it would say the calculation is valid, right? Now let's create this calculation. Okay, and we have it as high versus low. Now we'll just drag and drop it into the colors marks card. So when I drag and drop it into the colors marks card, what would happen? All the subcategories that satisfy the condition will be labeled as high sales. Okay, and all the others that do not satisfy the condition. What was the condition? Sum of sales greater than 50,000, right? If they don't satisfy the condition, they'll be labeled as low sales. Okay. You can very well change the colors. Yes, I'll open up the calculated field box again. I would like to have green for high sales and this pink or red for low sales. Okay. Yeah. So what was our line of code? If sum of sales is greater than 50,000, then high sales, else low sales. Okay. So each label, high sales is given a unique color, low sales is given a unique color because we had dragged and dropped this calculated field into the colors marks card. Okay, right. So now this is categorizing my subcategories based on a condition. What was the condition? Sum of sales greater than 50,000. But this seems to be static in nature, right? This 50,000 value might be some end users will not be ready to accept this as the constant value based on which my subcategories are getting categorized, right? They might have a different perspective of analyzing the data, or they would like to use a different value in order to categorize the subcategories, correct? So to summarize what's happening over here, there's some kind of constant value that is being used. Okay, so this makes my chart static in nature, but I want my chart to be interactive in nature. I don't want a constant value to be used, but instead I would like to use dynamic values over here. So how do we do that change from constant value to dynamic value? With the help of parameters. So we'll first have to create a parameter for that. Okay, so step one, create a parameter. I'll name it as, let's say, limit value. Okay, the limit value is the name of my parameter, and it's going to be of an integer data type. I'm again creating a slider. Now, how do we decide the minimum and maximum values over here? Using whatever data we have. Let's have a minimum value of 1,000 and might be maximum value of 4 lakhs. Because right now the maximum value that I have is 3,30,000. Okay, so let's make it 4 lakhs and a step size of 500, or you can also have a step size of 1,000, right? So that is going to help us create our parameter. Let's show the parameter control. See, 1,000 is my first value. The next jump would be 2,000, 3,000, and so on. Okay, the maximum value would be 4 lakhs, right? Okay, the slider has been created, but I'm changing the value in my slider, but why isn't my worksheet responding to it? Correct? I'm trying to set different values in my parameter control, but my worksheet is no way responding to it. It's still static in nature. What is the reason for that? See, now what did we just do? We've just created a parameter, right? Have we used the parameter anywhere, or have we linked the parameter with our worksheet through anything? Not yet, correct? So there's this line that would, that's always very important. There's no point in just creating a parameter. You will have to link your parameter with the worksheet. And how do we do that? Through a calculated field. Yes, see, point one, we've created a parameter. Yes, let's use that. Okay, I'll go into my calculated field. I'm using my parameter in the calculated field. I'm removing the constant value and I'm entering my parameter right here. I'm replacing that constant value with a parameter. This was step number 2. Okay. Step 1, create your parameter. Step 2, use it inside a calculated field. And step 3, bring that calculated field into the worksheet space. So that's when the circuit gets completed. The connection gets completed, right? There's no point in just creating a parameter. We will have to link it with our worksheet through a calculated field. And that's when, see, right now 1000 is my parameter value. So as per the condition, all the subcategories with sum of sales greater than 1000 will be high sales. Okay, let's just change it to 88,000, or might be I'll change it to 1,70,000. So now what happens? All the subcategories with sales. So this value would go into my calculated field dynamically, decide the condition based on which subcategories are categorized as high sales and low sales. Okay, so that's how it works. And now, as you can see, a change that we make in the parameter control, our worksheet is responding to it because the parameter has been linked with the worksheet through a calculated field. Okay, right? See, now directly dragging and dropping your parameter. I mean, you might had this question, why can't I drag my parameter directly into the color marks card? I mean, there's actually no point in doing it because this calculation has some categorization, correct? Right? So normally what we do is we don't directly drag and drop parameters into the worksheet, but we do it through a calculated field so that our calculation is affected based on the values that the user decide. Okay, so that's how it works. Okay, so now this is how we define a parameter. Wherever you have a constant value, we replace it with dynamic values. Okay, I'll give you another example. Okay, yes, I mean, just like how you have your interactive filters, this is something the end user will be able to use in our dashboard, right? Similarly, this is also something, this parameter control is something that the end user can use to enter value. Okay, so it acts like a remote control through which they can decide the parameter value. Similarly, they have these drop down menus or check boxes. What are they? I mean, what are we going to let them do through these check boxes or drop down menus? To filter the value in the worksheet, right? So they're able to interact with the dashboard and filter, focus on whatever they are in need of. That's the work of a filter. Similarly, the work of a parameter control is to get the values from the end user, change the parameter value accordingly. The result of my calculation would change and that would be displayed in our worksheet. Okay, so both are letting the end users interact with our dashboard, which is our objective. That's the whole reason why we use Tableau dashboards, right? Because of its interactivity. So might be a person who is analyzing it now will have a limit value as 180, who's interested to see how it looks like if they increase the value. Okay, so that's the reason why we have our dashboards that are interactive in nature with the help of these features. Okay, so far we've been creating only integer data type parameters, but let's create one string data type parameter. And this example is, okay, this is your problem statement, or this is how the client will tell you. So what's a parameter? Constant values being replaced by dynamic values. That's the definition of a parameter. So the client is coming and this is the way they will let you know about what exactly the requirement is verbally. Okay, so they'll tell you that I would like to have a chart where a chart which is having one dimension and one measure. Okay, might be state-wise sales or country-wise profit. Okay, that's how normally a basic bar chart is created, right? So they'll tell you, I want the end user themselves to choose the dimension and measure using which the bar chart in the worksheet is supposed to be created. Okay. One user would like to see state-wise profit. The other user would like to see ship mode-wise sales. Okay. So it's not a value inside my calculation that should be made dynamic, but the fields that we use in the worksheet, the fields to build my chart itself should be dynamic in nature. Okay, so how do we proceed, or how do we create such a dynamic chart? So far, we've been replacing constant values with dynamic values through parameters, but over here, the dimension and measure, the columns used in the worksheet itself should be made dynamic. Anything that should be made dynamic, anything constant that should be made dynamic can be achieved with the help of these parameters. Okay, so this involves the creation of, I think, two parameters and two calculated fields, one for dimension, one for measure. Okay, the process is not that complicated, I would say. It might be, now listening to the problem statement, it might seem as if it's complicated and all that, but it's very simple. Okay, and once you look into the finished product or the output, how we've, it'll be very interesting and it'll seem very easy actually. Okay, let's start doing it now. Point one, we need two parameters, right? So using one parameter, the user will decide the dimension. Using another parameter, the user will decide the measure. Okay, so two parameters are required. One is going to be named as choose a dimension. Let's make it user friendly and readable, right? So naming your parameters are also very important because the end user should be able to understand what this parameter is asking them to enter, what value it is asking them to enter, right? So choose a dimension. It is going to be of a string data type, correct? Because all our dimension or column names are string in nature. Okay, so choose the data type as string. Let's go create a list. Why create a list? Because I am going to display a list of dimension names from which the user is going to select one. Okay, so I'll start entering the names of my dimensions. We'll it, then we'll have city, then we'll have ship mode. Okay, as of now, we'll stop with around 3 to 4, but you can just enter all the dimension values, names that you have, okay, when you're actually creating a solution for this problem statement. Okay, now we're just looking into a small example. So I'll stop with 3 or 4. Okay, and segment. Okay, you can keep on entering there's no limit. You can keep on entering your dimension names, right? So that becomes my first parameter. Let's see how the parameter control looks like. It's a simple drop-down menu from which the end user can choose the dimension. Okay. Parameter number 1 is ready. Parameter number 2 is going to be a measure. Okay. It would be of a string data type again, a list that we are creating with sales, then quantity, okay, the measures that we have in our data set, and then might be profit, and you can just keep on adding all the KPIs or measures that you have in your data set. Okay, click on OK. So that becomes my second parameter. First one is choose a dimension from this list over here, and the next one is choose a measure from this list. So based on whatever dimension and measure the end user is choosing, the bar chart will change accordingly. Okay, right. So first half of our work is done. We've created two parameters. Now, how are we going to link these parameters with our worksheet? Through a calculated field, right? Which means we will have to create two calculated fields, one for dimension, one for measure. Okay, so I'll go create a calculated field and let's call it as dynamic dimension. Okay, let's call it as dynamic dimension. And what kind of function are we going to make use over here? Okay, we are going to make use of a case function, right? Now, what's a case function about? You can just type case. Okay, and when you type case, you will have the function. This F over here is representing functions. Okay, click on it and you'll be able to get the syntax, a small description with an example of what it does. Okay, so see, in scenario, I mean, in certain cases, you can come up, you can solve this problem either using a case function, or sometimes you can also use. So see, I mean, the same problem can be solved using a case function or using a if then else function. Okay, so I'll tell you what's a case function. So in the case, okay, yeah. So in the case, now we are creating a calculation for our dynamic dimension. Okay, so we have a parameter called choose a dimension, correct? So in the case of my parameter called choose a dimension, what is supposed to happen, right? So I'll first write the complete code and I'll explain it I mean, in the form of a story, okay? Of literally, verbally, I'll explain it, what's actually the flow of the function, okay? So what do we know about choose a dimension parameter? What are the values? You have state, city, ship mode, and segment. See, these are the values of your parameter, correct? So I'm telling the calculated field over here. In the case of this parameter, when the user is clicking on state, okay, from the drop down menu over here. So in the case of our parameter called choose a dimension, when the user clicks on state, see, we have the drop down menu over here, right? So when the user clicks on state, what should the calculation do? When state, then pull the state column from my data source. Okay, so we are directing the parameter value. Okay, whenever the user clicks on a parameter value, go pull this particular column into the worksheet. So this is what we are trying to say. When the user clicks on segment, then pull the segment column. Okay, when the user clicks on ship mode, then pull the ship mode column. Okay, and you just have to do this for all the values of your parameter. What else? I think we have city, right? So when the user clicks on city, then go pull the city column from my data source. And finally, you just end this. This is how your case function works. So in the case of my parameter, when the user clicks on state, pull the state column. When the user clicks on segment, pull the segment column. So this is how you direct the calculation as of what is supposed to be done when the user is clicking on each of these parameter values. Okay, so that sums up my first calculated field. Okay, in the next one, okay, the next calculated field is going to be named as choose a measure. I mean, not choose a measure, but a dynamic measure is going to be the name of my calculated field. And what would be again, it's the same case function, right? So in the case of my choose a measure parameter, what is supposed to happen? When the user clicks on sales, then pull the sales column. Okay. When the user clicks on quantity, then pull the quantity column. When the user clicks on profit, so no matter how many measures or dimensions you have, you just have to keep doing the same thing. When the user clicks on this column, this particular value, pull the appropriate column. Okay, and we finally end it. Okay, so I mean, this is not exactly an SQL query that it's using, because SQL query is all about select statements and all that, right? But this is not any language it is using, but we have functions that are inbuilt. Okay, so the syntax of the function will remain the same no matter what language is it, right? So if, then, else, end. So even in Python, we have the same thing. If condition, then this is the first result, or else this is the result. So the functions are just the same, but no specific language. I mean, we just use the functions as such. There's no other language that is involved, like the select statements or the update, delete, and all of those things are not used over here. Okay. Yeah, so this becomes our second calculated field, and we are done. We've created two parameters. We used those parameters into calculated fields. What else? Just bring those two calculated fields into our worksheet. So my dimension goes into, okay, rows. I'll place it into rows. Okay, and then I'll place my dynamic measure into columns, right? So now what are we actually viewing? State-wise sales. I would like to see city-wise. I'll just sort them out in the descending order, okay? City-wise profit, okay? See, profit has positive profit and negative profit. That's why your graph or axis looks like this. Okay, suppose I would like to see segment-wise quantity. Okay, so dynamically, the dimension and measure in the worksheet itself can be decided by the end user. Now, ship mode versus sales. Okay, it just says null over here. It's supposed to display the 4 different ship modes, right? First class, second class, standard class, same day. But it's just giving me as a null over here. What must be the issue? See, parameters are case sensitive. Okay, that's a very important point we have to remember. Parameters are case sensitive. So just compare. See, I'll open up the calculated field first. So when ship mode, then ship mode. Bring the column called ship mode. So if you compare the value between your calculated field and your parameter, I'm using a lowercase m over here for ship mode, whereas it's an uppercase m over here. So parameters are case sensitive. Okay, so whatever value you enter here should exactly match with the value that you enter in your calculated field. Okay, so we either have to change it over here in our parameter as uppercase m, or change it in your calculated field as lowercase m. Only then there'll be a perfect match that would be created. And now you get the result as expected. Okay, so parameters are case sensitive. That's why I wantedly added an uppercase and lowercase m here and there to highlight this particular point. Okay, so that's what a parameter does. That's how we define a parameter. Wherever you have constant values, replace them with dynamic values. Okay, so yeah, that's about parameters. Okay, and finally we have actions. Okay, so actions are also interactive features, equally important, and this is one of the most interesting topics, I would say. Very colorful, very fun to work with, very interesting. Okay, and we have 6 different types of actions in Tableau. Let's look into each of them with a detailed example. Okay, so action, there are 6 different types. Okay, so action by filter, action by highlight, action go to URL, go to sheet, change parameter action, change set values. Okay, so previously, as until version 2019 of Tableau, or 2018, okay, Tableau version, now we are in 2024 or 2025 version, right? So in 2018 or 2019 versions, we only had 3 different action types, but since then we've been having 6 different action types, which is making our dashboard interactive in nature. Okay, right, so starting with action by filter. See, slowly, we already know what a filter does, but action by filter, what does it mean? So we are slowly diving deep into the topics, okay, where multiple features are going to be merged. hereafter. See, there's something I normally, uh, first we need to create a parameter, then write the calculation. Yes, exactly. Or you can also write your calculation just like how we did in this case. See over here, we first wrote our calculation and then we thought it was static in nature, after which we decided we created a parameter. We went back into our calculated field and simply replaced our constant value with a parameter. So either way would do. Both would anyways give you the same result. Either create your parameter first, then create your calculation, or write your calculation, create your parameter. After that, come back to the calculation and simply replace your constant value with a parameter. Okay, both ways would work. Okay, right. So yeah, to continue with this, there's something that I always feel is we are currently, we I mean the process how we learn anything new is we first start with a alphabets. Okay, we learn those alphabets just like how we've learned any language. We start with the basics, right? So we start with alphabets and then we combine those alphabets to form words and then combine those words to form sentences and then paragraphs and so on, right? So the same thing is happening over here. We are discussing about each individual feature first, getting familiar with them, and gradually we'll be combining multiple features, okay, and see how the worksheet works, how it is being interactive and all that. And then gradually we'll move into the dashboard creation where you'll be putting all your skills over there, showcase all your skills, use all the features that combine everything together to finally build your interactive dashboard. Okay, so we've already, we are already familiar with most of the features, and now comes a new feature called actions, where the concept of filter is also there, but with something new that you're going to learn. Okay, so action by filter is nothing but use the data from one view to filter data in another. So far, how have we been filtering data? Using quick filters or using interactive filters, those check boxes, radio buttons, and drop down menus. Correct? But now this action is all about use the data from one view to filter data in another. Okay, right. Let's look into an example for this. And for that, I may have to, gradually start moving into the dashboard space, because that's where I can explain about using data from one view to filter data in another. Okay, so we'll do it slowly. Just because we are going into a dashboard, you needn't panic, or you needn't think about, okay, dashboard is something that we haven't seen so far. So how are we going to manage with dashboard space related stuff and all that? We'll be coming back to modules where we'll be discussing all about dashboards and stories in detail. But now to explain about this action by filter, we may have to go into a dashboard space. Okay, right. So first I'll create sheet number 6, which is going to be category wise sales. Okay. A very simple chart is what we'll start with. This is sheet number 6, and then I'm going into sheet number 7, where we'll have category, subcategory. Okay, I'll have them into columns. Okay, category, subcategory, and then sales. These are the two charts that we've created. One is category-wise sales, and the other one is category, subcategory-wise sales. Okay. Now, let's go into a dashboard space. See, actions can be applied directly on your worksheet, and then that worksheet can be taken into a dashboard, or go build your dashboard and then apply your action. See, either way it would work the same, right? Like the properties we have for addition. 3 plus 5 or 5 plus 3 anyways is going to be 8. Similarly, create your worksheet, apply the action, then take the actioned worksheet into the dashboard, or first go build your dashboard, then apply action on it. So result will be the same. Okay.
Just a quick info, guys. Intellipaat offers a Tableau course. Through this course, you will learn various techniques like connecting to data, transforming data, working with calculations and expressions, visualizing data, and much more from the top industry experts. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth.